Hello guys, Kurti is here, and this video is about some basic facts on the Ergo protocol. And let's start with Bitcoin. So I assume that you have some knowledge on Bitcoin. And let me start with what was new in the Bitcoin protocol from my personal point of view. So in the first place, Bitcoin is about a blockchain. So a decentralized replicated database, and this database is done via cryptographically chained blocks which carry transactions. So a lot of materials available on blockchain technology, so I'm going to skip details. So in the second place, Bitcoin is known as digital gold. So under some assumptions, it's a perfectly scarce digital resource. Why? Because emission is limited, and even more, currently about 90% of all the bitcoins already minted. And in the second place, like gold mining, Bitcoin mining is very expensive, especially these days. So you need to spend a lot of electricity to mine bitcoins, right? So then under certain assumptions, cryptographic ones, and also some assumptions on majority of miners being honest and so on, so protocol properties, Bitcoin is even better store of value than gold. Okay, so it's not an unconditional statement, right? So there are some assumptions, but at least they are very formal, very well understood, even more understood likely than gold properties, right? Especially if you can understand cryptography and protocols design. And yeah, then if you do understand these assumptions, then and if the assumptions hold, then Bitcoin is indeed even better than gold in regards with its scarcity. Alright, and also Bitcoin is about programmable money. Alright, so before Bitcoin and other cryptocurrencies, so each coin or each banknote had the same contract, right? Usually given in national laws, right? And usually most of users do not quite understand those rules, right? And in opposite, in case of Bitcoin, each digital coin, right, or digital banknote maybe, has individual contract, and this contract is given in very precise form of computer code. Alright, and in simplest case, this contract is as follows, right? So it's just requiring a signature corresponding to some public key, and also spanning transaction bytes. But we can have more complex contracts. And now it's your own freedom, right, to make banknotes with contracts you want, right? And you can interact with your counterparties via those contracts. Alright, and then what about Ergo? So Ergo is following the first principles of Bitcoin, stated formally or informally. So in the first place, Ergo is conservative store of value proof of work cryptocurrency. So it's permissionless, open, and it's more powerful than Bitcoin in regards with every aspect of its design, because now we have more knowledge So decentralization is still the main principle we follow, and we develop further the principle of programmable money. Right. So now it's possible to have different monies even within the blockchain. So it's about DeFi, decentralized finance, right? But also even more powerful concepts are possible. So you can think about different sub-protocols on top of the Ergo protocols as of different contractual monies which are interacting with each other. So it's a kind of economic environment even for concepts like DeFi or even more complex. Alright, and there is a long-term focus in regards with Ergo development. Right, so we are thinking about how to make the protocol which is survivable in the long term. Okay, so basically we are following first principles of Bitcoin again. But Ergo is designed and implemented from scratch with knowledge and observations which Satoshi didn't have. Right, and how we are following, how we are implementing the protocol technically. So in the first place, Ergo is about proof of work. Why proof of work? So this is a popular question in the community. So proof of work is widely studied and tested. So proof of work protocols have high and well understood security guarantees. Proof of work is permissionless. Well, at least in theory, everyone can buy hardware and mine. Right. Well, in practice, this is also the case. So maybe not so all the places around the globe have low electricity prices, right? But if you're living in such a place, then you can buy some ASIC miner and mine Bitcoin still. And the same is true for other proof of work cryptocurrencies, even more true. Alright, so then you have light validation also in opposite to other proof of somewhat. Alright, and we are using a very classic proof of work blockchain scheme. So Ergo is not doing hybrid protocol like proof of work plus proof of stake or proof of work plus masternodes or whatever. So no more complex structures than just blockchain used, like DEX or Ghost protocol, which was half implemented in Ethereum with no clear outcome. Alright, because of that, security is simple. And then we can increase throughput via sub-block protocols like Bitcoin NG or Flux. There are some other protocols published. So such protocols preserving security of Bitcoin blockchain, right? But also adding higher throughput. Right, without the need to use complex techniques or hybrid blockchains with unclear security guarantees. Okay, then Ergo is very focused about freedom of participation. So if Bitcoin community is pushing be your own bank agenda, but to be your own bank, you need to run full nodes, and it's pretty painful these days. Right, so most of users are running light clients, and light clients also far from perfect in Bitcoin and Ethereum and other proof of work cryptocurrencies. Right, then Ergo is significantly improving in regards with few aspects. So in the first place, Ergo is supporting non-interactive proofs of proof of work. And this allows to synchronize with the network and be a light client by downloading less than 1 megabyte of data, less than 100 kilobytes, usually in practice. That means you can run light nodes on mobile devices, very efficient ones. But also it's possible to be full node, so be your own bank without storing the current state of the system, so-called UTXO set, so a set of unspent coins. So if you are running a non-mining node, you can have full node security guarantees and do that with Raspberry Pi even. So there are some full nodes on the network which are running on Raspberry Pi with just 1 gig of RAM, and Ergo node is taking just half of it. So far so good, and we consider that a user should be free to choose one mode of operation or another. Right, so we are trying to deliver the most secure mode of operations and do them efficiently. Okay, and it's up to user after all how exactly user will run its own bank. Okay, and then the very new approach in regards with smart contracts is there. So we spent a lot of time on reworking smart contracts. So what was the motivation? So we did aim for safe contracts, right? So for the users and also for the blockchain in regards with blockchain bloat. So scalability issues, again, very painful. So contracts should be easily templatizable because in most cases users don't need to write a lot of new code. They just need to change certain parameters, so add multi-sig, for example, so few signatures needed instead of one in some contract already published or something like that. So yeah, then templates are very useful. And also we need to enforce somehow to do minimum things on the chain, because it's very expensive to do complex things on the chain. Right, so most of the work, most of the logic should be off-chain, and then only certain checks which are very needed must be executed on the trust computer, so on the blockchain. Okay, so contractual layer should be friendly to simple and safe higher-level languages, which are suitable for ordinary developers. Right, so definitely we need to have more powerful contractual layer than in Bitcoin, because well, most of startups which try to do something on top of Bitcoin, like crowdfunding platform Lighthouse or local currencies platform Kolu, so on, so on. So they failed, so they switched to other blockchains. Okay. So we need to support variety of cryptographic protocols. So there were a lot of proposals published for Bitcoin to include threshold signatures, ring signatures, and so on, so on. Right. So usually it's not possible in case of Bitcoin. So then a lot of forks arisen but if we can have some generic support for a variety of cryptographic protocols in the core, then there is no need to fork the main chain. Alright, and definitely what's needed these days is to support custom tokens and financial applications, because tokenization is everywhere, and blockchain is very helpful about that. Okay, so then what Ergo is doing, so it's preserving Bitcoin-like UTXO model with one-time coins to be spent and created on each transaction executed. So instead of some fixed signature scheme, we have some flexible non-interactive zero-knowledge proof scheme called generalized Schnorr proofs, also known as Sigma protocol. So in the simplest case, such Schnorr proofs are about Schnorr signature, which is coming to Bitcoin, which is good, by the way, for interoperability. But also because of generalized Schnorr proofs being used, we have native support for ring signatures, threshold signatures, and such signatures are really ring and threshold signatures, so they preserve zero-knowledge properties. So from observing signature on-chain, for example, in case of ring signature, so you don't know who was an actual signer, so you see only the ring. Okay, and also there is support for native custom tokens. So custom tokens are first-class citizens on the Ergo blockchain, so you can issue a token easily. Alright. Then we are changing Bitcoin terminology a little bit. So this one-time coin, which is created by transaction and then been fully destroyed by a follow-up transaction. So in Ergo it's called box, right? And then you can describe current state of the Ergo blockchain as a set of boxes not destroyed yet. Right, and why we are talking about boxes? Because in addition to just X, so monetary value, box may contain up to 10 registers with monetary value, scripts, custom tokens, information about transaction which created the box, and also additional data provided by user. Right, so there are 4 mandatory registers, up to 4, with predefined semantics, and then user may add up to 6 registers with application specific data. Right, so to spend a box you need to provide some spending proof, which is about signature, and potentially also some additional input data, which may help in unlocking specific locking condition. Right, so for example I can create box which is protecting by condition like show me number x, such as 2 plus 2 is equals to x. Right, and then to spend such a box protected with such statement, you need to provide number 4, right, in additional inputs. And actually no signature is needed in this case. Alright, and also we allow for complicated scripts, and most of possibilities are coming not from the scripts even, so not from the scripting language, which is more powerful than in Bitcoin, but still not so powerful as general purpose programming language. Right, but a lot of possibilities coming from extended execution environment. So we allow to refer to inputs and outputs of spending transaction to the box being spent, right? And also transaction may have some read-only inputs, so this is very efficient way to do oracles and other applications where read access is needed to the on-chain data. And also we allow access to last block headers, which is also useful in many applications. Okay, so this is called extended UTXO model. Right, so again, what is shaping this model for Ergo? So this is usage of data read-only inputs, usage of Sigma protocols instead of simple signatures in general case. So rich execution context. Ergo also has support for operations with cryptographic groups, and because of Sigma protocols and operations with cryptographic groups. So now you have possibility to express many cryptographic protocols on the application layer. Right, and also language is more powerful than Bitcoin script, and also it has different representation of programs. So instead of stack-based language, we are using abstract syntax trees, and this representation is good for program analysis and so on. Okay. So what else is new in Ergo is storage rent. So storage rent is when you need to pay for your data to be stored on the blockchain. So in details, if you want to store something for a long time in the active state, so in boxes not being spent, then not do need to track such boxes, and this is not free, right? And as you are going to occupy resources, so hundreds or thousands of computers around the globe, then you definitely need you need to pay for that, right? And also it's not viable to store something forever for free, right, on hundreds or thousands of machines around the globe. Then Ergo is using a model which is similar to regular cloud storage payments, right, and you need to pay amount of X proportional to space consumed, so number of bytes consumed by your boxes, and also time. Right, and in Ergo, this storage rent is implemented in a pretty weak form, right, to make system convenient for almost all the imaginable applications still. Right, so payment is collected from a box which is not been moved, not been moving every 4 years, right? So if your box is forgotten, right, so if you are going to keep it for a long time, then every 4 years you need to pay something. Right, and if there are not enough ergs in the box at the moment of payment, then it can be removed from the state. Right, and the storage price also may be adjusted via miner swatting. Right, so we will see yet how the storage rent is affecting the Ergo economy. But because of storage rent being used, so we can estimate some upper bound of the state size, right? And this is actually quite a good thing if we are talking about long-term survivability. So because of this storage rent, lost coins are getting back into circulation slowly. Right, then miners also have additional source of income. Right, and usually storage rent, also known as demo rush, is incentivizing people to use the money, but this effect is very weak in Ergo, probably. Right, and well, amount to pay is not big at all. So for ordinary output, ordinary box, so currently you need to pay about 0.12 ERGs per 4 years. Right, and even if miners readjust the pricing, it will be 0.25 Ergs maximum. Alright, what's also done in Ergo is some self-amendability protocol. Right, so a lot of parameters can be changed via miners voting. Right, and many parameters already changed actually. So block size, well, during the first 1 year of Ergo existence was increased by like 100%, right? And in regards with max execution cost of the block, so kind of maximum gas consumption, right? So gas limit per block in Ethereum. So similar limits we have in Ergo, and this limit was raised by like 4 times during the first 1 year and a half of the network existence. Alright, and miners can change parameters with a small step usually, so like 1% per epoch of 1024 blocks, right? But via small steps, changes can be big eventually. Some examples I've already provided. Alright, and then if more fundamental changes is needed, not just block size, right, or something like that. So some parameters which can be expressed in simple form, but if you need to change protocol in more complex way, then Ergo was very heavily designed around soft forkability. So hopefully for most of needed maybe protocol changes, soft forks are enough, and to activate soft fork, 90% of miners should be for the activation. Our 32 epochs, one epoch is again about 1000 for blocks, right? So if 90% of mining power, our long enough periods, is for some change to be activated, then it will be activated after. Right, and if old node is seeing that new version is activated, it's going to skip validation of deactivated rules, and also skipping validation of newly introduced rules. So it's pretty much following signs of soft forkability in Bitcoin, but done before the mainnet launch, so it's done more stable and rigorous manner. Okay, now about properties of the native token. Right, so emission of native Ergo token is limited, so in total about 98 million ERGs will be issued in 8 years. Right, and most of those ERGs are going to miners, except of Treasury, which is going to fund development efforts. And Treasury is about 4,300,000 ERGs to be released in the first 2.5 years of Ergo existence. Right, so most of it is already unlocked. And since July 1st, 2021, emission will start to decrease. So first Treasury part will be decreased to 0 in slightly more than 6 months, in 9 months actually. And then starting from 2022, miner rewards also will be decreased. Right, and within 8 years all the ERGs will be issued. And after that, so only storage rent rewards and transaction fees will support the mining. Okay, and so if we are thinking about properties of the native token, about its utilities, so then Ergo is theoretically not worse digital gold than Bitcoin because of proof of work, limited supply, and so on. Right, but also in the long term it can be better because of improved survivability in the long term, so storage rent, support for lightful nodes, and so on, right? And also on top of this digital gold, you can issue tokens and build contracts, build financial applications. Right, and for many contracts some collateral is needed, and then this collateral will be about ERGs in most cases, so not custom tokens, but this also could be the case. But for many applications, so most of them, ERGs will be used as collateral. Right, and then yeah, we can think about Ergo token as a classic proof of work cryptocurrency, right? And then also full for DeFi space, so to pay collaterals. Also full for applications like Mixer and so on. Right, and also in contracts, Ergo, in some contracts, Ergo is already used as a medium of exchange, so you can visit Ergo auctions, and yeah, if you sum up all the bids on the Ergo auctions house, then it's already about thousands ERGs sometimes. Right, and so hopefully will be more, and we will have more applications, right? So then we will have a lot of ERGs being locked, right? A lot of ERGs being circulated in applications. And after all, Ergo token is the only one token to pay for storage rent, right? So then some amount of ERGs is necessarily token to pay for storage rent. And unlike Bitcoin or other cryptocurrencies, so there is some minimum value you can put into a new box. So you can think about these minimum values of kind of collateral for storage rent. Right, then let's observe Ergo ecosystem, so which applications we already do have. So there is a non-interactive Ergo Mixer, which is providing security superior to mixers in Bitcoin, so it's more like privacy coins, value not shielded, right? But it's not core functionality, so a mixer is working on application level, so Ergo is not a privacy coin per se, right? But it just provides support for cryptographic protocols on application level. There is also Oracle Pulse protocol, so some protocol for Oracle's agreements, and the oracles are in the every DeFi protocol, right? So then Ergo is pretty much DeFi ready with Oracle Pulse. So there is decentralized auctions protocol, Ergo auctions. So currently like 20 auctions are running in parallel right now, and yeah, a lot of auctions already finished, so yeah, please check. There is application called Zero Knowledge Treasury, which is about spending funds jointly with preserving privacy on-chain. So DEXs, Stablecoin and gateways are coming. Very soon after Summit you will see some demos or running applications. Right, and there is a new website, Sigmaverse.io, where you can check the state of the ecosystem. Alright, that's all. Thank you very much, and please study the Ergo protocol. It's my pleasure to develop on it, and I invite you to participate in the ecosystem.
Hey there, this is Robert Kornacki, Head of Research at Emurgo and Ergo Foundation board member. In this talk, we're going to be talking about Ergo, Cardano, and the extended UTXO model. So, as many of you may know, the UTXO model is something that has been in cryptocurrencies from day one. Bitcoin started cryptocurrencies, and it was the first blockchain to come up with the extended UTXO model. This was one of Satoshi's original inventions, and which you could argue tried to replicate cash kind of on the electronic sphere. So rather than having accounts, which is what Ethereum later on did, the UTXO model instead has these unspent transaction outputs, which is what a UTXO stands for, unspent transaction output. And these have some coins inside. And every time you want to pay someone, you have a previous UTXO, you destroy it, you create a new UTXO, or multiple new UTXOs, and whatever coins are in the old UTXO must be distributed within the new UTXOs that you created. And so in this sense, you have a value transfer where the old UTXO, which you can conceive of as a box, and that's actually terminology that's used in more of the EUTXO space. So you have a box that holds a bunch of coins, which is what a UTXO is. You destroy that box, and then you create one or more new boxes that have a total of coins that was equal to the input. And so in this way, let's say I owned the previous box, and I want to send money to my friend Alice. So then what happens is I have the right to spend my box, because my box, my UTXO, is encoded with my public key on it, or my address. And since I signed with my private key that I agreed to spend this box, this UTXO, then that gives me the power to decide how it's spent. And so in my transaction, I say I'm spending this specific UTXO, and I want to, instead of having my public key, my address, on the UTXO that's created from the destroyed one, instead I say that it's Alice's, and put Alice's public key or address. In this way, we have a method of taking value that I owned, because it had my name on it, now Alice owns because it has her name on it. And it uses asymmetric cryptography, public key, private key cryptography, where if I sign that transaction, it is therefore then valid, because I am the owner, so I have the right to spend it, and I have the right to determine how it's spent. And in this case, it's all given to Alice. And if I have Alice and Bob as friends and I want to split it between them, well, then we can do the same thing where I destroy the input UTXO that has my address on it, and then I create two new UTXOs, one for Alice, one for Bob, and I can split it, the funds, so let's say I had 10 ADA or 10 ERG, then I can split the ERG as 50-50, so 5 ERGs to Alice, 5 ERGs to Bob, or 75, 25, 7.5, 2.5, and so on forth. That, as a whole, is how the UTXO model works at its simplest. All you have is a bunch of UTXOs with coins in it, and so originally that was just Bitcoin, right? And so you transfer Bitcoin through this UTXO destruction and creation method. Bitcoin, as you may know, had Bitcoin script. And Bitcoin script, while being not useless, because there were initial ideas of like colored coins and other more interesting types of projects that were approaching smart contracts and a lot of, dApps and attempting to make this decentralized ecosystem happen. However, Bitcoin script isn't very powerful. And so while it's not useless, it is missing a lot of features. And this is why when Vitalik created Ethereum, he decided that rather than making Bitcoin script more powerful, which is actually not that simple, and there's a lot of questions to be had because the UTXO model is such a novel thing, where the account model is much more like a bank account, like, an entry in a database. This is something that's very well understood in the realm of computer science, and it's a lot simpler to reason about. And so that's why Vitalik decided to throw away the UTXO model, put in this Turing-complete smart contract language, and that's what became Ethereum. However, with the UTXO model, there are a lot of really interesting facets which are thrown away in that process of switching to account-based model. And so right now, we're kind of at the precipice with the latest blockchains that are coming up with truly novel technology, taking this old, in blockchain terms, of 10, 11 years old of Bitcoin, this old model of UTXO, and reinvigorating it with brand new research, and then coming up with how to go from this limited Bitcoin script simplistic UTXO model and then empowering it with new additions to the model itself, plus brand new languages that allow you to build full-fledged dApps. And that's what's really cool, and that's effectively what the extended UTXO model is for both Ergo and Cardano. In other words, what we can kind of visualize Ergo and Cardano for the UTXO perspective is that it's much more of a natural step forward, building on top of the original design that Satoshi Nakamoto came up with. And what's really cool about that is that with the account-based model, we run into many issues that are kind of tied to this more imperative style of programming, where you just have this account and global state. Because in the account-based model, you're effectively creating mutations of data with your transactions. But in the UTXO model, you're effectively issuing state transitions by destroying old data and creating new data. If you know programming, the account-based model is very imperative in style, while the UTXO-based model is very functional in style because of that. And what this means is that some of the inherent downfalls of the imperative model can be seen in Ethereum, and some of the benefits of the functional model can be seen in the extended UTXO model. And this is the really interesting part, as there's quite a few parallels where also in the imperative world, for most people, it's a much simpler type of programming to get into, as it's more pragmatic, one can say, and less focused on key fundamentals. But that has its pluses and minuses. It may be easier to get into, but it doesn't have as much expressibility, and it's more prone to downfalls. While with the extended UTXO model and functional programming, you go back to basics, strong principles, and while it's more complex, you have a lot more power in what you can do to some degree, but also how you reason about the system itself. And so right now, before I jump into explaining the extended UTXO model at a very high level for both what Ergo and Cardano have, what is very interesting, and the last thing I'll say about the high-level overview, is that because the extended UTXO model is much more functional in design, and both ErgoScript for Ergo and Plutus are not Turing-complete languages within a single contract, but Turing-complete across multiple transactions with contracts. What this means is that it's much simpler to do a lot of cool static analysis, like formal verification of what is going on, because we have this much more foundational basis that's more functional in nature, and it's not Turing complete per transaction, meaning we don't have this state space explosion, which makes it very challenging to near impossible to fully guarantee what you are doing is correct. Instead, we have a much more declarative style of writing smart contracts, and our contracts match state machines much more, which allows us to have a lot of benefits. Now, with that all said and done, what is the extended UTXO model? In short, what we had on Bitcoin was quite powerful, and so we actually had Bitcoin script, and so that's a rudimentary contract language. Maybe not a smart contract language, but a contract language on Bitcoin that's quite limited. In the extended UTXO model, what we have are more powerful languages, as I mentioned, ErgoScript and Plutus for Cardano and Ergo, respectively. And what these do is provide us with all of your basic programming essentials that you come to expect. So you have your if statements, you have the ability to do mapping on lists, you have the ability to do folds, filters, you can check for equality between different data. And so you have the expressibility of your standard programming language to a certain degree, because we don't have Turing complete smart contracts, which is actually a big plus for us, and also why we can make much more efficient claims on contracts, because we know they won't go on forever. And so what we have in the extended UTXO model is this expressive language, whether ErgoScript or Plutus, plus the concept of data and first-class assets. So let's break that down. So we've talked about the language. We have these much more powerful languages. ErgoScript, for those wondering, is much more inspired by Scala, while Plutus is much more inspired by Haskell. In many ways, this changes how the syntax is written, but the languages, at their very core, attempt to evaluate very similar logical propositions in the end. And so they're reasonably different on the user side, but deep down inside, what they're doing is making similar checks. In the first-class assets, this is quite novel compared to Bitcoin, right? In Bitcoin, BTC is the only asset on the blockchain, and that's the only native first-class asset. With both Cardano and Ergo, what we have are native assets. And so these are tokens, which aren't like ERC20 contracts, where in Ethereum, there are no first-class citizen tokens, no native assets. They're just mini ledgers in smart contracts, which makes them quite inefficient, not very powerful, and very limited and restrictive. And you have to pay more in gas fees than if they were a first-class citizen. And instead, in the EUTXO model, we have the ability to mint or forge tokens that are native assets that can get treated just like ADA. And there's discussions about how to even implement paying for transaction fees with these assets, And that's already partially possible in Ergo, and there's talks about it in Cardano, and there's ideas for how to do all of this on the smart contract level too. And so there's a lot of cool things that are possible with native assets, which isn't possible in Bitcoin. And furthermore, what is, one may say, not intuitive, is that in the smart contract world, as we mentioned, we do not have Turing complete smart contracts. And so what this means is that there are limitations in that, and if we only had non-Turing complete contracts, that would be actually kind of crappy. But the addition of native assets act as this outside carrier of state and data in smart contract dApp protocols, which allow us to have a lot of guarantees and a lot of really novel and some of the coolest design patterns and innovations we've already found in the extended UTXO model, both on top of Ergo, especially on Ergo since it's already released public on mainnet for over a year and a half now, but also on Plutus and Cardano, is that we can do things that were never possible before in the account model, because with the extended UTXO model and with native assets, we can distribute the state of our dApp instead of being held in one single account with one single smart contract, or maybe just a couple accounts across a few smart contracts, or a few accounts and a few smart contracts. We instead have the entire UTXO set as the potential state of our dApp, and the native assets which are tied to the dApp act as signifiers of proving that you did a specific action in a dApp, proving that an oracle submitted a data point within a given epoch of time, proving that you entered into the smart contract protocol through a valid method, and that this allows you to perform actions asynchronously away from other participants of the protocol. These are all possible because we have the ability to forge and mint native assets that was never possible before. And these native assets, which don't exist on Bitcoin, which don't exist on Ethereum, in themselves have a lot of, arguably you could define them as phenomenological benefits that don't exist on ERC20 standards and anything like them. And so having non-Turing complete smart contracts can be limiting. However, with native assets put together, we actually have what you could argue as a turbocharged smart contract environment. And especially when we add in the last part of this, which is the data. So UTXOs in Bitcoin, they don't inherently carry an area within the UTXO that is relegated for data that can be used within the smart contract. And so you have the ability to post, say, metadata, but you don't have the ability to, say, implement a state of your smart contract, of your dApp, that is carried within the UTXO. And in the EUTXO model, for both Ergo and Cardano, we have data. And this data is slightly different. In Ergo, it's in the form of registers, and in Cardano, it's in what's called a datum. But effectively, they map onto the same thing, where you have this area inside of your UTXO where you can say, where you can keep the state of your dApp. And maybe the state of your dApp is distributed across 5 different UTXOs. And for specific actions in your dApp, you need to spend 2 out of the 5 together to perform, say, minting a token. or you need to use the other three to say perform DAO governance. And what's cool is that you can have some people using those two while other people using those three in parallel. And maybe the state of the three UTXOs all change when they perform governance. And, a specific vote goes through and a parameter changes. And that's all reflected within the data, also known as the datum or registers, respectively in Cardano and in Ergo. And that's where you keep the state and update the state. And this is novel compared to Bitcoin because that wasn't even possible in Bitcoin. UTXOs didn't have this state which can interact with Bitcoin script. But we now have that in the EUTXO model. And so, as a sort of conclusion to this talk and presentation, we effectively have this trifecta of native assets, smart contracts, and data within a UTXO. There's a few more parts of a UTXO and some minor differences between Ergo and between Cardano. However, the EUTXO model itself is effectively based off of these three parts of a UTXO, and this is what gives it the power that it has. What is quite cool is that we've already come up with a lot of interesting design patterns that were never possible before in Bitcoin, in Ethereum, or in any other system because they've never used the UTXO model. And right now we're at the point where we're really exploring and jumping into what's possible. And so there's already concepts of, recently I came up with potential design patterns for how to work on having asynchronous smart contract protocols. So the possibility of potentially starting a dApp, splitting it into potential sidechains or potential shards, and then having those shards and sidechains only come together and synchronize every once in a while in a very natural way, where even within the shards, the individual actors can asynchronously perform their own parts of the protocols. And so you have this parallelization that can naturally separate, which is never really possible, or while maybe technically possible in the account-based model, very inefficient, would cost a lot, and it's not very clean to do it. And it would be very limited based off of a number of factors. But in the extended UTXO model, we can much more naturally do this. And these design patterns, while still very nascent because this model isn't very popular, we're seeing in our research that there is a lot to uncover. And it is my opinion, and the opinion of a few of us, that these extended UTXO systems, currently we have Ergo and Cardano, the complexity, admittedly, may be a bit more than your account-based systems, because it's a bit different than what most people are used to. However, the power of these systems seems to be a lot more unbounded, a lot more exciting, because the potential here is that you have a brand new model that has effectively all the power of the account-based model, but distributed across an entire UTXO set with native assets, with the ability of your state, of your dApp to be spread across hundreds, thousands, potentially tens of thousands of UTXOs, with the ability to potentially perform asynchronous parts of protocols in separate groups, maybe in different shards, different sidechains. These are directions that are theoretically in our grasp. And while we're not there yet, there's a lot of research and a lot of developer work that we require to get there, we already see a lot of the fruits that are ripe for the picking and which are already going in and starting to harvest. But we also see the fruits that are ripening and even, the native saplings that are just starting to bloom. And some of those saplings will be fruitful, others obviously not so much, as always goes with research. But we're in this phase where we see everything is developing, growing, and we see we have some solutions to problems that are plaguing the account-based world. And that's why the extended UTXO model and the future from a technical perspective for both Ergo and also for Cardano seem very bright, because we really do see there's a lot of untapped potential that lays await in these extended UTXO-based systems. And I think, as you'll see in other talks in the Ergo Summit, there is a lot of really exciting things to come, and a lot of things we're releasing today. And so I think if you're interested in getting into development, or you're just a user, this is a really great time to try to learn a bit more about the UTXO model, because I really do not think it is going away anytime soon. But in fact, we might start to see more and more blockchains adapting this and moving away from the account-based world, which seems to have dominated for a certain time. But it might be my contention that that may have been that era of blockchains, but as we move forward into the next era, we might be seeing more and more extended UTXO-based blockchains popping up.
Hey everyone, my name is Sebastian, and I'm the co-VP of Engineering and Cardano Project Manager at Emurgo, one of the companies behind the Cardano project, and also the company behind the Yoroi Wallet. So in this video, I want to go over the Yoroi Wallet, what it is, what we've done so far, what we're working on now, and what we plan to do for the future, and how all that ties into the Ergo project. So first of all, what is Yoroi? So obviously not everybody is familiar with it, but Yoroi is a cryptocurrency wallet. Notably, it's a cryptocurrency wallet that only supports two currencies, Cardano and Ergo. And the reason for this is that originally this was a Cardano only project. We want to expand to a second cryptocurrency. And we looked at all the cryptocurrencies out there and which one made the most sense. And because Ergo had a close relationship with Cardano, and also because it shared some similarities, for example, in the way that smart contracts work, we thought this made the most sense for our partnership. And one of the ways we differentiate our products from other wallets is that instead of supporting many cryptocurrencies with a very small support for each one, we instead want to support a small number of cryptocurrencies. We want to support each one very well, right? So for example, you could find a wallet that supports Cardano and 100 other cryptocurrencies, but the only thing you can do with this wallet is send ADA or receive ADA. But instead, with the Yoroi extension, not only can you send and receive ADA, we also have a beautiful dashboard to manage your staking. You can delegate the stake pools. You can register for the Cardano Treasury system and so on. So for Ergo, we plan to have the same thing where we don't just provide Ergo sending and receiving, but also a very deep, full integration with all the functionality that Ergo provides. So where can you get the Yoroi extension? Right now it's available in two ways. One is the Yoroi extension, so browser extension, and the other one is a mobile application. For the browser extension, we support Firefox, Chrome, and Edge. And then for mobile, we support Android and iOS. So if you haven't heard of Yoroi, you might be interested in the history of this project. So let's talk a bit about what we've done so far. So the Yoroi wallet was created in 2018 as a browser extension. And originally it was just a browser extension, and we wanted to see how popular it would get, and it turns out people really liked the software we wrote. They really liked the Yoroi extension. And so in January 2019, we also launched a mobile application. Now these projects are separate but similar in design and share some code, but unfortunately the technology at the time was not good enough for us to make both of them the exact same application. And so there is sometimes a delay. For example, the Yoroi extension right now has Ergo support, but Yoroi Mobile does not have Ergo support yet, and it's something that we're actively working on. But so speaking of Ergo support, in October 2020, we released Ergo support for the Yoroi extension. Now, the Ergo support was done through a library called Ergo TypeScript, which is a library that was created for CoinBarn that allowed you to add Ergo support for light wallets. Now, the problem with this library is that it didn't have support for smart contracts, and so it really only supported the basic we needed for the most basic integration to Yoroi. So similarly, we didn't have support for smart contracts, and we didn't have support for multi-asset transactions, just to keep it simple for the first release. Now, let's look at the present. So the present, we now have a version of Yoroi with an update in 2020, where we now support multi-assets, so you can receive custom tokens and send custom tokens. And we also support the new library called Sigmaverse. So Sigmaverse is a more complicated but also much stronger library for Ergo support, which allows us to have stuff like smart contract support. And because it's written in Rust, which is a programming language that works well in many scenarios, we can also run this inside the browser extension and inside Yoroi Mobile. And so this is a big update for us because as of this update of January, not only do we support multi-asset, which is very useful for just smart contracts in general, because many smart contracts use custom tokens. It's also important because the use of Sigmaverse enables us to now have a much deeper integration with smart contracts inside our platform. So just from this explanation, you may not have a clear idea of exactly how Yoroi works. And so here I'm going to just show you Yoroi very briefly so you have a good idea of how Ergo is integrated into the Yoroi extension. All right, so first I'm going to show you how to get the Yoroi extension. So first you go to yoroiwallet.com and it will look something like this. And in this drop-down, you will be able to find the Chrome extension. So if you click on that, you'll be brought to our Chrome Web Store page. You can see this is the real version of Yoroi because it's uploaded by us. And also you can tell from the user count and the number of ratings that this is kind of hard to fake. Now, once you've added this extension to your Chrome or Brave or Edge browser, you'll get a icon at the top right of your browser. And when you press it, you'll see the Yoroi extension appear. Okay, once you've got the Yoroi extension, you'll go to Restore Wallet and select Ergo Wallet. From the Ergo Wallet, you'll be able to choose the number of words you want for your recovery phrase. And so I'll pick 12 for my wallet. Now I'm just going to hide this part out so you don't see what I type in. But here you would enter your own recovery phrase. But if you don't have one, you can also select Create Wallet and create your own Ergo Wallet. All right, there you go. I've restored my Ergo wallet. And you can see here we have a checksum that represents your private key. Okay, so this way, if you type in the wrong recovery phrase, you'll get a different checksum, and so you'll know you typed in the wrong thing. So this is a special feature we have in the Yoroi extension, because we often have people messaging us saying, I type in my recovery phrase and I get an empty balance. And now we can tell them, if you type your recovery phrase, you should get a checksum. Does your checksum match what you had before? And so whenever you use Yoroi, be sure to write down your checksum and keep it somewhere, because if you get the wrong recovery phrase, you'll be easily be able to tell because the checksum will be different. So now let's restore the wallet. And here's our Ergo wallet. So you can see that it'll take some time to pull up the transaction history. But once you've got that up and running, you should be able to see. Sorry, I'm running a test build, so you get to see an error at the top. Once you've got the wallet running, you should be able to see your transaction history, which will show you all the transactions you have in your wallet. Saying, for example, here's a transaction that contained 3 boxes. All of them were paid to public key types, and then they got sent to other addresses. You can see some of these boxes contain just ERG, and some of these boxes contain a token. This example token in this case is called test. So if you click on these links, you'll be able to go to the Ergo Explorer and find out more information. But from here, you can also see there's a receive page where you can see which addresses you have and how much balance is in them. And you can also generate more addresses if you need more addresses for some reason. And now these are all paid to public key address types, and we don't currently support any other address type through the receive page, but that should be all you really need. Now once you've done this, you can also send your ERG to other people. So we have a drop down for you to pick the asset you want to send. So you can either send ERGs or you can send whatever custom assets you have. So if you want to send ERG, you just pick an address, enter it in, and then you can send any amount you want, or you can send the full balance. So once you want to send some ERG, you'll be able to see a confirmation page that shows you where you're going to send it to and how much you're going to send. Now, if you want to send tokens, for example, if I want to send my test tokens to somebody, you'll notice that the amount you're sending is just the test amount, right? So because I have, 1,000 test tokens, I can send, for example, 100 of them, right? And the only amount of ERGs that will be spent is the 0.0011 amount. Okay, and if I press the confirmation page, you can see I'm paying a small amount of ERG, which is the minimum you need to have inside a box, plus a fee, which is the minimum fee required, and then the test tokens. And obviously you can send all of your test tokens if you want to send them all somewhere too. Now, the thing is that you can't send multiple tokens at once, and you can't send tokens with a custom amount of ERGs. There are definitely use cases for these situations. We tried it out and we found that the user experience for this is really tricky. Like, people don't want to select 10 different tokens or drop down and then make sure they get all the right amount. It's just not a great user experience. So for these cases where you want to send multiple different tokens in some specific way, we suggest that this should all be handled through some sort of dApp. If there's a use case for this that is really common, we could provide a advanced view for transaction sending that allows this functionality, but we try and keep things simple to start with. And if people really need the extra complexity, then we kind of take the extra step. So this has been a short introduction of the Ergo features we support for the Yoroi extension. And once we have Yoroi mobile support, we'll also support a similar feature set. All right, so now let's talk about the future of Yoroi. So now that you've seen our amazing stack, let's talk about even more exciting stuff, what's happening in the future. So there's three main things that we want to work on. One of them is Yoroi mobile support. So as I mentioned, right now we have support in Yoroi extension, but not Yoroi mobile yet. We have a prototype integration of Sigmaverse into our mobile code base, but it's going to take us more time to add the rest of the missing functionality. We're also working on a stablecoin integration into Yoroi, and so you'll hear more about that in other talks during the Ergo Summit. And also, we want to have a dApp connector. That means that we want dApps to be able to communicate with your wallet through the Yoroi extension. And to give you more information about exactly how we're going to provide dApp support, I have a video by one of our engineers called Rob, who's going to go into more detail about the work we've done so far.
Hi, I'm Rob, a research and development engineer at Emurgo, and today I'm going to be quickly going over how we've been integrating Yoroi with Ergo-based dApps. First of all, communication. There needs to be some way for dApps to communicate with the wallet, and for this we're using EIP12, which is an Ergo improvement proposal that aims to standardize this kind of communication. This is very similar to how Web3 can work to join together an Ethereum-based dApp to a user's Ethereum wallet, such as MetaMask. Essentially, the API entry point, request read access here, will be exposed to web pages, and dApps can then choose to call this entry point, and this will request that the user give them access to their wallet, read-only access, and if the user accepts, then they are given the rest of the API. Among this, we have get UTXOs. This can return the user's unspent boxes, get balance, gets the user's wallet balance, get information about the used and unused addresses, and also potentially we can request that the user sign a transaction. This would be something the user would also have to additionally consent to, not just something given to all websites. We also have the ability to sign part of a transaction for more complicated use cases where the user might only own some of the inputs. You can sign generic data, and also for ease of use, this allows us to submit a transaction through the wallet so that the dApp doesn't necessarily have to host their own Ergo full node if the rest of their requirements are quite simple. Alright, now I'm going to demonstrate this with a locally hosted dApp. Alright, so we've navigated the dApp, and as we see, we have a connect confirmation box. We can select which wallet we want to expose to the dApp. All of this UI is just temporary because we've just been focusing on getting the backend and the core communication systems done first before we finalize the UI. Alright, so now that we've connected, this is what we see. This is a very simple dApp that I'm just using for testing here. It essentially aims to allow the user to donate a specific amount of ergs to a hard-coded address in the dApp. Okay, so let's just choose a specific amount, and then we click send here. The wallet, in order to do this, it first called get balance to get the balance from the user, and afterwards, to construct the transaction, it had to get the unspent boxes to know which boxes that the user owns so that we can use for this transaction. And using that, it constructed a transaction. This transaction is shown here using this temporary UI. As we can see, we have the donation we want. We have the rest coming back as a change output. and then the fee output. And this box appeared because the dApp requested the user sign the transaction. This is entirely inside the wallet. The dApp has no control over this. It just requests that the user sign it, and if they don't want to, nothing happens. Alright, this is an additional security layer we have. The user must enter in their spending password to sign any transaction through the connector. Alright, so now that we've signed that, it gives them back the signed transaction, and then the dApp then chooses to try and submit the transaction to the wallet, and this gives them back a transaction ID, and we can now track that, which potentially could already be in the node's mempool already. Let's see. Not yet. Okay, we'll just wait a little bit more. And some additional things to note. This is not going to be directly a part of Yoroi itself. We chose this mostly for privacy and security considerations. As we see, if we open up our extensions, we have two extensions installed. We have the regular Yoroi. Notice that it says no access needed. It does not need to see and change information on any website. We wanted to maintain that. And since in order to do this kind of communication, we need to expose this API to web pages for dApps to interact with. We decided to put this in a separate extension. And you notice there, full access. It can see and change information on the site, which it needs to expose the API. This will be true for any kind of web-based API. And this also allows us to be more modular as well, because we could be additionally planned later on in the future to implement this also for Cardano or something else. And also as just another privacy feature as well. While the user has to consent to any kind of access to the wallet, you can refuse any sites having access. This also allows users, if they have Yoroi installed, to not let any website know that they have some kind of wallet installed by just not installing the connector. So if you don't need this functionality, you don't need to be exposing that to anything. Okay, let's try and refresh this again. Look, it's already been accepted. We have the transaction that we just sent for this amount that shows up here. It's already been accepted by the other Ergo nodes in the main network in mainnet. So as you see, we have this entire thing functioning fully. We just have to do the app UI.
Hello everyone and welcome to the next segment of Ergo Summit, where we go through a demonstration provided by a non-real. One of the first things that we can see within the layout of Ergo Auctions is a panel to the left, which provides an interface for navigating around. If we go to auction history, we have the ability to witness all the past auctions that have been completed. Inside the auction box, the token ID for the NFT is presented. Going a little bit towards the bottom of the box, there is an option denoted as details. Clicking on this, we can see the history of the bids for the auction as they happened. The transaction that contained the bid can also be seen, which is great for verifying who sold the NFT as well as who bought the NFT. The transaction will also contain the asset ID, which is assigned to the NFT. And along with all of this, we can see our bids. Now, looking towards the panel to the left, we can move from the auction history back to active auctions. Here we can see that there is already one auction active, which has 62 blocks remaining, around 124 minutes, 2 hours. Now let's quickly look at creating an auction for ourselves. At the top is where the token ID is entered. This can all be automated via Ergo Utils. Below the field for the entry of the token ID, we also have the ability to set some parameters for the auction itself, with some specifics such as token quantity, the initial bid for the NFT, the smallest increment between bids, and of course the auction duration, with an option to extend the auction based upon the last bid that was placed. And right at the bottom, we can set a description for the auction. This is a great place to post a link towards an online space where one can see the NFT. Our auctions transaction is automatically generated. A notification pops up just in the top right corner to notify us that the transaction has been generated. If you do continue to stay on the web page following the initiation of the auction, you'll be notified furthermore about the status of the auction. Things such as who has placed bids and to what degree their offer is. We just have to wait for a miner to pull it from the mempool and released with the next block. And when all of this has been executed, we receive another notification via a pop-up, which tells us that our NFT auction has successfully been posted to Ergo Auction House. Now everyone has the opportunity to place a bid on your auction. Now let's place a bid. If you click on Update Wallet to the top right of the web page, you are presented with an interface to enter your wallet address. You have the choice of selecting any wallet, the node wallet, which comes with Ergo, along with Yoroi. Moving on, if we open up Yoroi, let's generate a new address quickly. We'll copy that address and paste it. If you just click on Save, Ergo Auction House will successfully configure the wallet for you. Finally, you can bid away on all of your favorite NFTs. Once Ergo Auction House has processed your input, it will specify an amount of Ergo that you need to send to the address given. Anything sent to this address is safe. If you send too much, there's no need to panic. The transaction will simply be returned. Now let's send the necessary amount. If we quickly go back to Yoroi, paste the copied auction address. Following that, copy and paste the amount required to be sent. Returning back to Ergo Auction House, we just have to go through the procedure of our bid being mined once again. Let's just double check our offer, and there it is. We can click on See Transaction for a quick direction to the Ergo Explorer, where we are shown the transaction itself as it is on the blockchain. And thankfully, there it is. So the person who has been outbidded, if the current price is still deemed to themselves as being within their range, they have the ability to use their funds once more. And of course, this is something that you would expect. Moving back to Ergo Auction House again, once our bid has successfully been placed, we can see our address as the current bidder, which is the third row down under the current price. If we click on the circled question mark to the right of this row, we will once again be pulled to Ergo Explorer. And of course, we are the current winner of the bid. If you're interested in the changes of the NFT's valuation over time, within the bottom left of its container, you can see how much it has increased by since the initial bid. For the second part of this demonstration, we will now have a look at setting up an auction through the usage of Ergo Utils. Let's auction this piece of art in ergoauctions.org. It's always useful to use some form of online storage, such as ibb.co, as shown, just so the bidders can see for themselves what is being offered. But before we actually initiate the auction, let's firstly have a look at ergoutils.org. Ergo Utils is a pretty neat and simple application that can assist with a variety of needs for all users with any wallet. Currently, Ergo Utils facilitates issuing a new token as well as artwork NFTs. Clicking on My Tokens, we can look at our previously issued tokens towards the Ergo environment. Now let's quickly walk through this process to retrieve our address for Ergo Utils and just follow the copy and paste process, followed by save. Ergo Utils will notify you that the operation has been successful. Finally, we can set the name of our artwork. To complement the season, let's name it Christmas with Ergo. Be sure to provide a accurate and descriptive name for the artwork. And now we can elaborate on the artwork name within the artwork description box. It's good to extend on what we have named our NFT. Remember, we want to encourage people to place bids, so it's good to provide details such as what has inspired you for your piece, possibly what software application was used. And as covered a couple of minutes ago, a link to the artwork would be extremely useful. After setting the artwork description, it's time for us to select the file which contains the artwork for the checksum to be computed locally on your system. Now here's a little catch. If we issue the NFT now, it will be sent to our own address, which of course we don't want. So let's go to ergoauctions.org and try to initiate our auction first. And if you remember, before we try to do that, we must configure our wallet, which is simply done by copying and pasting the address into the field. We will set our initial bid to 5 ERG. We'll have to deposit that amount not long after creating the auction. If we use a minimum step of 20 ERG, each offer made must be at least 20 higher than the previous. Remember that this can be both provocative, but at the same time could possibly be off-putting. And as shown in the first half of this demonstration, we will use the auto-extend feature for the duration of the auction. And finally, let's give a description to the piece. This is the first graphical auction on Ergo Auction House. Thus, let's specify it Now we need to send exactly 5.002 ERG, and it's worth noting we have a limited time to do this. Now let's click on the amount we must send, navigate back to ergoutils.org and paste that amount within the amount field as shown. Now let's copy the address, go back to ErgoUtils again and paste that into send to. Once done, click on issue, and before we're ready to fly off, we just have to deposit the amount which is shown to the address provided. And once received, ErgoUtils will issue the artwork and send it to Ergo Auction House with the initial bid. All of this happens by using a proxy service, the assembler. Any wallet can be used, so let's send the amount using Yoroi. Now we literally just have to wait a few seconds before all of this is recognized, and when completed, we will of course be notified of this. You can click on this pop-up box for more details, as well as check the transaction for a second opinion if needed. If we head back over to Ergo Auction House, we can check our auction again. It should be listed there, ready for an offer. Everything that we can see is achieved by chained transactions, with the only roadblock being us having to wait for them to be mined. And until recently, we have the ability to explore artworks on Ergo Auction House, as it now recognizes the auction's specifications. And we can look at the details which were shown as we were setting up our auction in ErgoUtils. As demonstrated, you can just copy the URL for where the image is stored online. But we now have the benefit of Ergo Auctions loading images directly into the dApp, which I recommend is something for you to try out following Ergo Summit. And of course, as shown, placing the bid is very easy. Just enter your desired amount, and of course send your desired amount from your chosen address. It would be great if we saw some more action at ErgoUtils. There's a lot of fruitful things which we can reap from this application. This is only going to expand further while the ecosystem expands. I'm sure we can expect a lot from ErgoUtils in 2021. And that's all from a non-real. Thank you for watching and enjoy the rest of Ergo Summit 21.
Hello there, this is Robert Kornacki, Head of Research at Emurgo and Ergo Foundation board member. Today is a really exciting day for the ecosystem. Not just because we have this awesome event, the Ergo Summit, but also in addition to that, we are announcing the release officially of the AgeUSD stablecoin protocol. This has been in the works for a number of months and has been made possible due to a collaboration between the Ergo Foundation, Emurgo, and IOHK. This is a novel stablecoin protocol, and it is the first stablecoin protocol to be built on top of the, built and designed on top of the extended UTXO model. And so today, in this talk, we're going to be looking at what is the AgeUSD stablecoin protocol, what are we releasing, and what does this mean for you, the users of Ergo and the ecosystem as a whole. So, we'll be having a couple talks after this, getting into the nitty-gritty of the stablecoin from both the more economic, game theoretic perspective and also the technical perspective of the smart contracts. But in this talk, I'm going to be introducing you to what we're releasing and kind of a very short and high-level overview of what is AgeUSD, what are the implications, how do you mint stablecoins, what else is part of the protocol. We're going to get into all of that right here and right now. So what you see right in front of you is the AgeUSD repo that will be released and should be public right now as you're watching this talk. In this repo, just to give you a quick overview, you will find that it is divided into a number of sections. We have the AgeUSD specs, which are the high level specs that explain exactly how to implement the protocol. And so we have all these specs defined, so you can go take a look and read through them all. They effectively are similar to what you may remember from the Oracle pool specs, quite similar to that. We have the smart contracts, of course, so you can go read the smart contracts, you can understand the different parts. We actually split up, we developed both the specs and the smart contracts into different phases, and so as we added more complex features, we kept improving the specs and improving the smart contracts, which allows you, the potential future developers who want to build other dApps, or maybe take this AgeUSD code and contracts that we wrote, and maybe you want to add new features. You can see the step-by-step process of how we built these up, and it's all available for you to dive into in this repo. Furthermore, we have the AgeUSD Headless dApp, and so what this Headless dApp allows is that once someone in the ecosystem launches the AgeUSD stablecoin protocol, maybe they'll improve on it, add features, that's to be seen. The Headless dApp will allow anyone to compile the methods required to interact with the released instance of AgeUSD, or whatever new protocol someone builds on top of AgeUSD, and allows them to build unsigned transactions or integrate with the transaction assembler, allowing you to build web UIs, allowing you to build command line interfaces, allowing you to build mobile applications, desktop apps, all just by integrating with the Headless dApp. And this is why we've invested a lot of time into Headless dApps, which you'll hear more about in this summit about. And that's why we devote a lot of time to having the AgeUSD Headless dApp be available on release, so that both for whoever wishes to deploy AgeUSD onto Ergo and whoever wishes to create UIs and then make money by creating really high quality UIs and earning a small percent back for creating the UI on top of the headless app. We are trying to build out the infrastructure here so that both for deploying the stablecoin and both for building on top of it in terms of UI and for developers in general, we're making this experience as streamlined as possible so that we can really get a decentralized ecosystem. And we spent a lot of time, research, and development work to make this all a reality. Finally, we also have the CLI, which allows technical users to use a deployed AgeUSD instance on chain and start to mint stablecoins and interact with the protocol. However, the CLI is much more of a technical tool that's meant to be used by technical individuals and also for testing for developers. All of this is being released so that the community can now take all of this research and development work and build on top of it and deploy the AgeUSD protocol. This is one of our largest projects, I think, that we've really tackled. And what's cool is that the Oracle pools, which we developed about half a year ago, now are being utilized, and we're starting to see this building effect where every single previous piece of the DeFi puzzle that we scaffolded from the ground up now fits on top of each other. And so now that we have Oracle pools, it's really not that challenging to get nice data feeds so that we can build a stablecoin. Furthermore, because we created the Headless dApp framework a couple months back and released that, now that we have the Headless dApp framework, we can create a Headless dApp for the AgeUSD stablecoin protocol so that whenever the AgeUSD protocol is deployed on chain, then front-end implementers will already be able to start implementing and start to earn income so that better and better front-end UIs are developed, and we start to get this really exciting ecosystem where both protocol developers and front-end developers can both benefit from building these kinds of dApps and deploying them. And so this is really exciting, and I think AgeUSD is the prime example that we're going forward with at the start of 2021 to show just what is possible in the ecosystem. So that's a kind of a high-level overview of where we're at with the structure and what we're releasing. However, I'm sure as most of you would like to know, how does AgeUSD actually work? And so in this repo, all of this is going to be explained in detail and you'll be able to read this. However, I'll kind of jump in and give you a high-level overview. Most stablecoins, which you may know of, that are crypto-backed, which is what AgeUSD is, are based off of MakerDAO and DAI. However, MakerDAO and DAI are based off of the concept of CDPs, collateralized debt positions. And these CDPs have a not so great feature that they can be liquidated. And this is an inherent property of the protocol, but this is a property which we have seen back in March of 2020, where Black Thursday really did not turn out very well, and the further mechanisms to bolster up the MakerDAO protocol ended up liquidating for effectively 0 ETH and just causing serious problems. We, in our initial stages of looking at that protocol, realized that having CDPs and the ability to liquidate causes a lot of issues, because if there's blockchain congestion, then people can kind of get away with murder potentially, and on the auctions, on the liquidations, they can just take what's available for nearly $0. Furthermore, having this design of forcing liquidations means that if there's a bit of volatility, you could trigger, 10 or 20% of CDPs to liquidate, even if the price at which they liquidated at was only 1 or 2 cents under their liquidation limit for, say, a few minutes or an hour. And this is not very sustainable, you could argue, because the threshold concept of liquidation for CDPs is very unstable. And in our design of AgeUSD, we kind of looked at what's available out there, and we tried to take the best of the best and come up with a protocol that doesn't have this variability, which is weak due to blockchain congestion, but also isn't weak due to big volatility spikes, which would cause mass liquidation events, and instead tries to smooth all of that out and make the protocol not require dynamic actions that require someone to perform transactions, which fails under blockchain congestion, and which tries to smooth out the issue of when prices decrease, we don't just have liquidation events which kind of cause tragic volatility and issues within the protocol itself. That's why in the AgeUSD protocol, what we actually have are not just AgeUSD stablecoins, but we actually have 2 coins, which is quite interesting and provides us with a lot of benefits, but also more flexibility and power, which is quite exciting. So, in the AgeUSD protocol, we have AgeUSD, which is our stablecoin, which pegs USD, and we have reserve coins. Reserve coins are this novel coin which you can kind of consider representing going long on ergs. So when the AgeUSD protocol is deployed onto the blockchain, first there must be people who wish to mint reserve coins. They do this by, say, putting in, 1,000 ergs, and then they get some exchange rate of reserve coins back. These reserve coins represent the underlying reserves of the stablecoin protocol. So let's say we have this scenario I just mentioned. I put in 1,000 reserves. This is a brand new implementation. It was just deployed. I'm the first person. I mint 1,000 reserve coins. 1,000 ergs worth of reserve coins. Now the reserves in the stablecoin protocol are 1,000. The stablecoin protocol has something called a minimum reserve ratio. This is how many stablecoins can be minted for every erg worth of US dollar inside of the stablecoin protocol. So in other words, if our minimum reserve ratio is 100%, that means if we have 1,000, well, let's say we have $100 worth of ergs. So let's say we have 1,000 ergs. Each erg is worth 40 cents. And so that would be that we have $400 worth of ergs in the protocol. Thus, that means if we have a minimum reserve ratio of 100%, we have the ability to now offer anyone on the entire blockchain to mint up to $400 worth of AgeUSD. And so we have this inherent relation where first users who believe that the price of ergs is going to go up, they mint reserve coins, putting their ergs in the reserves, And then based off of the reserve ratio, this thereby allows and provides the opportunity for then AgeUSD users who want stability of value to then come to the dApp and mint AgeUSD. And so as I mentioned, anyone on the blockchain who has ERGs, assuming we have 100% minimum reserve ratio, and we have $400 worth of ERGs, so 1,000 ERGs at 40 cents each, we have the ability for anyone to mint 400 AgeUSD. This can be done by anyone. And so, assuming we have this scenario, let's say Alice comes into the mix and Alice wants to mint 250 AgeUSD. She takes her ERGs, uses the dApp by issuing a transaction, and what she does is she submits herself 250 USD worth of ERGs to the reserves, and this allows her to mint those 250 AgeUSD. Now, in our scenario, we have Alice, who has 250 AgeUSD, and we have me, who submit 1,000 ERGs and got a bunch of reserve coins back. The exchange rate of reserve coins varies depending on various protocol parameters and the state of the USD to ERG exchange rate. But effectively, the more reserve coins you own, the more of the underlying reserves of the protocol, after paying off all of the stable coins, that you have the right to withdraw. To try to give some more light to the explanation of how this all works, let's consider in this scenario, after 30 days, the price of ERG goes up. And so in this scenario, what this means is that the 250 USD, AgeUSD, that Alice minted now require less ERGs to cover them, right? So before she submits sufficient ERGs to cover the 250 USD she minted, and now let's say the price went up by 10%, so to cover those AgeUSD, she needs the protocol needs to have 10% less ERGs to cover those. Thus, that means the reserve coins that I'm holding actually increased in value. And so I can then go to the protocol and redeem my reserve coins to profit because of the price increase of ERGs to USD. And so we have this very interesting dynamic with AgeUSD, where the price of reserve coins changes based off of the current situation of the protocol, the amount of stablecoins minted, and so on forth. And rather than having liquidation like in MakerDAO, instead we do that all automatically based off of the mathematical equations inside of the protocol itself. Thus, we don't need to worry much about blockchain congestion because we don't have liquidation. It's instead in the math, and when someone tries to mint or redeem a stablecoin, then that's when the math gets calculated and there's no dynamicism that's a weak point in the protocol. And so in this scenario, after the price goes up 10%, say Alice wants to redeem her stablecoins, she can go ahead and do so. However, because the price did go up and she chose stability over variability, therefore Alice redeems her 250 AgeUSD for 10% less ERGs because she chose stability. I instead chose the variability. I chose to go long, so to speak, on ERG, and so I chose to mint the reserve coins. And so since Alice decreased her ERG rewards, or her ERGs that she redeemed by 10%, those 10% are now in the reserves, and they are mapped to the reserve coins that I'm holding. So now I can redeem my reserve coins and I got 10% more ergs for supplying the reserves that allowed Alice to have that stability of value. And so, in short, we have a protocol that allows people who wish to go long on erg because they believe that the price of erg will go up, and so they can submit ergs to the protocol by minting reserve coins. And we have people who want stability who are allowed to mint AgeUSD because the reserve coin holders provided the reserves in ergs. We have these two different participants of AgeUSD users and reserve providers, and each has great incentives, allowing for this whole protocol to survive and, you know, have these brand new two DeFi assets being AgeUSD and reserve coins that have a very different dynamics than just holding ergs by themselves. And so what's really exciting is that this new protocol provides us with these new DeFi primitives on top of Ergo of AgeUSD and reserve coins, and provide a simpler protocol that's less prone to many of the problems we saw on Black Thursday with MakerDAO and DAI, with CDPs, thanks to having a simpler set of math that doesn't require dynamicism. What's explained here is a very high-level overview, and there's still a few more parts to the protocol, like fees, where anytime someone mints or redeems either stablecoin or reserve coin, then there's a small fee taken, and those goes to the reserves. And so reserve coin minters, or reserve providers, as they're also called, also benefit whenever people mint or redeem AgeUSD, and so there's also extra profit potential for reserve providers, not just on the exchange of the peg of the exchange rate of ERG to USD, but also if a lot of people use AgeUSD, then you also profit. And so we're trying to create a protocol that really incentivizes the users who took on the risk by minting reserve coins to really get a solid upside so that we can guarantee liquidity, so whoever wishes for stability always has the ability to mint AgeUSD. With all of that said, this repo and all of these explanations will be, are now public, with the Ergo Summit now being live, and in the consecutive 2 talks after this, we'll be going in depth on the technical side for smart contracts, but also the more incentive side of how this all works and what this means. If you're looking to become, say, a reserve provider, what are all the incentives that can help you to maximize your returns? And if you're an AgeUSD user, what does that stability provide for you, and how can you get into this? And so both of these dynamics allow a lot of exciting new potential, and both reserve providers might also be AgeUSD users. And so it's cool that we have really 2 brand new assets, DeFi assets, that will be available. And so to sum up with this talk, the AgeUSD stablecoin protocol will now be officially released in public, so you can go to this repo, check it all out, see everything from the specs, the contracts, the headless dApp, and how the headless dApp can be used to integrate with, say, a CLI. That is all now public and available for developers and users of Ergo. As stated, we're releasing the protocol, and now we're giving this to the community. And so the community has the ability to very simply take all of this work that we have created and released and simply bootstrap the protocol to put it on chain. we have done all the research and made sure from basics of design to the actual code written in both the headless dApp, in the smart contracts, that everything is a unified system that's ready to be deployed by the community. We think this is a really exciting step forward, as this has been a really great partnership between the Ergo Foundation, Emurgo, and IOHK, and we've made a lot of amazing steps forward in the process of creating this. And as mentioned before, headless dApps are one of the results of this. And this is really the first moment where we have the ability for both smart contract developers, dApp protocol developers, but also front-end developers to jump into the mix and start providing awesome user experiences by deploying the AgeUSD protocol and then also creating front ends so that the users are not just stuck in one UI inside of a wallet or just one website, but instead they have the ability to choose between multiple great UIs, but also have incentives so that front-end developers can actually earn some profit for providing these awesome user experiences. We believe this is the way forward for the dApp ecosystem as a whole, and now with the release of all of the code of the AgeUSD stablecoin protocol, we're really excited to see members of the developer community deploy the AgeUSD protocol, build amazing UIs on top of it, and allow the ecosystem and all users of Ergo to really get a lot out of this and start to build DeFi from the ground up. Thank you very much for watching this talk. Everything I mentioned here is now publicly available. However, I would implore you not to rush on over there, but to wait for the next few talks where we'll be going very much in depth into the AgeUSD protocol from a technical and incentive perspective, which will really give you an understanding how it all works, which then afterwards I would really recommend for you to check out everything we have released and start, jumping on in, developing, deploying, and building on top of this.
Hi everyone, My name is Bruno. I'm a technical director at Input Output, and I'm going to present to you our stablecoin, which is a pegged and crypto-backed algorithmic stablecoin. This has been joint work with some amazing people from Ergo and Emurgo, and also other people from Input Output. So yeah, let's start. Let's start with some definitions to explain the title of this talk. So first, by stablecoin, we mean a digital asset having low price volatility with respect to another asset or index. Some examples of assets and index are, for example, the USD, Euro, even Bitcoin, gold, silver, stocks, indexes like the S&P 500, inflation indexes. We say that a stablecoin is pegged if it tries to keep the volatility as close as possible to zero. And we say that it's backed if it maintains reserves to enable the stabilization mechanisms. And we say that it's crypto-backed if the reserves are made of cryptocurrencies, for example, ADA or ERG. And finally, we say that the stablecoin is algorithmic if the stabilization mechanisms follow an algorithm. So before I explain the stablecoin to you, I would like to go over some principles and goals that have guided ourselves in the design. So first, of course, if we want to do a stablecoin, one of our main goals is stability. And we have to think about how we're going to stabilize the stablecoin, right? The price of the stablecoin. And one thing we could do is to make something very complicated and obscure so that you don't understand how it works, hoping that by not understanding how it works, you wouldn't be able to attack the stability of the stablecoin. Now, of course, I'm joking, right? We're not really going to do this. Instead, we are aiming to do something that where you can reason very clearly about the stability, so that you can be confident that it's stable, and you can be confident about the conditions under which this stability holds. And as long as these conditions are true, the stablecoin, the price of the stablecoin will be stable. When thinking about the stabilization techniques, we took our inspiration from well-established concepts and techniques from traditional economics and finance. So we tried to avoid reinventing the wheel, and maybe accidentally creating squares and triangles instead of wheels that don't really work, that are not really stable. So yeah, we tried to use as much as possible techniques that already exist and that are already proven in the traditional economics and finance. Another very important goal for us has always been legal compliance. So let me be very clear, we have no intention of doing anything that is illegal. So all the decisions, all the design decisions that we have made in the design of our stablecoin have been with the goal of being legally compliant. So we have done our best to be legally compliant. And that's also one reason why we decided to take our inspiration from well-established concepts and techniques from traditional economics and finance, because we believe that this would facilitate legal compliance in the sense that because our stablecoin will be doing something that is already well known to the public and to regulators, it's more likely that our stablecoin will be considered okay from a legal point of view. One principle that we have always followed is simplicity. So we want our stablecoin to be simple to understand. And that's because it enables a clear reasoning about the stability of the stablecoin price. So we also believe that by making something simple, we will make the job of regulators easier, and this will facilitate legal compliance again. And finally, by aiming for something that is legally compliant, that is inspired by well-established concepts and techniques, and that is simple, we hope that our stablecoin will achieve wide adoption. So we hope that these principles and goals will encourage adoption of our stablecoin. And finally, we have managed to design something that is so simple that we can describe it to you in a single slide. So let's move on to this description now. So imagine that you have, we have our contract, right? Our smart contract. And we have some users interested in a stablecoin. So one thing that the users might want to do is to buy stablecoins. And they can do that by interacting with the contract. So they send $1 USD, $1 to the contract. And the contract sends one stablecoin back to the user. So it mints the stablecoin and sends the stablecoin to the user. And of course, you cannot send actual dollars to the contract because dollars don't exist on the blockchain, right? So instead, what you send is an equivalent amount of base coins, where the base coin is either ADA or ERG, depending on whether you're using Cardano or Ergo. And the conversion rate, this X USD BC, is provided by an oracle. So the price of the stablecoin usually is going to be $1 in base coins. And this process can be repeated, right? Users can send more base coins to the contract and get more stable coins. And in this way, the contract builds its reserves of base coins. Then later on, the users might want to sell stable coins. So they send, for example, one stable coin to the contract. The contract will get rid of this stable coin and will send back an amount of base coins that is equivalent to $1 to the user. Now, the problem is that because of the fluctuation of the price of the base coin, there might not be enough reserves to give back dollars for all the stablecoin holders. So in such cases, when the reserve becomes too low, what we do is to give a quantity of base coins that is equal to the reserves divided by the number of stable coins in circulation, this NSC. So of course, you're only guaranteed to get $1 back if there are enough reserves. And if there's not enough reserves, you get a bit less, but at least the distribution will be fair. So every stablecoin holder will have the right to the same amount of base coins. Okay, so this portion of the reserves contains base coins that are, let's say, reserved to pay back the stablecoin holders, is what we call liabilities. Now, since every time users are interacting with the contract, they are paying some small fees to buy or sell stablecoins, and also because the price of the base coin may increase, you may end up having a surplus of reserves. This surplus of reserves we call equity. So the equity is the reserves minus the liabilities. And note that because the price of the stable coin is this minimum between $1 and the total reserve divided by the number of stable coins in circulation, the equity can never go below 0, so we don't have a balance sheet insolvency problem. Now, even though we don't have a balance sheet insolvency problem, and this means that our contract cannot go bankrupt, when the equity goes down to 0, there's still a situation that is not so nice for the stablecoin holders, right? Because they would prefer to be receiving $1 and not less than $1. So to improve on the situation, we have a second type of users, and these users, they would be incentivized to provide more equity to the contract, so that even if the price of the base coin falls, there will still be enough reserves to cover all the liabilities to the stablecoin holders, so that they can get $1 for their stablecoins. So, and they provide this additional equity by buying what we call reserve coins. And the process is basically the same. So they provide some additional base coins to the contract, and they get back some reserve coins. So the contract will mint the reserve coins and will send these reserve coins to the users. And now, how much of the base coins do they have to send to the contract? That's determined by the price of the reserve coin, which is usually the current equity divided by the current number of reserve coins in circulation. So this is similar to what in the traditional financial world is known as book value per share. Now, because because the equity may go down to close to 0, if we just charge the book value per share for reserve coins, we might end up we could end up selling reserve coins for a price that is too close to 0. To avoid that, we have a minimum price for reserve coins, so that the price of the reserve coin is the maximum of the book value per share, and a minimum price that is a parameter of the stablecoin protocol. Okay, so this process of the contract selling reserve coins to potential reserve coin holders is similar to what in the traditional financial world is known as equity financing. Okay, and similarly to stable coins, for reserve coins, the reserve coins holders can also sell reserve coins later on. So they send a reserve coin back to the contract. The contract gets rid of the reserve coin and sends back some amount of base coins to the user. Okay, and this process is similar to what is known as a buyback in the traditional financial world. Okay, now these 4 operations, buying and selling stable coins and reserve coins, they are not always allowed. So we have a quantity that we call reserve ratio, which is basically the reserve divided by the liabilities. And 2 of these actions increase the reserve ratio, and 2 of these actions decrease the reserve ratio. So for example, if you sell reserve coins, you are decreasing the reserve ratio. And we don't want to allow the reserve ratio to become too low, right? So the same for buying stable coins. Like if too many people buy stable coins, the reserve ratio will become too low. So at some point we forbid buying stable coins. So buying stable coins is only allowed while the reserve ratio is greater than a minimum reserve ratio threshold. That is a parameter of the stablecoin protocol. And similarly for selling reserve coins, it's only allowed when the reserve ratio is greater than the minimum reserve ratio threshold. We also forbid buying reserve coins when the reserve ratio is greater than a maximum reserve ratio threshold. And this may seem counterintuitive at first, because you may think, okay, we should just allow the reserve ratio to grow as much as possible, right? The greater the reserve ratio, the greater the stability. And that's correct. But the greater the reserve ratio, the more the interests of the reserve coin holders are diluted. So remember that an incentive that the reserve coin holders have is that thanks to the buyback, they are able to collect profits from the contract. So as people interact with the contract, fees are accumulated. And later these fees can be obtained by the reserve coin holders when they sell their reserve coins. But if the reserve ratio is too high and there are too many reserve coins, then the amount of fees that are collected per reserve coin will be too low. So we don't want this to happen. We want the reserve coin holders not to be diluted. So that's why we only allow buying reserve coins when the reserve ratio is lower than a maximum reserve ratio threshold. With one exception. So if the time is smaller than a certain specified time, certain parameter of the protocol, then you can also buy reserve coins. And that's to provide the initial reserves to the contract when the stablecoin contract is being deployed, right after the stablecoin contract is deployed. If we didn't have this condition of allowing the buying reserve coins when the time is smaller than T star, then you basically wouldn't be able to initialize the stablecoin protocol, because all these conditions would be too strict and you wouldn't be able to violate them. Okay, so that's it. The protocol is explained in a single slide. So let's move on to the next slide. So why is this stablecoin stable? Right. It's stable because it would be futile for someone to try to sell a stablecoin for more than $1, because potential buyers could just buy the stablecoin directly from the contract for $1 instead. And it would also be futile to try to buy a stablecoin for less than $1, because potential sellers could just sell the stablecoin directly to the contract for $1 instead. So everybody would be incentivized to trade stablecoins among themselves for a price that is approximately $1. Under which assumptions is it stable? So the assumption that the reserve ratio is greater than the minimum reserve ratio threshold, and that's because if this is not the case, then buy stablecoins directly from the contract is not enabled anymore. So this is a situation that may happen when there's too much demand for stablecoins, but not enough reserves. So you may end up having to buy your stablecoins in the secondary market for a price that is higher than $1. because the contract wouldn't be selling it to you for just $1. Another assumption is that the equity has to be greater than 0. Otherwise, selling a stablecoin directly to the contract would give the seller less than $1. And finally, another assumption is that there should be no more than negligible blockchain congestion, right? Because the stability depends on users being able to buy and sell the stable coins interacting with the contract. If there is blockchain congestion, they won't be able to interact with the contract quickly enough. Now, are these assumptions reasonable? So the sale of new reserve coins, which is somewhat similar to equity financing, encourages the maintenance of the reserve ratio and the equity conditions. And potential reserve coin buyers are encouraged to buy reserve coins because they profit from the accumulation of fees and because they are protected from dilution by the maximum reserve ratio threshold. Okay, so why did we choose a pegged stablecoin and why USD as the peg? So USD is the most popular peg for stablecoins nowadays. And there's still no USD pegged stablecoin on Ergo or Cardano. So we wanted to provide a USD pegged stablecoin because that's what the public is demanding, and we still don't have that on Ergo or Cardano. We also wanted a stablecoin pegged to a fiat currency because it's potentially useful as a means of exchange, right? Nowadays, we still use fiat currencies as a means of exchange in our daily lives for goods and services, and a stablecoin that is pegged to a fiat currency could be useful for those activities. And particularly a stablecoin that is pegged to the USD could be useful for people in countries with weaker currencies and higher inflation. So because we chose to have a pegged stablecoin and it's pegged to an off-chain asset, this means that we need an oracle. And yeah. There are some differences in how we are going to do oracles in Cardano and in Ergo, but this would be a topic for another talk. And it's important to note that our design could work with other pegs as well. So there's nothing specific about the USD. You know, we could have pegged it to the euro, to some index, to some inflation index, to a basket of currencies, and so on. As long as we have oracles providing the data that the contract needs, we could peg the stablecoin to anything. And I would like to say that even though we have chosen a pegged stablecoin, and we think that a pegged stablecoin addresses the short-term use cases better, I do think that in the longer term, unpegged stablecoins are also worth researching and pursuing. So why did we choose an algorithmic stablecoin? We wanted to demonstrate the capabilities of Cardano and Ergo and the contract languages, Bluetooth and ErgoScript. We wanted to demonstrate an algorithmic stablecoin on UTXO-based blockchains. So the UTXO accounting model presents some additional challenges when you are implementing the stablecoin, and we wanted to achieve that as well. Although we should also note that the design that I presented in the previous slides could also be used for an account-based blockchain as well. And also, an algorithmic stablecoin is more autonomous and hence requires less management, and is less susceptible to misbehavior by a managing entity. So a managing entity cannot just run away with the reserves, for example. The reserves are there locked by the contract, in the contract. So I'm going to show you now some preliminary implementation in Plutus, just to give you an idea of how Plutus contracts look like, but I will not go too much into details on that. So here you can see in Plutus the state of the stablecoin being defined. So you can see that it keeps the reserves and the number of stablecoins in circulation, the number of reserve coins in circulation. Then you can see here the definition of liabilities and equity as I defined in the previous slides. Here you can see the parameters of the stablecoin. You can see that you have the minimum and maximum reserve ratios. You have the percentage fee that is charged in every trade. You have the base coin, the base currency that is used for the reserves. And down there in the slide, you can see the actions that are allowed. And you can see there just two actions, right? Mint stablecoin and mint reserve coin. And you can remember that in the slide that I presented a while ago, we had 4 actions. And the reason why we have just 2 actions in the contract is that the other 2 actions, you can just use the same 2 actions, but using a negative value, right? So for example, if you are buying stablecoins, then you use this mint stablecoin action with a positive value. But if you're selling stablecoins, you use this mint stablecoin action with a negative value. So the implementation is even more minimal than what I described in that single slide. Okay. So this shows what happens when you apply the actions of minting stablecoins or minting reserve coins. And finally, you can see here some code checking the conditions. For example, down there you check that the actual reserves must be greater than the minimum reserves calculated by the minimum reserve ratio, and it must be smaller than the maximum reserve ratio. Okay, now we continue to work on this stablecoin protocol. So some of the things that we're currently looking at include a debt to equity swap to obtain a smoother handling of balance sheet insolvency. We are looking at continuous pricing. So that buying n reserve coins at once will have the same price as buying 1 reserve coins n times. Currently, you can kind of get a discount if you buy lots of reserve coins at once. We're also looking at dynamic fees. This would mean fees growing linearly for buying and selling actions that move the reserve ratio away from an optimum reserve ratio. And the reason why we're looking at this is that it would provide greater robustness against oracle delays and against manipulation of the price of the base coin of ADA or ERG. We're also considering to include debt financing, so bonds in addition to equity financing, in addition to selling reserve coins. We could also replenish the reserves by selling bonds. We are considering dividends. In fact, the initial design of the stablecoin included dividends, but we removed that because there would be some scalability issues related to creating too many transactions to pay dividends to all reserve coin holders. We are, of course, interested in stablecoins pegged to other assets. We are also looking at reserves consisting of a basket of assets. So instead of reserves being only ADA or only ERG, we could also include other assets there. Yeah, pegging the stablecoin to other assets is trivial, but having a reserves consisting of a basket of assets is a bit more complicated because you have to think about the optimal basket composition. Okay, we have already done some stability simulations, but we intend to do more, and we also intend to formally verify the stability. We are also looking at governance and updates because, you know, the stablecoin has a few parameters, as you have seen. And the question is, how do you set these parameters, right? And one interesting possibility is to allow the users to update these parameters based on some governance mechanisms. We are also looking at KYC and AML. And one very interesting thing, in the case of Cardano, we are looking at staking. So basically we can take all the reserve that is there in the contract and stake it and earn some rewards for staking and possibly distribute these rewards to stablecoin holders or reserve coin holders. So as I mentioned, we took most of our inspiration from traditional concepts and techniques from economics and finance. But of course, we also looked at all the stablecoins out there. We looked at dozens of stablecoins, and 3 of them were particularly influential to us. So one of them was seigniorage shares. So there are some similarities with ours, right? In seigniorage shares, the shareholders profit from the contract, like the RC holders, the reserve coin holders profit in our case. One difference is that in their case, profit comes from seigniorage, and in our case, it comes from trading fees. In their case, there's no backing, and stability is based on changing the supply of the stablecoin. So I do think that researching unbacked stablecoins is very interesting, but I think that it's harder to achieve stability in that way. So that's why we preferred a stablecoin that is backed. Another one, of course, DAI. So DAI is crypto collateralized, and this is similar to crypto backing, but not exactly the same. So there's a difference between collateral and reserve. I will not go into details on this in this talk, but it's a subtle but important difference. And I think it's important because when you don't have reserves but you have collateral, the contract could be interpreted as a kind of bank with 0% reserves, you know. And we were concerned about legal aspects related to this. So when you hold DAI, you cannot sell your DAI directly to the contract, except if you're a vault owner or if there's a vault liquidation auction. So in our case, the stablecoins are always sellable to the contract by anyone immediately. So we believe that this will make the stablecoins more attractive to potential stablecoin users. And on the reserve coin side, like in DAI, you are penalized for providing collateral, right? You have to pay the stability fee. Whereas in our stablecoin, if you're a reserve coin holder, you are rewarded for providing reserves. So you are rewarded because the trading fees are accumulated in the equity, and you can sell your reserve coins and get that equity. You can get that fee, those fees at some point. Another one that was highly influential for us was static coin and risk coin, and it was probably the most influential of these 3. So a risk coin is similar to a reserve coin. One difference is that the risk coin's focus is on the leverage that it provides over the base coin. Whereas in our case, the focus of the reserve coin is on I mean, if you're a reserve coin holder, your primary interest is to profit from the contract through the accumulation of fees, of trading fees, right? You also get a little bit of leverage, but that shouldn't be your main focus, I would say, if you're a potential reserve coin buyer. With Statcoin and Riskcoin, there's no dilution protection for Riskcoin holders. So there's no maximum reserve ratio. And there's no reserve protection for static coin holders. So there's no minimum reserve ratio. And there's no fair pricing of stat coins when the reserve ratio falls below 1. So this means that there can be bank runs, like if the reserve ratio falls below 1, then the stat coin holders can run to sell their stat coins back to the contract, and the ones who manage to do that first will get more reserves than we'll get more base coins than the later ones. Okay, so in summary, the presented stablecoin contract take some of the responsibility and role of banks or central banks, depending on how you look at this. It behaves a bit like a full reserve central bank-like autonomous entity using automatic open market trading and market making for stabilization, equity financing for replenishing the reserve, and buyback for rewarding the reserve contributors. And to the best of our knowledge, the implementation in Ergo is the first algorithmic stablecoin on a UTXO-based blockchain. And finally, a final remark, you should use and interact with this contract with caution, right? So you should keep in mind that you are interacting with an autonomous software entity that follows its rules blindly and irreversibly. The best we can do is to make the rules be like the traditional rules that are already accepted by society and regulators, and explain these rules clearly to you. So we can make an analogy with self-driving cars, A self-driving car still needs to comply with traffic rules, and in our case, we are making our stablecoin in a way that complies as much as possible and as much as we know with the rules. But the builder deployer of a self-driving car is not the car's driver, right? And it would be strange to require a driver's license from the builder or deployer. So thank you very much. It was a pleasure to present the stablecoin to you. Bye.
Hi, in this talk I'm going to be discussing about the AgeUSD stablecoin, also known as the Ergo USD stablecoin, because it pegs USD to Ergo, the Ergo's base currency, the ERG. And in this talk I'm going to be giving you a high-level overview of the smart contracts used in the stablecoin. And this is joint work by Ergo, IOHK and Emurgo. So what exactly are we trying to achieve in this stablecoin? This slide gives you a high-level overview of the concept behind the stablecoin and the goals that we want. So it doesn't have anything to do with Ergo or UTXO. It is the same if you would implement this in Ethereum, for example. So what exactly is a stablecoin that we want? Yeah. So it is trying to emulate a centralized bank, and this bank holds three assets. The first of them is the stablecoin tokens, which are issued by the bank. The second is the reserve coin tokens, which are also issued by the bank. And the third is the base currency, which is the currency of the underlying blockchain, such as ERG, the native token of Ergo, or Bitcoin or Ethereum. So in this talk, I'm going to be assuming that the base currency is ERG, and everything is going to be in terms of ERG, yeah, from now onwards. So the bank is supposed to allow two kinds of exchanges between itself and the people, right? And these are the SC exchange, where we exchange SC with the base currency. So bank will either take or receive stablecoin tokens and give or receive base currency, right? Similarly, the other exchange is the reserve coin exchange, where the bank and the users will exchange reserve coin and the base currency. So these two exchanges need to have the rate, yeah. So the rate is defined as follows. So SC rate is the rate at which the stablecoin is going to be exchanged, either purchased or redeemed. So what this means is how many in the base currency do we need to pay for one stablecoin, yeah. So the units will be ERG per stablecoin. Similarly, we have the RC rate, which is how many of the base currency do we have to spend to get one RC token. The units will be ERG per RC. Finally, we have something called the peg rate, which says how many of the base currency do we have to exchange for $1 US, where US dollar is the currency that we want to peg to, right? So the units will be in ERG per USD, right? So where do we get this peg rate from? Because the other rates we can understand, but the peg rate is something that has to come externally, because the US dollar is not in the bank's control, right? So the peg rate is coming from an external source. And the goal of the stablecoin is what? The goal of the stablecoin should be that the SC rate is as close as possible to the peg rate, yeah, as close to the ratio of SC rate to peg rate should be as close to 1. So it can be slightly higher or lower. So it can be, for example, 0.099 something, or it can be 1.001. It can be very close. Yeah, it need not be the same. In fact, it will not be the same many times, but it should be very close to the peg rate. And that is what we want the goal of the stablecoin to be. Yeah. So SC rate should be as close to the peg rate, ideally the same as the peg rate. So we should be able to exchange SC tokens for ERGs at the same rate as which the ERG and USD can be exchanged on some other external exchange, or via some external source, the rate that we receive. And RC, the reserve coin, is an additional token, right? Used to handle fluctuations. So many times the ERG USD rate will go high and low, but we still want to keep the SC pegged to the USD. So the RC will be used to handle the fluctuations. Yeah, it's kind of a shock absorber. So I'm not going to go into the details of how the stability works here, because that is covered in a separate talk. Here, I'm just going to discuss how the stablecoin, as the algorithm we define, is going to be implemented on top of Ergo. So as I discussed, there are two rates that we need for the exchange to happen, right? One is the SC rate, the rate at which one SC can be exchanged in terms of ERGs, yeah. So this needs 3 inputs. The algorithm needs 3 data inputs, 3 data to calculate this, 3 pieces of data. So the first input is the current base currency reserve that we have, denoted by B. So it will be the amount of ERGs held by the bank. The second input is the amount of stablecoins in circulation, so called S. It will be the total number of stablecoins held by the people, stablecoin tokens that have been purchased from the bank, yeah, minus the stablecoins that have been redeemed. Yeah, so it will be the actual stablecoins in circulation, not the actual purchased ones, but the purchased minus the redeemed ones. And finally, we also need the ERG-USD rate from an external source denoted by E. Yeah, so this is the three pieces of information we need for computing SC rate, and let this be given by some function f. Yeah, so there is an algorithm that takes input these three pieces and then returns the SC rate. Similarly, RC rate is determined using 4 parameters. The first parameter is the current base currency reserve as before, which is denoted as B. The second is the SC in circulation, denoted as, which is the same value as before. The third value is the reserve coins in circulation, which is similar to the SC in circulation, but now applied to reserve coins, and we denote this by R. The fourth value is the rate, external rate, E, that we used earlier as well. Yeah, and then the RC rate is determined using a formula given by algorithm G, which takes as input these 4 values. So a little bit more detail, this SC rate, how it is actually implemented. So here we have a function that returns SC rate. It takes us 3 inputs, as I said, B or base reserve, SC in circulation or S, and E in the previous slide, which was the external ERG-USD rate, right, from an external source. And then it has this formula, which I will not discuss, but I'll just leave it there for a couple of seconds for you to see. And it computes the SC rate using this formula, and it returns that. Then the bank will use this rate to exchange the SC tokens. Similarly, I'll show you the formula for RC rates, the rate at which the bank exchanges RC tokens. And as you can see, it takes 4 inputs and then outputs the rate, yeah, what we need. So without going into details, which I'll refer you to the other talks and the documentation to actually understand the details of the formula, why it is like that. I'll just assume that this is the formula we have to implement without understanding why. So considering the previous slides, right, we need to get the rate from an external source called E in the previous slides. Yeah, we will also refer to this as the ERG-USD rate. Yeah, and this must come from a reliable external source. So what is this external source, right? So in many blockchain implementations, this is done through oracles. So what is an oracle? Oracle is simply a trusted party that takes data from an external source and then posts it onto the blockchain at regular intervals. So this is something that a few blockchains have tried, but this concept of a single oracle has an inherent issue. It is a single point of failure, right? And you have to trust this oracle without any alternatives, right? Basically, you have no choice. You have to trust the oracle. So this leads to a few issues, right, which make this system not so reliable. So in Ergo, we have the concept of oracle pools, which is taking the concept a bit further in terms of reliability. So oracle pool behaves like oracles. It posts data to the blockchain on regular intervals. The data is taken from an external source, but the difference is that the data is more reliable, right? So we have to trust the source of the data, the data posters less in this scenario. I'll get to that in a minute, how it works. So basically what it does is that instead of one party submitting the data, a number of parties submit their own data points. In this case, it will be the rate. And each of these parties is an oracle. And what the pool does is that it takes the average of all the rates and then uses that as the data point to publish on the blockchain. Yeah? In this case, the ERG-USD rate. And each rate must be within a max deviation, right? So you can't have like the oracles post very extreme rates, right? One oracle cannot post 10 and the other oracle posts 20. So it has to be within a very small margin of error, each of them. And then there are some other checks, right? Like the rate must be fresh. You cannot use an old rate. Yeah? It must be posted within the last, say, 6 hours or so. So without going into details how it works, I'll refer you to the Oracle pool documentation. This figure explains how the Oracle pools work in a very brief manner. So on the left side, you see that there are 5 oracles. They have posted data points. So this data point is some value which we don't care what it is. In this case, it is the value of US dollars for something. Yeah. So as long as they all understand that what units they are posting and the purpose of that, we don't care what that is. We just call it data points. And they may be slightly different, right? So the average is the finalized data point, which is what the pool will post on the blockchain. So this is showing one instance of taking the average, and the right side shows this happening multiple times. And the system is divided into 6 hours, phases of 6 hours, where the data points is posted. So approximately the Oracle pool will update its data point every 6 hours. And you can refer to this URL for more details on how this works. But for now, we'll assume that this is a reliable source of data because it is not just one, but multiple source. And so even if certain sources are untrustworthy, the checks implemented will either ensure that the data point is not considered or its effect is very low in the final data point. So before we start discussing more about the Ergo stablecoin, I'll quickly describe a few details about Ergo itself, right, which is relevant to this talk. So this is needed to understand how the implementation is done, how the smart contracts work. So what is Ergo? Ergo is a UTXO-based blockchain. It is basically similar to Bitcoin, for example, but a more advanced version of Bitcoin, you can say. And it has advanced DeFi features. So a few of them are listed here, but there are a few more. The first of them is ErgoScript, which is a advanced Scala-like programming language for writing the guard scripts. And guard scripts are also called smart contracts in UTXO-based blockchains. So ErgoScript, since it is taken from Scala, it also supports functional programming, which allows us to write very powerful contracts in a very compact way. The third feature that we have is that of secondary assets. So Ergo supports secondary assets. Ergo has the primary asset, which is the primary token called Ergo. Yeah? It is the native token of Ergo. And like Ethereum, Ergo also supports secondary tokens, right? These can be issued in transactions, and they can be NFTs, which is non-fungible tokens, and ordinary tokens. Yeah? I'll get to that in the next few slides, what these means. The fourth feature is that Ergo has a very rich context. The ErgoScript execution environment has a very rich context. So what is a context? Context is the information available to a program during execution. So in this case, it is the information available to the smart contract when it is spent. And this information can be normally in a standard blockchain, it will be the information of the UTXO itself, right? It will be all the information that is in the UTXO at least. The contract should be able to access all the data within the UTXO. But Ergo is slightly more advanced. It allows you to access the data of other UTXOs, right? But not every UTXO, the other UTXOs in the transaction, right? So Ergo transaction consists of input, output, as we'll discuss later. So the ErgoScript program allows you to access the other inputs in a transaction, right? So you can say that the first input should be of this structure, the second input should be of so-and-so structure, and I should be the third input, and the first output should be so-and-so. You can specify all these conditions in the guard script, right? And the script will evaluate to true only if all these conditions are satisfied in the spending transaction, right? So the context is quite rich. And this allows us to also design Turing complete programs on top of the Ergo blockchain, right? So although not very efficient, but using this rich context and multiple boxes, we can have Turing complete scripts. This is just for information. It is not really useful in a practical sense. it also has some, Ergo also has some scalability features, right? So without too much details, since they are not relevant to this talk, it has something called the storage rent, which means that you can't kind of put junk on the blockchain, right? You must pay rent for storing something on the blockchain, right? So if a box stays on the blockchain unspent for more than 4 years, right, then a certain amount of native tokens, nanoworks, are deducted from the box. So a copy of the box is created, everything is preserved except the amount of ergs and the box ID. Yeah? Box ID will obviously change because the box is spent and a new box is created. So this ensures that the blockchain junk eventually gets cleaned up over a long run. Yeah. So this is kind of automated garbage collection. Yeah, on the blockchain. And this allows also not only blockchain to be compact, but it also gives miners a steady flow of income, right? They can always get income from the storage rent in addition to the transaction fees. Additionally, Ergo supports light clients. So Ergo has various techniques that allow very lightweight clients, similar to what SPV clients in Bitcoin have. But instead of SPV, these clients will give you full node security. So, and it also has something called NIPAPOs, which allow very compact proofs about states of the blockchain. So I'll not go into too many details. In fact, these are not related, so we don't need to discuss this. Let me discuss what's a UTXO, right? Without referring to Ergo for now. This is just a UTXO in any blockchain, say Bitcoin. So a UTXO is basically an immutable box, yeah, nodes keep a set of UTXOs. So the blockchain ensures the nodes are in sync. Every node has the same set of UTXO if they have the same blockchain height. So the protocol ensures that the nodes have the consistent UTXO set, right? And what is a UTXO set? You can think of it as a bag of boxes, and a box is a UTXO, right? So each box has unique ID. So a transaction removes several boxes from the bag and adds some new boxes to the bag. The boxes that are removed are called the inputs, and the boxes that are added are called the outputs. And the scripts in the inputs must be evaluated to true. Only then the transaction is valid, right? Another thing to note is that the boxes in a bag cannot be changed, so they can only be added and removed. And in case we want to emulate a box that is changed, we just create a new box with the same properties, right? So even though the box is getting created and destroyed, it behaves as if it is in the box for a long time. Yeah? So this diagram shows how UTXOs look in multiple transactions, right? The last diagram showed how a single transaction manipulates UTXOs. Here we see how multiple transactions are linked using UTXOs, right? So one thing we can observe is that the input of one transaction is the output of some other transaction. For example, this box, the input of this transaction is generated as an output of this transaction, right? And every such input is actually an output of some other transaction, right? And the dashed boxes represent unspent boxes, while the boxes with thick lines represent spent outputs, right? So we can see that some outputs are spent and the others are still unspent. So these are in the bag, while these are removed from the bag. And let's look a bit more detail into what a UTXO of Ergo looks like, right? So this is what an Ergo box or a UTXO looks like. A box has 10 registers numbered R0 to R9, and the first 4 of these R0 to R3 are mandatory. Basically, they are reserved for protocols. The protocol data, they are as follows, right? The first register contains the nanoworks. This is the primary token, how many primary tokens it has, or the native currency. And the second register has the guard script. So for example, it could say that the signature of some public key X must be provided when spending the box. The third box has the creation info, basically, which is basically unique to the box. And we will not be too much concerned with this as long as we know that it's going to be there. So we will not be using this in our protocols right now. R3 contains assets, basically, which are a sequence of token ID amount pairs. And token ID is a 32-byte value, while amount is a long number, a non-zero value. So R3 can be empty if the box doesn't have any assets, or it can be have some one or more pairs if the box has assets. The other registers R4 to R9 are optional, and they can have data for our smart contracts, right? We can always use the other R0 to R3 in our smart contracts as well, but we can use these two other registers to store our own data as and when needed. So where are they actually coming from, right? Each transaction can issue at most one asset. It need not issue an asset, but if it wants, it can issue at most one asset, right? And this asset is a token ID. The token ID of this asset is the first input box's ID. So the transaction that issues it will have one or more inputs, right? At least one input will be there. And the first input's box ID will be the ID of the issued asset, right? So since each box is unique, so each asset ID is also unique. And the amount can be arbitrary, so you can issue as many assets as you want. And NFT is simply an asset that is issued in a single quantity, right? So we can check the blockchain and see that it is issued only a single amount of that token is issued. Then it is an NFT. And NFT is used for authenticating boxes. So for example, if we want to authenticate a certain box, anybody can create a copy of the box, right? But if it contains a certain NFT, right, then we can be sure that it is the authentic box because it was issued in quantity 1, right? So imposter box cannot have that. Yeah, it is only in the genuine box, right? That's the assumption we'll make in a lot of our protocols. So moving on. Earlier I showed you how a transaction looks like, right? See, a transaction basically has a set of inputs and a set of outputs. So the inputs are the boxes that are removed, and the outputs are the boxes that are added. Ergo transaction is slightly more advanced, right? So it has these inputs and outputs as before, but it also has something called data inputs, right? Which are additionally read-only boxes, right? So recall that the script in the inputs is executed, right? So, and these boxes are destroyed. So they are removed from the bag, and whatever the code inside the script is must evaluate to true for the transaction to be valid. This is not so in the data inputs, right? So like inputs, the data inputs must exist in the bag, but they are not destroyed. So they are basically taken from the bag and put in the bag, you can assume. And the script in this is also not executed, right? So these are just used for reading their registers, but you don't really need to, you don't execute the scripts. You just take the data from them and use it for in your protocol, right? And then they have the outputs. The transaction has outputs as before, right? Similar to other UTXO systems. So moving on, how does Ergo stablecoin transaction look like, right? So Ergo stablecoin transaction looks as follows, right? It has 2 input boxes, 1 data input box, and 3 output boxes, right? So let's first discuss the types of boxes in a exchange transaction, right? So in a stablecoin exchange transaction, will exchange either redeem or purchase either stablecoin or reserve coin, right? So I'll get to that in a minute, but let's first discuss the types of boxes that we have, right? So the first is a bank box. So this is the existing bank box. This is the one that is going to be destroyed. And this is a copy of the bank box which will be created, right? So it will preserve all the things we need, and it will change only certain things. So this is the bank box. Then there is this funding box. So the funding box contains it is not really part of the protocol. It contains any additional assets, basically the native tokens or the secondary tokens that are needed, that are deficient, right? So for example, if our protocol needs, this input has 10 ERGs, and this output has, the sum of these outputs is 20 ERGs. So this additional 10 ERGs will come from the funding box, right? So any deficient tokens or nano ERGs will be from the funding box, right? So every transaction that we have will assume to have a funding box if there is any shortage of funds. Similarly, there will be always a fee box which pays the transaction fee, the mining fee, and sometimes we will show this box, sometimes will not. But we'll always assume that this is there, yeah, because without this the transaction won't be mined. So fee box is necessary, and then this receipt box, yeah, this is the box of part of the protocol. So this receipt box contains the details of the purchases, right? It contains the how much information about how many stablecoin tokens have exchanged. It also contains any deficient, any purchased stablecoins or any redeemed ERGs, right? It will contain these extra assets as well. And then there is this Oracle pool box, which is basically the box that we use to get the rate from. So notice that it is part of the data input because we don't really need to execute it, and we don't have the ability to execute it. In fact, the script in this box cannot be executed by every transaction. In fact, it has a very special script. So we are only going to use this as a data input, right? It will contain in its register R4 the value that we need. And let's look at the types of transactions that we have. Yeah, we have 4 types of transactions in our exchange. So one is the purchase stablecoins, where the funding box has any ERGs that we have to give to the bank, and the receipt box will have the SC tokens that we take from the bank. Yeah, we purchase from the bank. The other is the redeem stablecoin transaction, where the funding box has the SC tokens that we want to give to the bank. We want to redeem those tokens, and the receipt box will contain the ERGs that we get in exchange for those tokens. Then we have the purchase reserve coin transaction and the redeem reserve coin transaction, which is similar to the earlier transaction but applied to reserve coins. So what is the Oracle pool box, right? This is the box that contains the rate. Let's look at this box in a bit more detail. Note that this is a data input and the script will not be executed. So it contains the following tokens. It contains the NFT that uniquely identifies this Oracle, right? We call this Oracle pool NFT, and its quantity is 1. So in the third register, in the fourth register, R3, it stores this NFT. And then it has 4 additional registers, R4, R5, R6. R4 will have the rate that we need, yeah, and R5, R6 will have some data that we don't need in our protocol, so it's not relevant to us. It will have some data that we don't care for now. What does the bank box look like? So bank box looks as follows. This box, first of all, this box will be the input to the transaction. So the script will be executed, right? So whatever the script it contains, the bank script, it will be executed. It has the following tokens. So it has the bank NFT that uniquely identifies the bank box. So nobody can impersonate the bank and cheat somebody, because the NFT must exist, yeah. And if we check for an NFT, then we know that the box is authentic. The other tokens will be the SC tokens that it wants to emit. It wants to give to other users, and the RC tokens it wants to give to users in exchange for ERGs, and in certain quantity, right? So here I have given some numbers as an example. It also will have 2 registers. R4 will have the RC, the stablecoin in circulation, current stablecoin in circulation. That's a long value. And R5 will have the current reserve coin in circulation, also as a long value. Finally, the monetary value of the box, the native number of nano ERGs, the native tokens, will be considered the base reserves, right? So that's what a bank box looks like. Finally, what does the receipt box looks like, right? Receipt box is as follows. So it will be owned by the user who issues the transaction, right? Let's say the user's user is Alice, identified the public key, and it contains the following tokens, right? So it contains the RC or SC tokens that have been purchased in case it is a purchase transaction. It contains R4 register. R4 contains the delta in SC or RC. So if it is a purchase transaction, then this will be a positive value, and if it is a redeem transaction, then this will be a negative value. And R5 contains the delta in bank reserves, yeah, the base currency bank of the bank. And the monetary value of the box will contain any redeemed nano ERGs. right? So if it is a redeem transaction, then it will contain the random that were redeemed from the token. So let's look at the bank box contract in a bit more detail, right? So the contract is stored in R1 of the bank box, and it has the following conditions at a high level, right? Remember the rule that we had for exchange, the algorithm we had. So we are going to implement that using the bank script. So the bank script has the following requirements, right? So that it first of all, it says that it has to be the first box in the transaction, right? First input in the transaction. The bank box has to be the first input in the transaction, right? And the first output of the transaction should be a copy of the bank box, right? Where the bank NFT and the script are the same. So the script and the NFT value must be preserved, and the rest of the token will be updated as per the formula. Yeah. So if it is a SC exchange transaction, then this value will be updated and this value will be the same, will be preserved, and base reserve will be always change. Yeah, because this will be the delta in this. There will be some change in base reserve whenever there is a redeem or exchange of any type. Similarly, the value of if it is a SC exchange, and this value will change and this value will be preserved. Otherwise, it will be the opposite of that. So these R4 and R5 contain the stable coins in circulation and reserve coins in circulation, and these will be updated as per the exchange. The other requirement of the bank contract is the second output, right? This second output must be the receipt box, and the receipt box contains the information that we used for calculating the formula, right? So R4 of the receipt box will be the delta of the tokens exchange, either SC or RC tokens, and R5 will be the delta in the base reserves, right? And we will require that R5, the delta in base reserve contained in the receipt box, matches the delta in base reserve as per the formula of the exchange, right? That will be the requirement. And the data input, there will be only one data input, the first data input. That should be the Oracle pool box, which gives the Ergo USD rate, and this is identified by the Oracle pool NFT ID. This NFT ID is also hardwired in the bank box, and we'll assume that R4 of this Oracle pool box contains the rate that we need. The following are the exchange rules. So only one of the tokens can be exchanged in one transaction. So you can't exchange both SC and RC tokens at the same time. You can either exchange RC tokens or you can exchange SC tokens at a time. And the SC rate, RC rate is determined using the formula that I described in the beginning. The only missing piece was the Ergo USD rate, which we now have from the Oracle pool, the R4 of the Oracle pool box. And the base reserve delta is based on the SC rate and the RC rate as per the formulas. And additionally, there is a fee in base currency added to the delta, base reserve delta, right? And there is another condition that the final reserve ratio must be between some minimum maximum value. In this example, I have shown the minimum as 400 and the maximum is 800, but these are just some values and you can have some different values as well, yeah. So the details of this final reserve ratio for this, please refer to the documentation of the stablecoin. Yeah? Why we have this this max and min reserve ratio. So let me summarize what this Agenor USD stablecoin contract is, or Ergo USD stablecoin contract is. So there is a single box which has the NFT that emulates the bank box. That emulates the bank. This is called the bank box, and it contains the unminted SC and RC tokens, and its register also contains the SC and RC in circulation, right? And then its smart contract contains the rules for exchange I had described earlier, right? And there is an Oracle pool box used as data input that contains the external rate in Ergo USD, and anybody can spend the bank box. We call this an exchange transaction, as long as the rules of the exchange are followed, and the rules additionally to the exchange rules are that the receipt box contains the tokens exchange and the receipt box register hold the delta in the tokens, and the new box is created with the NFT and balance tokens as per the formula. So this kind of summarizes how the Ergo USD works. In the next talk, I'll discuss how we can update this contract, right? So for example, just looking at this contract, suppose we now have this final reserve ratio, right, after the exchange. What this means is that after the exchange, right, whenever we buy RC tokens, so this is applicable only to certain exchanges, not to all exchanges, right? For example, this is not applicable to redeem stablecoins, but this is applicable to redeem RC and purchase RC, right? So what this means is that the final ratio, the final reserve ratio must be between 400 and 800%, right? And suppose we decide that, okay, 800 is too low, right? We want to make it 900, right? So we want to update the contract and change this value, right? But the problem is that the smart contract requires the script to be preserved, right? Recall that the script must be preserved, right? So now we cannot, it's kind of fixed forever, right? So we want to be able to update this, right? So in the next talk, I'll discuss how we can achieve updation of this contract. And yeah, so that kind of summarizes the introduction to AgeUSD stablecoin. Thanks.
Hello once again, this is Robert Kornacki, and welcome to the Sigmaverse. The Sigmaverse is a new website which you can go to at sigmaverse.io, which we released back at the end of 2020. And the intention of this website is to be your portal currently to the dApp ecosystem of Ergo, but in the future, for this to be the user-facing go-to search engine portal and overall website to allow you as a user, as a developer who doesn't really care or might not be specifically interested in the possibilities of, what kind of proof of work is Ergo using specifically. On the protocol level, can miners vote on chain? What is the core language that Ergo script, the smart contract language, compiles down to Ergo tree? What's all the syntax for all that? None of that really is all that interesting for most people, right? Unless you're, an academic, you're super technical. All of that is cool, and it's very vital for a blockchain because you need good fundamentals. However, at the end of the day, for end users, what we care about is what's in the ecosystem. What kind of dApps do we have? What frameworks do we have to allow developers to build stuff? What kind of educational material do we have so we can onboard people? And how do we synthesize all of that data, links, papers, guides, put that all together into one portal that you can visit and find everything? That is our intention with the Sigmaverse. And so currently what I'm going to be introducing you to in the Sigmaverse today is the first version. And this version is quite simple, but I think it is great as introductory, which can already link to others to kind of show them what's up, what's going on in the Ergo ecosystem in the perspective of dApps. So as you currently can see on the website at hand, we have a nice Ergo knot, floating there in the Sigmaverse, most likely in the middle of space, I'm guessing, with a nice Sigmaverse logo in the top left, and then the main chunk at the bottom. As you see here, we have a list of the current dApps in the ecosystem. And so we have the auction house, the Ergo Mixer, Ergo Utils, which allows you to do a bunch of useful utilities like minting NFTs, minting normal tokens, doing airdrops. And so if this is a website you haven't heard about before, I would recommend you go and check it out because there's new tools being added every few weeks. And so it's a great resource that I know not many people in the ecosystem have tried out yet. Of course, we also have Oracle pools, Zero Knowledge Treasury, and soon, as once the stablecoin that we're announcing and releasing all the code and specs and everything for today, called AgeUSD, which you will see soon in this event, that too will be added and any other dApps that come out. And so, as you can see here, if we're searching for auctions, we have the Ergo auction house, and this acts as kind of a search engine and a registry for the current dApps in the ecosystem today. With the search, it searches the title and the description, and so this allows us a lot of power, because as we start to get more and more dApps within the ecosystem, with everything scattered on different websites, different UIs, this will be the central hub. And especially once we add in the ability for searching development tools, frameworks, educational material, both for end users and developers, this is really going to be your portal to the Ergo universe. And so I highly recommend checking this website out, bookmarking it, sending to others who are interested, what's up in Ergo, checking this page out, once every couple of weeks, once a month, as even if you're not following all of the updates, which I highly recommend you do in the Ergo ecosystem, this still acts as a great gateway to see what's available in the ecosystem. So I highly recommend that you check out sigmaverse.io and enjoy seeing week by week by week how we keep expanding and growing the ecosystem.
Hello everyone, welcome to Ergo Summit 2021. My name is Marek and I'm a co-founder of 5 Binaries, an infrastructure development company based in Prague, Czech Republic, and today I'm going to talk to you about Ergo-Bootstrap, a project we did with help from Ergo Foundation. So what is Ergo-Bootstrap? Ergo-Bootstrap is a really simple tool that will help you quickly deploy an Ergo Blockchain node with a handful of useful tools that you may need in your journey of developing dApps on Ergo. So let's get started. First question for all is, where can I get Ergo-Bootstrap? So Ergo-Bootstrap is right now currently hosted on the Ergo platform GitHub organization. So if you just browse to the github.com/ergo platform/ergo-bootstrap, you will see the project itself. You will see some introduction and key features, installation and basic usage. But however, in this demo, I'm going to show you how to deploy the cluster. So the first thing to do is to install the Ergo Bootstrap. Let's do that. Okay. We have cloned the repository of Ergo Bootstrap project, and when you enter the directory and look around, you can see we have just one single executable script here. When we try to run it, it offers different options. The first one is for initializing the whole cluster. Then we can stop and start the cluster. We can get the status, the state of the cluster, and then naturally we can destroy it. So let me show you how to bootstrap a new cluster. Let's call Ergo Bootstrap init. And as you can see, the bootstrapper is offering us a number of options. It is important to say that at the core of every Ergo Bootstrap, there is an Ergo Blockchain node that is always deployed. So if you want just the node, you have to reply no to all of those questions. However, it may be useful when you are developing your dApps to have those tools available. So the first one is Ergo Explore API, which is an API on top of the Ergo blockchain node. Of course, for our demo, we will initialize all the components of Ergo Bootstrap. We will also initialize the front end. So this is the basically Ergo Explorer you are used to. However, this one will be run on top of your Ergo blockchain node. Yoroi backend, Yoroi, if you don't know it, it's a lightweight cryptocurrency wallet, and their backend is just a lightweight API. So in case you are developing something like a wallet, it may be useful to use the Yoroi backend instead of the full Explorer API. And lastly, it asks us if we want to set up monitoring for our clusters. So this will actually set up blob collection and monitoring of your Ergo Bootstrap. Let's choose yes here. Okay, so once we have chosen which components we would like to install, the Ergo Bootstrap is asking us to initialize it. This step usually takes about 10 minutes if you are doing it for the first time. However, as I did this before the demo, it will just take a few seconds. So as you can see, Ergo Bootstrap is deploying and starting a number of Docker containers with our services. Okay, and it's done. Now we can use the command Ergo Bootstrap status to see what is running. So here in the first portion we have the different containers with the state and the ports they are forwarded to, and here at the bottom we have the different components also with the URLs where we can access it. So for example, we have the Ergo node panel. So if we open it, we can see the state of our node is actually already synchronized and the current height of the node. We have the access to the API as well, so we can try it. it's 93. Of course, here we can see the height as well. And we can also see the different blocks, right? Okay. So we see that the Ergo node is running. Now we can actually have a look, for example, to the Explore API. It's 8080 API v0 blocks. And we here see the output from the Ergo Explorer API for the current blocks. Let's open and see the Ergo. This is the front end for Ergo Explorer running locally on top of your Ergo cluster. So you can see actually everything that you can see on the Explorer, but on top of your local cluster. And we have the let's try if Yoroi API is up. And lastly, of course, we have the Grafana metrics. Here you can explore your local cluster. So for example, if you go to a local collector, you can see what your containers are doing. So for example, we will get everything from my hostname. So for all the containers, you can see the node is synchronizing and so on. And of course, you can write your own queries on top of Ergo Explorer database. Okay, so that's it. I really hope you find Ergo Bootstrap useful. We are open for any suggestions or even pull requests, so please open an issue on the GitHub. And lastly, we would like to thank Ergo Foundation for sponsoring a grant to build this tool. And I would like to refer you to the presentation about Ergo Foundation grants that is also happening during the Ergo Summit. So if you have a good idea how to help the ecosystem and would like some grant for it, so please don't hesitate to apply. Thank you for your attention and have fun.
this is Robert Kornacki, and in this talk, we're going to be looking at the Ergo Headless dApp framework. So, for those of you who haven't seen either my previous recorded video outside of the summit about headless dApps, or haven't read any of the documentation we released or tutorials or anything, let's start from basics of what is a headless dApp, then we'll move on to the headless dApp framework, and what does this mean for the Ergo dApp ecosystem and for current existing dApps and coming dApps. So, what are headless dApps? To start, especially in the UTXO model, let's talk about a dApp. A dApp is a combination of the off-chain code, on-chain code, and some sort of a front end. So the on-chain code are the smart contracts that run on-chain. The off-chain code is the code which creates the transactions so that you can interact with the on-chain code. And so in the UTXO model, especially in the extended UTXO model, the vast majority of computation and logic actually occurs in the off-chain code, and then in the smart contracts, you write declarative checks that whatever you processed in the off-chain code is valid. And so in this way, we actually improve efficiency of our contracts by offloading computation as much as possible off-chain and keeping the on-chain code short, concise, less bug-prone, and more efficient in the extended UTXO model. So, what this means is that we have three parts, right? And so the on-chain contracts are written in Ergo script and Ergo. The off-chain code is where the vast majority of logic lives. And what we need is a generalizable form to write this off-chain logic so that it is trivial and very straightforward for front-end implementers to create a front-end. So, you can go to a website, or you can open up a wallet, or you can open up a desktop app, and you have, a front-end GUI, a graphical user interface, that clearly shows everything that's going on in the dApp, and it provides you with the ability to submit input, connect your wallet, and then perform whatever you need to in order to, say, mint a stablecoin, for example. So, headless dApps are the idea that what if we create the off-chain code and package it in such a way that it is a pure and reusable library written in a language like Rust, which compiles to pretty much any target, whether that's desktop, mobile, web, etc. And so the idea of headless dApps is that you write your off-chain code once, and then you compile it using the headless dApp framework, and you can compile it to whatever target you're aiming at, say web or mobile. And then with that, you have everything already written automatically so that you can create a front end. What this means is that if I create a headless dApp, like we did for the AgeUSD stablecoin, now that that is written, anyone can deploy a instance of AgeUSD so that it's live on the blockchain. At that point, simply compiling the AgeUSD headless dApp with all of the parameters for that given instantiation that's deployed on chain, now anyone can actually create a front end. And so with the AgeUSD release, we've already implemented WASM compilation and WASM support. And WASM is WebAssembly, And this means that we have full integration into web browser-based dApps. And so with the release of AgeUSD, we wrote a headless dApp that allows people to compile for desktops, and we also integrated web. It's also possible to target mobile, but that requires a little bit of extra work. And so we've effectively created this ability for anyone to implement front ends, and also we've also added the ability for transaction assembler support, if you've heard about that, which allows anyone from any wallet to use the dApp. And so, before I get ahead of myself and talk about AgeUSD for an hour, that's not the talk at hand. So with headless dApps, as can be seen with AgeUSD, we wrote the off-chain code where the vast majority of logic for the smart contract protocols is at. We wrote it as a pure headless dApp that compiles to any target that we want. It's written using the Ergo headless dApp framework, which you see right here in front of you. And what this means is that the endpoints for interacting with AgeUSD protocol are already implemented for you. And so if you're creating a front end, there's already a function, a method, that's called mint AgeUSD. And in order to use that, all you have to do is supply it with a few inputs, like the input UTXOs, which the Ergo Headless dApp framework also provides you with a very straightforward interface for using an explorer to automatically find the UTXOs that you need for minting the AgeUSD. And so we have this ability to write this off-chain code once, compile it to every target that we want with almost no extra code added or very limited amounts of extra code added, primarily just boilerplate because, say Wasm prefers types in a certain way, so you have to add an extra 3 or 5 lines of code, but it's all very boilerplate and simple, and you do the same thing every time. It's just a requirement due to some of the compilation process. But there's nothing novel. You don't have to figure something out. You don't actually have to put time and effort. All of the code is based off of one code base, which you can just compile every target. This is extremely powerful because that means we have a source of truth. And every time someone wants to implement a front end, they don't have to rewrite literally every single line of off-chain code. And remember, in the EUTXO model, the vast majority of logic is in the off-chain code. And so that would be a nightmare. The front-end implementers have enough problems to deal with creating an amazing front end, expecting them to rewrite 50, 60, 70% of the logic of the entire smart contract protocol themselves, just because they want to, use JavaScript and create a web dApp, or they want to use Swift and create an iOS front end for the dApp. That's not scalable to expect them to do that. And furthermore, with very complex protocols, with various incentive structures, and making sure all the calculations are good, it's not easy or even a good idea to expect these kinds of concerns to leak out to the front-end developers. It's simply impractical and bad design if we do that. And so that's what the Ergo Headless dApp framework prevents and allows us to create headless dApps which compile to every single target, and what's very important as well, provides an incentive structure for the front-end implementers to actually earn money for doing a good job. How does it do that? So, like I mentioned previously, each action in your smart contract protocol, say minting AgeUSD, has a method. an endpoint, so to speak. And so you can use this method by providing all the inputs. And what the Ergo Headless dApp framework allows you to do when you're writing your Headless dApp is to provide the front-end implementers who will create the GUI for end users to submit their address as one of the inputs to your method. And so when the front-end implementer is integrating the graphical user interface they created with your Headless dApp, they simply add their address as one of the input arguments to the method, and then they get a small kickback percentage, say 0.1, 0.25% of the total value of the transaction. The front-end implementer gets that sent to their address automatically. The front-end implementer doesn't have to know how the smart contract protocol works, how many UTXOs, inputs, outputs, what kind of data, what's all the mathematical functions. They barely even need to know how UTXOs work. All they need to know is they have their address, they found all of the other input UTXOs and user input for how many stablecoins do you want to mint. They shove that all into the method, and then they get an unsigned transaction returned to them. And so all they have to do is then send that unsigned transaction to the user's wallet, say Yoroi, or a full node, or use something like the transaction assembler. And then automatically the transaction gets signed, accepted, posted onto the blockchain, and boom, the person has minted some AgeUSD. And that's kind of the exciting power of Headless dApps, is that the front-end implementer doesn't need to know how the protocol works, but they can still implement a front-end for the protocol and be paid for doing so. And the incentives are perfectly aligned, right? Wherein we're not paying a front-end implementer upfront, we're not giving them some, we're not crowdfunding, or personally as the protocol creators, we're not paying them to create a front end for us. We're instead saying, hey, we believe in you guys. You know how to do front ends. We're going to give you the ability to earn a lot of money based off usage. And so if a lot of people really like your front end and you're the most popular front end, guess what? You're going to make a lot more money. If your front end sucks, well, then no one's going to use it and you're not going to make any money. As such, we don't have this issue of favoritism, of paying people out up front. We don't have the problem of crowdfunding, and then the implementer runs away with the money. They suck, and they said they could do everything, and then their final product was terrible. We don't have any of these faulty incentive structures that just puts trust, faith, and hope in front-end implementers and actually causes a centralizing effect because you have no ability for new entrants to enter into this market of front ends for specific dApps. But instead, you incentivize everybody. Doesn't matter if they're in Africa and they, might not even speak English fluently. They don't have, a gigantic team behind them, and so they may not be able to create a website and do a whole crowdfunding campaign. But they can still be a great developer who really knows how to make an awesome front end and work with someone else who maybe is fluent in English, and they can create an amazing front end that wows everybody, and they'll make money. The point is not to exclude anyone who has the ability to actually produce something that other people want. And so the decentralizing effect and opening up the boundaries, instead of having just one dApp front end that serves everybody, Headless dApps provide us with the incentives of a market where people compete to try and get the most users to use their front end for the dApp. And so we have this twofold effect where the core protocol let's say with AgeUSD, keeps getting more and more reserves, even if all these different front ends are used. And so we don't have this useless forking effect because there's no way for someone to make money. And so they fork a protocol, they change 10 parameters or something. They don't really do anything unique. And then they release their own version, as can be seen in Ethereum sometimes, because there's no incentive for anyone else to make money based off of improving the existing tooling, front ends, or anything around existing dApps. But instead, we're giving people the ability to make money based off of doing a better job than others and having a decentralizing, competitive atmosphere. So we lower the barrier of entry where people aren't required to understand, how to find all of the UTXOs to be used as inputs, and then what are all the mathematical equations put together with different state transitions that are required in order for this token to move there and this token to move to that address, just so we can have, some AgeUSD minted. These protocols are reasonably complicated, and we want to abstract all of that out as much as possible and provide the ability for front-end implementers to make a profit. And that's what the Ergo Headless dApp framework was created to do. So, now that we have the overview of headless dApps, I want to kind of look at specifically how do you go about making those headless dApps. So Emurgo released the Ergo Headless dApp framework a couple months ago, and this has been ready to be used, but has been first focused on having AgeUSD as its target. The Ergo Headless dApp framework, in this repo, you'll find a quite detailed explanation, much of what I've said currently from the high-level overview perspective, but also much more technical breakdowns about how this works, comparing it to the smart contract protocol specification format, Ergo Improvement Proposal 6 that I came up with. The Ergo Headless dApp framework allows you to seamlessly go from a spec based off EIP6 and then model that into a headless dApp. And the transition between the two is very clean, and when creating the Ergo Headless dApp framework, I focused on making that transition very smooth so that we have this streamlined approach to smart contract protocol development. In this library, the Ergo Headless dApp framework, we have a bunch of different modules, structs, and so on forth. And so in this repo, if you're technical, in the README, you can find details about exactly how everything is set up, what all the different parts do, and that's what exactly this README goes through. Furthermore, what I think is very exciting for people is that we have 3 very detailed tutorials or guides for both writing headless dApps and also implementing on top of headless dApps. And so, as you'll see right here, we have 1, 2, 3 pages of headless dApp introductory guides. And these guides take you through building a basic math bounty smart contract dApp, and effectively going from basic smart contract, as you see right there, to creating a project in Rust. So even if you've never used Rust before, but you're used to programming and you know a little bit about the UTXO model, if you want to create headless dApps, this takes you from bare bones basics to having a actual headless dApp. And so as you can see, the guide is quite detailed. Furthermore, what's very cool about all of this is that even if you are not the type who wants to get into the nitty-gritty and actually do the smart contract protocol development, in the 3rd tutorial that we've released, I go through how to write a command line interface on top of the headless dApp. So if you assume that a headless dApp's already created, say the AgeUSD headless dApp, and you just want to create an interface on top of it, this guide takes you through exactly how that would work. In this case, this is writing a text-based interface, a command line interface in Rust. However, the methods of using the headless dApp are exactly the same, whether you're creating a command line interface, whether you're creating, a beautiful GUI. The methods for minting a stablecoin are exactly the same. And so the only difference is how you acquire user input, right? And so in this case, we acquire user input because, they launch a command line application, they type in some user input in their keyboard, and they press enter. However, that doesn't have to be the case. You can create a beautiful GUI to take user inputs, and then based off of that, you still take all of those input parameters, call the same function to mint AgeUSD, and it all acts just the same way. And so what's really exciting for me is that we're starting to have a lot of useful tooling that's truly novel, unique, and puts a whole new spin to the dApp ecosystem. And we're starting to have a lot more educational material for people who are completely and utterly new to this tech. And so I think this is a really awesome opportunity where if you're a front-end implementer, for example, and you really want to get into blockchain, into UTXO-based dApps, this is one of the most opportune moments. With the release of the AgeUSD protocol, once the community, or multiple groups in the community, decide to release and launch and deploy specifically the AgeUSD protocol on chain, at that point you'll have the ability to create a front end on top of the AgeUSD headless dApp, which connects with that specific deployment. This means that you'll be able to start earning an income in ergs based off of your front end GUI. This has never really been possible before that I know of, where there's only, I believe, one project that was a DEX on top of Solana that tried to do something similar to this, but it wasn't generalized to being an entire framework and an entire movement of how we can begin to develop dApps anew. Instead, there was one specific instantiation. And so what's very awesome about this is that all dApps built on top of the Ergo Headless dApp framework will effectively have the exact same interface for a front-end developer to plug into. The function names might change, but all of the input types are going to be exactly the same. And so once you learn, and once you get over that initial hurdle of understanding the basics, you will have a tool set that will apply to every single headless dApp that will ever be created. So if you're thinking down the line, a year, 2, or 3, if you're one of the first people to jump on into this, start creating front ends, which are monetized for you. This is, potentially a very valid income stream as Ergo continues to grow and all of these dApps continue to gain more and more momentum. If you already have front ends for the most popular dApps and you're getting usage from those, you are making an income, and that's a great income stream. And if you have created great front ends in the past, chances are people really want you to make new front ends for new dApps that come out. And so I personally am a big believer that headless dApps are one of the opportune ways forward for pushing the dApp ecosystem as a whole to be more and more decentralized. Not just through saying it's decentralized because it's in a blockchain, but actually decentralizing everything from the front ends, from the dApps themselves, to the tooling you use, the wallets you use. One of the key things that Ergo wants to do is be a true decentralized blockchain, not just decentralized. And headless dApps, I really do believe, are one of the big prongs forward that we have going into 2021 and beyond that should be able to really make a solid difference, both for bringing in developers into the ecosystem and providing end users with a better experience, more variety and choice when choosing how to interact with dApps that live on Ergo.
Hi, my name is Nicolas Arqueros and I'm the CTO of Emurgo. Today I'm going to be talking about the Ergo Cardano collaboration. But before I start talking about that specific topic, I think it would be quite good if I can give you more context. Between our viewers, we have people from the Cardano community and others from the Ergo community. So I wanted to explain a little bit more about the other blockchain so we are all in sync before we jump into other topics. So let's start with Ergo. So Ergo is a blockchain that has smart contracts. It's run by proof of work, and it mostly focuses in decentralization, optional privacy with Sigma protocols. It also has threshold signatures and a lot of like really cool crypto related stuff that helps with privacy. Also, it provides a really powerful and secure environment for like the development of dApps. In the other side, we have Cardano. It's a third generation blockchain. Cardano has a proof of stake protocol, which is Ouroboros. It's currently mainnet, is are working quite well. We already have over 1,200 stake pools that are participating in the decentralization of the network. We also have Catalyst, which is sustainability. With this, we are able to have a treasury that's managed by the same community and is able to give finance projects that are also coming from the community. We already have our first round of funding, and some of the projects could look quite cool. Next, Cardano also has scalability, and this is going to be achieved by charting using Ouroboros Hydra, which is the protocol, and also Cardano is working towards safer smart contracts with functional programming language approach with Plutus, and also with the DSL of Marlow, among other solutions like, for example, Glow. And for last, also Cardano is looking towards interoperability with other chains, and I put an asterisk here because we are going to try to reconnect this at the end of the presentation. Also, I think it could be good to tell you, like, what is Emurgo? I'm the CTO of Emurgo, but who are they? So Emurgo is a multinational blockchain technology company providing solutions for developers, startups, enterprises, government. We are also one of the founding entities behind Cardano. And for the entities that are like behind Cardano are the Cardano Foundation, which is a non-profit that works with the community and regulators. Also IOHK, which are the researchers and developers of the protocol, and Emurgo, which I just told you about. So that was like the context that I wanted to give you before we start talking about why Ergo and Cardano like collaborating. Does it make sense? Maybe if both have a smart contract, shouldn't be competitors. So let's talk about it. So I put together this really quick matrix that's like summarizes like the core of like the two blockchains in a simplistic way actually, but it's going to help us like understanding what things are similar, what things could like actually work out. So let's jump into it. So the consensus protocol of Ergo is proof of work, while in Cardano, as I mentioned, is proof of stake. For Ergo and Cardano, the accounting system is UTXO-based. What do this mean? That unlike other platforms, for example, Ethereum, Tezos, etc., which are accounting based. An example of accounting is or like actually an analogy of accounting is, for example, when you're going to do a bank transfer and you want to transfer someone $13.49, you are going to send that person the exact amount of money. But UTXO is more similar to how cash works. So for example, when you go to a supermarket and you want to buy something that's $4.90, maybe you pay with $5. So it's not the specific amount that you need to pay, so you're going to get change. This is how UTXO works, and this is actually pretty important because everything else is completely different. So if we are developing smart contracts in a UTXO-based platform, the architecture of the smart contracts and the project, how they work, is completely different because it's based in UTXOs and on an account. And so this is like super critical, and not only Ergo and Cardano have the same account-based system, but also their smart contracts are UTXO-based. For Cardano, the team developed what is known as the extended UTXO model. Ergo has something similar as well. Both have functioning programming language. Ergo has Scala, while Cardano has Haskell. And the focus of Ergo is security and privacy, while in Cardano is scalability, sustainability, interoperability, and security as well. So this is quite interesting, right? We can see some things that are different and some other things that are like quite similar. So both share these particularities. What if for Cardano we wouldn't have to wait for Gauguin to start validating some assumptions of new projects? We could do this. Both of them are UTXO-based, so a protocol that's like been MVP or is being developed in Cardano also can in Ergo also could have like some similarities in the design patterns for Cardano. What if we test Yoroi multi-assets with Ergo in preparation for Mary? What if we collaborate and learn from the cryptographers and other experts from Ergo or Cardano, vice versa. So the collaboration start making some sense here, like in Ergo and Cardano working together start making more sense. And even we could go a little bit further. What if we leverage some of the privacy capabilities of Ergo for oracles and then connect those to Cardano? And we are starting to see like this integration between the two chains. And before we talk about that, one of the main points of Cardano is interoperability. What if Ergo is our first partner for interoperability? Really interesting, and that's why this was like the core of like, let's try how things work with Ergo, because we see more opportunities for cooperation rather than competition. That's my presentation about the collaboration between Ergo and Cardano. I know that you're going to have more questions, so feel free to ask me anything. I'm going to be checking your questions. Enjoy the summit. Bye.
Hi, in this talk I'm going to be talking about Kiosk, which is a tool and a library for interacting with the Ergo blockchain. So before we discuss about Kiosk, I'll give a brief overview of what is Ergo. So Ergo is a UTXO-based blockchain, and a UTXO in Ergo is also called a box. So I will be using these two terms interchangeably, UTXO and a box. Ergo is implemented in Scala. There is also an independent implementation in Rust, and it supports advanced smart contracts using a high-level language called ErgoScript, which is Scala-like, and this compiles to a low-level language called ErgoTree. So generally programming in ErgoTree is not very user-friendly, so we will usually program in ErgoScript, and I'll discuss in a separate session how to compile ErgoScript programs, but for now I'll assume that you have a ErgoScript program that is compiled and we'll be using that in Kiosk. So Ergo is based on Sigma protocols and their composition. So Sigma protocols are a type of cryptographic protocols which I'll not go into too many details, except that mentioning that it has two types of Sigma protocols. So the first one, called proof d log x, where x is some elliptic curve point, is the proof of discrete log of x to some fixed base g. Yeah, so g is a fixed base that we use, and it uses a Schnorr identification to do this proof. Yeah, so it's a zero knowledge proof. And the second Sigma protocol is called proof DH-tuple, which takes as input 4 elements and proves that these 4 form a valid DeFi element tuple, right? So this is nothing but 2 parallel runs of the first protocol using the same secret. And again, I will not go into details. I'll refer you to the Ergo documentation for details of these protocols, right? So a box in Ergo or a UTXO, it can store data in registers, right? So in addition to just the value and the script, Ergo UTXO can store some other information as well, right? And Ergo transaction not only has inputs and outputs, but it also has something called data inputs, right? So data inputs are boxes that you access. So these are unspent boxes, unspent at the time the transaction is going to be mined. These boxes are not spent in the transaction. They are just used for reading the data, right? Something in the register we can read. So the script in these data inputs is also not executed, right? The script only in inputs is executed. And it also has rich context. So what I mean by this is that a script in Ergo box can access the registers of other boxes as well, right? In the same transaction. So this is what I mean by rich context. And Ergo also supports secondary tokens, right? So Erg is the primary token of Ergo. And Ergo also supports secondary tokens like Ethereum does, which I have also discussed in a separate talk. So I'll not go into details. Let's look at what the Ergo box looks like in more detail. So as I mentioned, box is made of register, 10 registers to be exact, numbered R0 to R9. Out of these, the first 4 registers are mandatory and they are reserved for protocol use. So you cannot store arbitrary data in them. The data stored in these registers is part of the protocol. You can use this data in your smart contracts, but you cannot change the types of data in this. It is fixed. So the first register will have the monetary value, how many nanoergs are there, for example. So in Bitcoin, we had Satoshis. Here we have nanoergs. The second register will have the script, the guard script that protects the box. So I mentioned earlier that we have 2 Sigma protocols, and then we can interleave these protocols with predicates on the box data. So simple predicate is that proof discrete log of the transaction bytes, signature on the transaction bytes to some base G of some point X. So this is called proof dlog X, as I mentioned earlier. And this is the most common type of script that we'll find in Ergo. So this is similar to Bitcoin's default script of providing a signature, right? The third box has some creation info that we need for computing for uniquely identifying the box. So this will have the TX ID, the index of the transaction, and additionally something called a creation height, right? So we will not be using this too much in our discussion, but it's just there for use if we need. And R3 contains assets. So basically this contains token ID amount pairs, where token ID is an arbitrary 32 byte long string, and amount is the number of tokens contained in it. So it will have pairs of this. If it has no tokens, then this will be empty. Otherwise, it will have pairs of this type. And a transaction in Ergo can issue at most 1 token. So it need not issue any tokens, but it can issue at most 1 token. The token ID of that token will be the box ID of the first input in the transaction. So it uniquely determines the token ID because each box ID is unique. And the amount can be anything. So you can issue as much any tokens as you want. It's bound by the maximum number you can store in a long integer. Moving on. So let's look at what an Ergo transaction is like. Yeah. So here is an example of a simple Ergo transaction. Like I said earlier, Ergo transaction has 3 sets of data structures at a high level. The first is the inputs. So these are the boxes that will be spent or destroyed. The second is something called data inputs, which are also unspent boxes, but these are not going to be destroyed and these are not going to be spent. So the script in these boxes will not be executed, unlike the inputs where the script will be executed. So this data inputs are normally used for reading something without having the ability to spend them or without needing to spend them. And the data inputs are unique to Ergo. So I'm not aware of any other blockchain system that has this concept of read-only inputs, which you don't execute, you only use them for data. And the third data structure, similar to Bitcoin, is the outputs, which contains the sets of boxes that are created in the transaction. And as I described earlier, each of these boxes can have up to 10 registers with first 4 reserved and the remaining having arbitrary data. So coming back to Kiosk, right? What exactly is Kiosk? So first of all, why is there a need for Kiosk, right? Let me just give a brief overview of that. So Ergo is a very powerful protocol, like I explained earlier. It has advanced scripting language called Ergo script. It has registers, but using these constructs is not very user friendly as of now, yeah, because currently Ergo node doesn't have a very powerful API for creating these structures. So Ergo node gives us a REST API. So if you look at the right side of the figure, this is the Java. So I mentioned that Ergo has two independent implementations. One is the Scala/JVM based implementation, and the other is the Rust implementation. So here I'm describing the JVM/Scala implementation. I'm not talking about the Rust implementation here. So this figure gives the high-level overview of how the Scala component of Ergo is implemented, right? So at the lowest, we have Ergo tree, which is the low-level language that the node understands. Then on top of that, we have the Ergo script compiler. This is also called Sigma state interpreter in the code repository in case you are going through that. On top of this is the Ergo Wallet, which has the ability to sign transactions, and Ergo node is built on top of that. And there is a library called Ergo AppKit, a very, very powerful library. So this is written in Scala, and it also allows us to use Ergo using various languages like Java and Python as well. So have a look at Ergo AppKit when you get some time, because it's a very, very advanced library to interact with the Ergo blockchain. And it's not part of the node, so it's separate from the node. It just built on top of the Ergo wallet. It gives us the ability to interact with the Ergo blockchain using Scala API rather than REST API. Yeah? So which is more friendly for programmers. So we can use this Ergo AppKit to create various constructs like group elements, column, collection of bytes, etc. And what is a call byte? Here I've mentioned something called which is call byte. So basically this is a collection of byte. Think of it as like an array of byte, right? But in Scala, array has a lot of extra baggage, right? We don't want that. So call byte is a very lightweight collection just specific to Ergo. It is so think of it like an array of byte, but internally it is a collection. Yeah, so that's why it's called call instead of array, just to differentiate it. And so Ergo AppKit allows us to create all these constructs using Scala. And what is Kiosk? So Kiosk is basically made of two components. Kiosk is built on top of Ergo AppKit first of all, and it is made of two components. So the first is called Kiosk lib, which is a library for use in other programming applications. So it doesn't have a front end, it is a headless application. And it allows us to make AppKit even more user friendly. So AppKit is quite powerful, but again, using it needs a lot of knowledge of Ergo to actually use AppKit. So Kiosk tries to bridge that gap a little bit. Although I won't claim that you don't need to have any knowledge of Ergo to use Kiosk. You need a little bit of knowledge of Ergo, but not as much as you need to use AppKit. So Kiosk lib is what most people will use, which is a library. And as an example, the Ergo stablecoin module for bootstrapping the stablecoin is written on top of Kiosk lib, part of it. And the other part of Kiosk is called Kiosk Web, which is a basic front end. It is a machine generated front end using a library called EasyWeb. So Kiosk Web is what I normally use to test my transactions. It is built on top of Kiosk lib, and using EasyWeb, it has a very primitive front end, yeah, but it gives you a high level way of humans to interact with the Ergo blockchain, yeah, in very high level constructs that Kiosk lib has, rather than the low level constructs that AppKit has. And this Kiosk lib is pure Scala, while EasyWeb is a JEE application. So Kiosk Web is a mix of JEE and Scala. So what does Kiosk Web allow you to do? It basically lets you create environment variables like long collection of byte, bigint, things like that. Then it lets you create boxes with registers containing any of this data that you created earlier. And then finally, it allows you to create transactions using the boxes that you created earlier. Yeah. So these boxes will be the output of the transactions. And you can create transactions provided that you know the secrets of the boxes you're spending. Yeah. So I'll get to that in a second. I'm talking about Kiosk Web here. So Kiosk Web is multi-tenant in the sense that when you go to the URL, it will randomly generate a session ID for you, and that session ID will be stored in the URL. So whenever you want to, you can close the browser, but whenever you want to go back later on, if you know the URL, you will get to the exact same session, and your variables, whatever environment variables boxes you had created, will be preserved, right? And because this session ID is unique, randomly generated, so if two people are using Kiosk, their environments won't clash, and nobody will be able to get to your environment unless he knows the URL. So treat the URL like a secret. And again, Kiosk is for developers. So before we move on to the actual demonstration, I would like to warn that don't use Kiosk for storing a large amount of ergs. Use it only for testing. And there are two ways to run Kiosk. So one is a web-based version that we have deployed for testing. Yeah. So this is mostly for Ergo developers to play around with Ergo, but it is not really designed for personal use, right? So the other way is to run locally, Kiosk locally, instead of using the web version. So you run it local web server and you access using localhost. So I'll get to that in a second. Before I start demonstrating Kiosk, let me just show how to get to Kiosk. Yeah? So first of all, you go to this GitHub repository of Kiosk. This is the URL. And then you copy the URL. And then you clone this. So I've created a directory called temp and I'm going to clone this. So it's already there. Now let me show you what is there. So there's some directories and you need the SBT to run it. So I've already installed SBT. So what I do is I'll just start SBT. Once it loads up, I'll start locally the web server that runs Kiosk. So this is the right way to run it in the sense that it is more secure than using the web server, which I'll show you after this. So once SBT is loaded, you just do Getty start. And soon it will load all the libraries and start the web server and start running Kiosk. All right, so now we have Kiosk running locally. So I will, so once you open it, this is the window on the right side is what you will see. This is the very primitive front end that you will get. So you can use this to create environment variables, boxes and all, which I'll show you in a minute. But let me first quickly show you what you are interested in right now. So first of all, look at this session here. So every time you go to Kiosk, it will randomly generate a session ID. And whatever variables you create, as long as you save the URL, you will go back to this session ID, right? So here there is a wallet, very primitive wallet. So right now there's nothing here because it's a new session. You will see 0 ergs. You'll also get an address. So you can use this address to receive funds for testing. And you will need something called the private key for this address. So you have to save this private key. In this case, it's a negative number, doesn't matter. You have to save this number. And this is what you'll be needing to spend any boxes, any funds sent to this address, right? So to start testing with Kiosk, first you go to open a session of Kiosk, get an address, send some fund to this address, and then save the private key and then use that in your experiments later on, right? So now let me show you the other way to run Kiosk. This is how you run locally. And there is already a web version. This exact thing is implemented on the internet, yeah, which you can just go by going to kioskweb.org. So this is the same thing if you look at it, except that it is having a different color, right? So this is to differentiate. Suppose you are now using both local and remote version, right? And so you can easily differentiate which one you are using, right? So if you want to send sensitive data, then you don't use the remote one, use the local one. So it's in a different color for easy differentiation. And yeah, so I'll be using the local one, but if you want, you can use the remote one to also do your testing. But once you are familiar with it, I would recommend that you download locally Kiosk and run it using SBT as I discussed. So going back to the example that I wanted to describe. So I'm going to describe how to use the timestamping service. So there is a forum post about how to create a timestamping service using Ergo, and at a high level it works as follows, right? I'll not go into the detail. I'm just giving you a screenshot of the forum post, and you can visit it and understand how it works later. For now, remember, just understand that the purpose of this service is to prove that a certain box B was unspent at some height h. Yeah, so box B with some structure, some registers, some value existed in the blockchain, and that was not spent at height h. Yeah, maybe it was spent later, but at height h it was not spent. That's what you want to prove. Yeah, and why do you want to prove that? I don't know. That is some application in a smart contract, right? So suppose your smart contract needs something. Yeah, so it's quite a useful construct. Once you start creating Ergo smart contracts, you will realize that you need this quite frequently. This kind of proofs. So obviously one way to check it is to manually inspect the blockchain, right? A human can test it without needing a service. But our smart contracts are kind of automated, right? They should be autonomous. They should not need any human interaction. So this is something where a smart contract can verify that instead of a human. This is verifiable via code, yeah. So what we want to prove is that a unspent box B existed at some height. So there is this box B that we want to timestamp. This is the target box, and then there is the timestamp emission box. I'll call it E. So it emits timestamps, yeah. It is basically the one that will use to create the timestamp. Yeah, emit or create is the same thing. Yeah, so you can just think of it as a timestamp creation box. And the third is the timestamp box itself, yeah, which contains the timestamp. So basically, this timestamp emission box is going to emit the box T, in some sense, yeah. So I'll get to that, what that means in a second. But this is the service that we are going to demonstrate using Kiosk. So this is the script of the timestamp box E. Yeah, this is the emission box script, roughly how it looks. So I will not go into too many details, but I'll briefly discuss what the purpose of this box is, right? So first of all, it's going to ensure that it is the first input. So it is going to valid in condition is checked. This means that it is going to check that this is the first input in the transaction, right? So self.id is equal to input 0.id, and then this is tested in the final step, yeah. So what this means is that this timestamp emission box should be the first box in the transaction. And then the second condition says that valid out. It says that the first output of the transaction should be a copy of this box, right? So what this means is that the timestamp emission box contains the timestamping tokens, right? And each time it will emit one token with the timestamp. So suppose now it has 950 tokens at some point, and now I want to timestamp some box. So one token will be taken for timestamp, and there will be 949 tokens left. So what this code requires is that those 949 tokens should be the balanced number of tokens will be stored in this copy of the timestamp box with everything same except the number of tokens reduced by 1. And the other condition, it says that there is a timestamp box that it should create. So the second output must be a timestamp box, right? Timestamp box is the second output. And what it says is the second output, the register R4, the second output must be the ID of the box that we want to timestamp, right? So I'll get to where that ID comes from in a second. But this statement says that the register R4 of the timestamp box must be the box ID that we want to timestamp. And register R5 must be the height approximately, and there is an error buffer. So if because of some delays in transaction, there may be a slight delay, so we can have a buffer of say 5 blocks, yeah. So we know that the box existed at a height h with an error margin of 5. That's what this will say. So this buffer can be anything, but I've kept it in 5 in the implementation. And this says that R5 should have that value. And finally, this says that the proposition byte should be the timestamp proposition bytes, and this is basically a script that is unspendable. Yeah, basically this is just saying that this box cannot be spent. Yeah, the script will say false, so it will always evaluate to false. And the final condition says that it should have one token, exactly one token. Yeah. So if you read this code, you will understand. I'll not discuss it here. I'll just leave it for a second for you to figure out the details. And this is what a timestamp transaction looks like. Yeah. So this is the inputs. So it will have the timestamp emission box. This is the data input. So this is the box that we want to timestamp, right? So this is the box that we want to timestamp. Yeah. And it is coming from the data input. So this is how you read data inputs in Ergo script. And what this means is that the first data input is the box we want to timestamp. So this box is actually this box. Yeah. And then this is the output. So I'm skipping certain important boxes here. So there will be another funding box here, which is by default is going to be there. And there is going to be another fee box, yeah, box that pays the fee, which I will assume that is always there. Yeah. So these are implicit boxes. And I'm also assuming that there's a copy of this box is going to be there. Yeah. So this is just showing the timestamp box, but the first box in the output is going to be a copy of this box. And what I'm showing is that it has some nanoworks, which I don't care. They have to be preserved. It has the timestamping script, which is this script on the right side, some creation info, and it has the timestamp token ID and 499 of those tokens, right? And this is the box we want to timestamp. So we don't care what it is. It has some nanoworks. It has some script which we don't really care. I've just mentioned it as proof log, but it doesn't really matter. And some creation info, some tokens. We don't really care. We just need the box ID of this box. That's why it's in the data input. and then the timestamp emission box, which has some default, minimum amount of nanoworks, right? So that it stays in the blockchain for some time before being garbage collected. Yeah, so several years it will stay. And the script says false. So what this means is this is an unspendable box. Yeah, and the sum creation info. This will be the same token ID. So 499 tokens were there in the input, and one has been here. So 498 balance would be in the timestamp, the copy of the timestamp emission box. It will be the first output. This is the second output I'm showing here. And the R4 will be the box ID of this box. The timestamp box says box ID, and R5 will be the height that we want to timestamp. Yeah, so current height. So I'm just giving an example here, 500, but in the actual demo I'll choose the real height. Yeah. So here are the steps to manually create the timestamp box in Kiosk. So we have to collect the following information from the blockchain or somewhere. So we need to know the box ID of the box you want to timestamp, right? So in the previous slide, I showed Alice's box that was supposed to be timestamp. So we need the box ID of that box. Then we need the box ID of the timestamp emission box also, right? So how do we get that? Basically, we know the timestamp emission box's address. So we'll go to the Explorer and search for the boxes by address. It will give you one or more timestamp emission boxes, and you can choose any of the box, the ID of that box. Then we need to know the token ID of the timestamp emission box. So this will get, once we know the box ID of the timestamp emission box, then we'll get the token ID from there. And obviously you can refer to the forum post, which also contains the token ID. And then you need to know the current height, because that's what you want to timestamp. And then you need to know the box ID for funding the transaction, right? Because you can't have transaction without fee. Plus you need to store you need to put some nanoworks in the timestamp box itself, right? Because the timestamp box has to stay in the blockchain. You can't have zero balance boxes. So there has to be another box that will fund the entire transaction plus any additional works. Yeah. So you'll need to know the box ID of that as well. And then you need to know the corresponding private key. If that box is protected by a public key, then you know the corresponding private key also. So I've shown you earlier how to use Kiosk to get a private key, which is a big int. And then the second step is that you need to create the variable for R4, which is a collection of byte, box ID, and box ID of the box you want to timestamp. Then you want to create another variable in R5, which is the height that you want to timestamp. And the next step is to create the timestamp box with these variables that you created earlier. And the final step is to send transactions, right? So this is what I'm going to show you hands-on with Kiosk. All right, so I'm going to show now how to create the timestamp using Kiosk. In the previous slide, I had shown what information we need to collect. So here in the bottom right corner, this is the information that I have collected already in advance for the demonstration. So let's look at this. So this is the emission box ID. This is the timestamp emission box ID, and this is the same box ID that I have here. So if you look at it, this is the box ID, this is the emission box address. So if you compile the script that I showed earlier, this is the address you will get. This is the same address I've kept here also. And we see that it is not spent because the spent transaction ID is null. So this is the box that we'll be using, because we want to use the unspent box as the timestamp emission box. Then this box I do to timestamp. Yeah, this is some random box that I picked from online. So this is the box that I want to timestamp. It is this box with the box ID, and we can also see that it is unspent. We don't care what the other details are because we just want to timestamp this. We don't really care what address it has or how much amount it has. It will be used as data input. And this is the address of the timestamp. So remember, the timestamp had a script that always evaluated to false. It was just the statement false. So when you compile that, this is the address you will get. When you compile the statement false in Ergo script, this is the address you will get. So this is the address the timestamp box will have. Finally, like I mentioned, we need a funding box, right? So whenever we need to pay fee or we need to create some boxes where we are falling short of the funds from the input, then we'll need an extra box to fund it. So this is the funding box, right? This is the box ID. We can see it's also not spent. And this is the address. And this is the private key. So we'll need the private key because we want to spend this box to fund the transaction, right? So the funding box is not spent. The box that we want to timestamp, this is also not spent. And the timestamp emission box, this is also not spent. Yeah. So now the next step is to go to the Kiosk environment. So here I've opened Kiosk. So what we'll do is we'll go to environment, and then we have to create first the R4 will have the box ID, which is a collection of bytes. So we'll do this here. So let's just call it R4. And this will have the box ID of the box you want to timestamp. So this will have this, this value. So I'm just going to copy it and paste it here. And it will give me OK. So you can't create the same variable twice, right? So if I do it again, it will say already exists, right? So that way you can't overwrite something. You have to clear the environment variables. And you clear it using using this, yeah, which I'll not do it right now. So next we want is we want to create a long, yeah. So this long will be the height of the blockchain. So this is R5. It will be in R5. So I'll just call it R5. And what is the current height? So this is the blockchain. So let me just refresh it and see the latest height here. So the latest height I'm seeing it here is 402079. This is what I'm going to use this as R5. So this is the height. So next we want to create is the timestamp box, right? So this is the box that we I just call it timestamp. This is the address that I mentioned. This address I've already pre-filled most of the data. R4, R5 also I have filled. And the token ID, this is the token ID for the timestamp. So if you look at the timestamp emission box, it has this token and 997 of those tokens, right? So we'll have to take one token. So I'm just taking the same token ID and one token, and I'm putting some nano eggs here so that it is possible to create a box. You can't create a box with 0. So I'm just creating some minimum box with minimum nano eggs. I'm going to click submit. So this box is created. This box is called timestamp. And now we want to create another box, which is the balance of the, once we destroy the old emission box, we'll have to create a new emission box. So I'm just going to call it new emission. This will be the address. This is the same address, this address, or this address. Both are the same address. There is no registers in this box. The token ID is the same token ID, and 997 minus 1 is 996. So I've kept 996, and this is the same amount. I'm just copying the same amount here. Yeah. So I've created this box also. So now everything is created. Now we are ready to create a transaction. So here I've already pre-filled most of the data. So input box IDs I'll fill. The data input box ID I've already filled. So this is the box ID we want to timestamp. Yeah, this is the data input. This box. So this is the data input box ID. I just need to put the box ID. I need to put the names of the boxes I want to create. So I want to create the new emission box and the timestamp box. Yeah, and this is the transaction fee I want to pay. And any change, if there is a change, I will put it back in the funding box address, right? So this is the same address I put here. Sorry, this funding box address, this address I've put here. And the proof delog secret is this secret that I need. And let me also put the input box ID. So the first input will be the emission box ID. So I'll put this box ID here, timestamp emission box ID. And the second input will be the funding box ID. Yeah? So this is the funding box ID. Here I'm copying this and I'm going to paste it here after putting a comma. And let's see. Now let's just try to create the transaction. Yeah, I'll cannot go get rich in 5. Oh yeah, sorry. So I made a mistake. I need to create it as long value, int value. Sorry. So I'll just clear all the environment variables. And R4 as before, and R5 will be int instead of long. Yeah, so if I now do R5 here, it will give me an error. Yeah, but so if because I've already created an R5 end, if I try to define R5 as long, this is just for information. So it will say R5 is already defined. Right? Anyway, so now we are good to go. So let me just delete the box and create the emission box is fine. I have to recreate the timestamp box, right? So I'll just create a new box called timestamp 1 and with the same values. And here I'll just call it timestamp 1. Let's see. So this should create the transaction properly. Yes. So I selected no for broadcast. I just wanted to inspect the transaction. So it looks fine. Yes. So it is creating this is the new timestamp emission box. This is the timestamp box. This is my, this is the fee box and this is the change. So I'll just do it yes this time and I'll click submit. Okay, so this has been submitted. This is the transaction ID of the box of the transaction. Let's see. Yeah. So earlier there was no transaction. So now this should show up here in the Explorer. Let me refresh it. So here we see a new transaction is there, unconfirmed transaction with the same ID 9075. This transaction ID. So I've shown you how to use Kiosk to to do arbitrary tasks on the blockchain. Yeah, it does require a little bit of manual work because I have to first collect all these things manually, then I have to go to the blockchain, I have to go to the block explorer and get the height, and then I have to do it within a certain amount of time. Because if I delay in creating this, say if I delay a lot in doing this summit, then this height will become stale. Yeah, and we have only an error buffer of 5. So if I wait too long, then this transaction will fail. Yeah? So this requires a lot of manual work. I have to get the fresh height, I have to get the data, and then I have to broadcast the transaction. Yeah. So in a separate talk, I'll show you how to use another tool that automates most of this work. So that is the tool under development. And for now, I'll just conclude my talk on how to use Kiosk.
Hello guys, Kust is here, and as you may know, the Hardening Ergo protocol upgrade is coming in form of a hard fork, and let me provide some details in this talk. Right, so first about hard forks and how Ergo developers are thinking about hard forks. So I'm going to provide some joint agreement in the developers community. So Ergo developers are against hard forks in general, right? Why? Because forks can cause community splits in the first place. You know examples in Bitcoin community and Ethereum community also with Bitcoin Cash and Ethereum Classic and so on. Right, so when rules are changed, there is also possibility of split, right? When part of community is accepting the changes, part of community is rejecting, and often, this part of community which is rejecting is going to give life to a new chain forked from old one. Right, so this is very painful and should be avoided then. Then hard forks also may slow down ecosystem development. Right, if application developers need to adopt. Right, and then yeah, not all the application developers want or have time to adopt, right? Then you have some applications stop to work basically, right? And also, well, even if community agreed and so on, so it's hard to update decentralized ecosystem, especially when it's major enough, right? So if cryptocurrency is listed on many exchanges and there are many mining pools and so on, so in case of hard fork, all the nodes do need to update, and then it can be very painful. Okay, so there are many disadvantages of hard forks, but sometimes they are simply needed or better. For example, in case of Bitcoin emission bug fix and also database edge case fix forks, which happened many years ago, so there was a critical need for such forks, right? Especially for emission bug fix fork. And also hard forks are usually simpler to encode, to analyze, and to understand the changes in comparison with soft forks. Okay, so then hard forks must be avoided at any cost, right? And if they are needed, so changes must be minimal, so developers need to change as little as possible. Right, and hard forks are for security related issues only, again, right? So this is the rule. Alright, then let me provide you some information about the hardening hard fork coming, and well, why it's about the protocol hardening indeed. Alright, so the protocol upgrade plan is following. So the main, the biggest change is about switching from old proof of work scheme Autolycos to a new one called Autolycos 2. Other changes are not so visible to application developers and end users. So yeah, they're about SegWit like commitments to transaction witnesses. It's Bitcoin term. We are talking about spanning proofs in Ergo Community. The hard fork will also provide support for costing, scripts costing soft fork following up. And there will be a few non-critical security fixes to be explained in details after the fork. Alright, so now let's dive deeply into details. So in regards with the biggest change, so Autolycos 2 proof of work protocols. The changes are following. So the most controversial change is about non-outsourceability switched off. So we had discussions for many months. The Discord mostly, it's mining channel, and yeah, after many months of discussions, it was considered to switch non-outsourceability off. Also, Autolycos 2 is closing holes found in memory hardness of the Autolycos. So there was some possibility to bypass memory hardness of the proof of work scheme. So yeah, all the possibilities were fixed. So now, well, Autolycos 2 has better memory hardness. Right, and this was the first reason for hard forking, right? So holes in memory hardness were considered as a security issue after many months of discussions. Right, and for Autolycos 2 also memory requirements will go up with time. Right, so initially in order to mine 2 gigabytes of RAM will be needed. Right, then Ergo will target 3 and 4 gigabyte GPUs thrown away from mining Ethereum via proof of work scheme parameters update in Ethereum. Yeah, I guess Ethereum Classic also. Right, so yeah, so initially for first years Ergo will target these devices, but yeah, as memory requirements will go up with time, then eventually more powerful GPUs will enter the game. And yeah, GPUs with 3 and then 4 gigs of RAM will be not competitive eventually, right? But for some time, for a few years, they will be in the game. Okay, so still Autolycos is KSUM based proof of work, so it's based on problem which is believed to be NP hard. Right, and yeah, this proof of work is similar to Equihash, but a little bit different problem is used. Right, and so hopefully with Autolycos 2 we will stay for a long time. So yeah. In regards with other changes, so as I said before, they're invisible for application developers and end users, but still useful for protocol upgrades. So in particular in Autolycos 2, only static data from block is used in proof of work table generation, and this table is later used for solving a KSUM problem. And because of that, now proof of work function is friendly to block candidate regeneration and sub-block confirmation protocols to be implemented after. Right, so block structure is changed a little bit. So now there is possibility to add new fields to header with no need for hard fork. So via a velvet fork, even it will be possible to update block headers to add new fields there, which may be useful for sidechains. Maybe for other protocols. Right, and also SegWit-like commitments to transaction spanning proofs will be added. Okay, and as I said before, some security fixes are done, right, and will be activated on the hardening protocol upgrade. So such security issues are not critical, so the code is open even, right, with fixes. And fixes can be done via other methods, but with hard fork they are more clear. Right, and that's basically it. So as I said before, changes are minimal. Right, and yeah, mostly we are fixing things which are considered to be security issues, and on the way we are also adding possibilities to upgrade the protocol in non-breaking ways after. That's basically it. Thanks for your attention. Bye.
Hey there, this is Robert Kornacki, and in this presentation, we're going to be talking about the brand new release of the next version of Oracle Pools, what it's about, how does it work, and what benefits does it provide. So, Oracle Pools, for the uninitiated, are an Oracle solution that we developed in mid-2020 for Ergo. It takes advantage of the EUTXO model together with data inputs to provide the ability for oracles as a public primitive, or you could argue like a public service, where individuals who choose to be part of an oracle pool gather around together into a group, and rather than having, you know, this Sybil attack prone problem of just anonymous oracle operators who just get decided on randomly and can easily collude, the point of oracle pools is to have a set of oracle operators who all know each other, have some reputation at stake, which adds to the whole risk of actually, becoming a bad actor, or it decreases the risk of knowing that someone isn't doing a Sybil attack where they're trying to fake that they're, 3 different people, but it's actually one person. Oracle pools try to add in the concept of reputation between the oracles. And between the oracles and, the oracle pool itself and the users of the oracle pool, by having the operators be much more transparent and have more reputation at stake. That, put together with the fact that oracle pools try to create a basic foundation for oracles to work on time, have an income stream, and be utilized by anyone and everybody in the ecosystem, helping enrich Ergo as a whole. So Oracle pools work in such a way that every single Oracle pool has a schedule for when they post, right? And so as we can see here, we have the Oracle pool epochs, or the posting schedule. And so each epoch is divided into epoch preparation, the live epoch, and then once the live epoch finishes, there's a collection period, and once the collection period gets accepted, or once the collection transaction gets accepted, we move on to the next epoch, the epoch prep period of the next epoch. This then keeps moving forward, and as such, you have a posting schedule that the Oracle pool follows. Whenever the collection happens, all oracles within the Oracle pool that posted data points get rewarded. The collection in the very first version of the Oracle pool design averaged everyone's data points out. In this new update version, we're bringing in the whole new concept of consensus based off of deviation checking. We'll get to that in a moment, but let's just finish off with giving you the full picture of what Oracle pools are, and then we'll jump into the latest updates. So, with this posting schedule, every time, as I mentioned, that the data points are collected, the oracles are paid out. Every time that this new data point is created, what's really cool about Ergo is that we have data inputs. And what that means is that every single dApp or user on the entire blockchain now has access to that data point for free. What's really great about that is that means we can have very big dApps subsidize the Oracle pools so that smaller dApps or smaller just individual users who are interacting peer-to-peer have the ability to utilize the data feeds. And so maybe even if both the big dApp and the small dApp are contributing to the Oracle pool, maybe the small dApp itself wouldn't be able to pay for the Oracle pool to pay off all the oracles, but when joined together, there is a sufficient amount of ergs coming in to support the Oracle pool for the foreseeable future. This allows us to then treat key data feeds, key Oracle pools, as effectively public goods on top of the Ergo blockchain that everyone utilizes. This is one of the nice things about Oracle pools, is that we have this really solid foundation to build off of, and we don't have this restrictive model where everyone is forced to have to keep paying for the same data to be produced, or just to read the data. Instead, we're paying the oracles for doing their job well, and then the results of them doing their job are on-chain and can be used by anyone. So in a sense, we're really having a more decentralizing effect and opening effect to allow even small dApp creators to utilize and take advantage of Oracle pools and have Oracle data feeds for their dApps without requiring, really complex understanding or requiring a useless token in order to get data from the oracles or anything as such. That, in my opinion, is really one of the most attractive things about Oracle pools, is that it's not a project that is intended to make billions and billions of dollars because of hype, because of a token, or any of that. It's trying to create, from solid first principles, how do we create a decentralized ecosystem where any group of individuals can come together and create their own Oracle pool. There's no barriers to entry. We don't have a useless token that causes barriers to entry for dApp creators who want to use Oracle pools. And we don't have any barriers of entry for building on top of this either. If we have a token, there's typically a single company that created that Oracle solution, and they get to deal with how the development of the project moves forward. Oracle pools are a set of contracts that are open, public, and very easy to build off of because there isn't a token hard-coded into every single incentive into the protocol. We have a base protocol that just takes in ergs, the base currency, which drives demand for ergs, and allows anyone. So even if the existing Oracle pools, for whatever reason, someone doesn't trust, because let's say it's only them and their 4 friends that they really trust closely, and they just have a dApp between them, or some sort of smart contract that's they're say betting on, let's say, the course of the election, or they're betting on what the weather will be in 2 months, or say they're farmers and they're betting on the future chance of rain and what's the crop yield going to be on average. And say those farmers have some sort of local association and they only want to trust members of their association and not say other associations who have different incentives and are more prone to corruption. Oracle pools are simple enough that they can be reused for any of these scenarios, and they allow people to choose who are the operators without having this really large baggage of requiring this entire ecosystem around a specific token, having to get permission from someone, or having your costs limited based off of said token, demand, supply of that token, having to purchase it on exchanges and blah 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 blah. That's all, in my opinion, a lot of fluff that gets away from the core fundamentals of decentralized technology, of giving people the power to choose who they deal with, who they work with, who they source their data from, who do they trust. And so Oracle pools are intended to be this base layer Oracle solution, which doesn't solve every single problem, but it's not intended to solve every single problem because it's just the base. And so, as we'll talk in a moment, deviation checking consensus is one of the first steps forward above the base protocol, which gives us higher assurance. And this isn't the only step forward. There's already a lot of ideas, and I've already actually come up with a couple novel design patterns for entire dApps that utilize similar but still quite unique incentive structures compared to some of the current Oracle solutions, say on Ethereum, which provide even greater guarantees while utilizing Oracle pools and extra incentives on top. Because Oracle pools, as I said, are such a base layer and they don't have these opinionated limitations on top of them, we have the ability to build on top. And so in the coming years, it is very likely that we're going to start to see more and more complex infrastructure built on top of Oracle pools to increase assurance, to increase their power. And so I think it'll be very exciting as we move forward to see what all of that becomes. But before we get ahead of ourselves, let's talk about today, right here, right now. So, with this Ergo Summit, we're also announcing the launch of the deviation checking pools, which, if you now go to the Ergo Explorer and you check out the 2 pools, ErgoUSD and AgeUSD, those are already using deviation checking consensus. So feel free to now go ahead and use these pools for any of your dApps. Deviation checking consensus is a very simple but very useful concept. And it has a number of additional pluses to it that may not be obvious at first sight. So, what deviation checking consensus does is it says that we want to get a price that lives externally from the blockchain. And we have a set of oracles that we are using to reach a consensus on what that is. In the very first version of Oracle pools, that consensus of what the price is was just a straight average. This has a number of key issues because it can vary a lot, one rogue actor can cause problems, and these are problems we already understood. However, we knew we needed to iterate in versions and versions in order to be able to ship something and have the ability to build on top. And that's why we're shipping this right here, right now. Now that we're releasing the AgeUSD protocol so that anyone can deploy it onto the blockchain, we're also now officially releasing the deviation checking pools. So we have higher assurance now that we're starting to move into real world dApps that are going to be used on top of Ergo that have the Oracle pools as a key component of them. Deviation checking consensus is the idea that rather than having oracles vote or taking some sort of mean or some other approach, an average is actually the best function to be used for acquiring the current pricing from the oracles. And so, they all acquire information from external exchanges about the current price. However, one oracle might get it, 30 seconds earlier than another, or a minute, or something happens with another oracle and it submits data points a minute later. And the price difference between them actually reflects a change in price, right? And so it's not just you want to trust one of them or you just want to trust another one of them, because they're reflecting the price over time effectively. And so if you average out their prices, you're effectively taking the differences and you're coming to something that's closer to the truth rather than just choosing one or the other based off of a majority. And so the concept of deviation checking is that a threshold is set, a minimum number of oracles that have to agree with each other in order to be in consensus. And so you have a threshold plus a deviation check range. The deviation check range, the deviation range, is a range in terms of percent, 2%, 3%, 5%, and that the lowest data points submitted by oracles and the highest data points submitted by oracles must be within. And so, let's say we have a price that's $1, and our deviation range is 5%. That means if we want to reach consensus, and we have a consensus of, let's say, 5 out of 10, that means at least 5 oracles must all post a price around $1, which will have a maximum range between the lowest and the highest price within this consensus is 5%. So let's say in the most extreme example, that would be the lowest price. So we have one oracle that submits the price 0.95, another one 0.96, another one 0.97, 0.98, and 0.99. And then maybe we can have a sixth one that's actually $1. With these 6, because it's within the 5% range, this is a valid consensus, right? Because they all agree within a 5% range that that is the current price. If, let's say, only 3 of them agree, and typically our range, our variation in pricing isn't that big. It's not actually going to be, 5 cents on the dollar. And so that's just an example to be more explicit. You know, it'll be probably like 1/10 of a cent, 100th of a cent, more likely, maybe up to a cent, generally. And so when we're in this scenario where, say, we require 5 out of 10, but there's one group of people say that the price is 20 cents, let's say so we first had those 6 people in our oracle pool. So let's say there's 10 oracles, 6 of them agreed that the price was about $1. The other 4 are bad actors, and they tried to say the price was 20 cents, not around $1. Then deviation checking consensus prevents those 4 rogue actors from taking over because they don't have consensus, right? They haven't met the minimum threshold. And thus, this provides us with much stronger guarantees and prevention of rogue actors colluding and actually causing problems. And what's cool about this is in the future, once we implement stake slashing, we actually have a model for measuring the cost of corruption. Because if we have a consensus of 5 out of 10, and let's say every single oracle has to put in 20k down in ergs as stake, then the minimum amount of money, and we're not considering reputation, which would also add a lot extra cost to corrupt somebody, but we're just talking pure, simplistic economic analysis. If you require 5 out of 10 oracles to collude, each one has 20k USD in stake locked up. That means you have to do very simple mathematics of 20k times 5, which is $100,000 USD, where you need to measure that the cost of corruption of the oracle pool is at least 5 times 20,000 each, so that's $100,000 if you wish to corrupt the pool, assuming that the oracles don't want to make any other money. And so then, in reality, that would be the minimum cost of corruption in that case would be 100,000 plus whatever each oracle would deem of its own reputation, which can be very varied a lot, plus however much the oracles expect to be paid out in order to be corrupted as well. And so in hard numbers, we can say that the minimum cost of corruption with deviation checking consensus of 5 minimum with a $20,000 stake is 100k plus auxiliary hard to map costs. So minimum of $100,000. This allows us to have now hard numbers. And that's what's really exciting about this kind of stuff, is that we have a solid base, and now we're starting to play with incentives, add in consensus, and have these different features on top of oracle pools to kind of breathe new phenomena within the more basic framework. And so, now for example, if we have the ability to do cost of corruption, I guess I'll leave you with kind of what's possible in the future, since I've talked about it a little bit. With deviation checking consensus, we have a lot more assurance that the oracle pools are going to be producing valid data. In the future, we'll be able to have cost of corruption calculations on top of oracle pools. What's even more exciting is that because we have data inputs in Ergo, and because oracle pools are very open and easy to utilize and combine with other protocols, that means we can build alternative incentive structures on top of oracle pools, which also use cost of corruption, and then it can act even as a layer 2 security measure on top of oracle pools. What this means is that you have a cost of corruption of layer 1, and if you create an incentive structure a security measure that acts as a layer 2 security measure on top of Oracle pools that has its own cost of corruption, then having this 2-layered solution on top of Oracle pools, each with its own cost of corruption, doesn't mean that we have an additive, right? So if Oracle pools cost of corruption is 100K and whatever security measure layer 2 on top of Oracle pools is, let's say, also 100K, the net cost of corruption isn't 200K because the risk is much higher. Because if you corrupt layer 1, the Oracle pool itself, but you fail to corrupt layer 2, then your layer 1 corruption was wasted. And so maybe you invested 100K to corrupt layer 1, but you didn't corrupt layer 2, so who cares? And so that means by having these more complex incentive structures being possible to add on, we can actually get net benefits. We don't just have this additive cost of corruption, but potentially multiplicative. And so we have the ability to scale upwards with fewer resources the security and assurance of our Oracle pools and therefore of our data feeds. This is obviously all quite complicated. There's a lot of research to be done, there's a lot of development to be done, and there's limited resources that we currently have at hand. And so I'm not here telling you that all of this is going to be here tomorrow and we're going to have the perfect Oracle solution right away. But what I am here to tell you today is that we're seeing a very bright future ahead. And we're taking steps from where we're at to already improve step by step by step as we move towards this potentially and hopefully ideal future of trying our best to solve the Oracle problem at hand. Right now, we're really excited that we're releasing Deviation Checking Consensus, and that we really do have a solid base that DeFi dApps can rely on for both the Ergo to USD exchange rate and the ADA to USD exchange rate. These are openly available, and now, right now, with the Ergo Summit going on, you already have access to these pools free of charge for yourself too. And so I'd highly recommend that you explore into the world of DeFi dApps, start using dApps that use Oracle pools like AgeUSD once that gets deployed by someone in the community. And furthermore, also maybe start to look into how to develop dApps on your own, because we're starting to have these primitives, this base infrastructure ready so that the next onslaught, next wave of DeFi dApps on top of Ergo have this very smooth process of being developed, of being deployed, of being shared as headless dApps and compiled to various targets and providing incentives and an entire business model for front-end developers to implement and build on top of. And we're starting to get all these building blocks, piece by piece, block by block, so that we can really have an ecosystem that grows and thrives and utilizes all of the benefits of the EUTXO model.
Hi. Earlier I discussed how we implemented the Ergo USD stablecoin or the Ergo USD stablecoin. Here we will discuss how we are going to update the bank contract, right? If you remember, there was a bank contract that implemented the stablecoin exchange rules. So we would like to update that. Yeah. So let me give a more concrete example. So first of all, let's look at the bank box. So left side is the input bank box and the right side is the output bank box. So each exchange takes as input the old bank box and creates a new bank box. Plus it takes creates other boxes, right? But for now, let's only look at the bank box. So the SC exchange takes in as input a bank box and outputs another bank box, such that the following things are changed, right? The ones highlighted. So the base reserve is changed. The creation info is obviously changed. The SC tokens are changed. So here we see that SC tokens have increased by 1. Tokens are in reserves, so that means it is a redeem transaction. And then SC in circulations are also SC in circulation is also changed, right? So an SC exchange transaction changes these 4 pieces of info. Let's look at RC exchange. So RC exchange transaction changes these 4 pieces of info: the base reserve, the creation info, the RC tokens, and RC in circulation, right? So here we see that RC tokens have increased by 1. So that means it is a RC redeem transaction. So let's look at the bank contract, right? If you recall from my earlier talk, we had a bank contract that encoded the exchange rules. So I'm not going to go into the details of the rules. Let's just look at the last line, which says that the final reserve ratio must be between 400 and 800%. But now we want to increase it to 900 for some reason, right? So we want to update this contract. So basically, in addition to the last 2 spending paths, we want a new spending path, right? In this spending path, everything is preserved except the bank script, right? And the creation info. So the bank NFT, the SC tokens, RC tokens, base reserve, SC circulation, RC circulation, everything is preserved. So this is the update path we need. Yeah. So how do we do that? So let's first modify the bank contract slightly. So we just add one extra spending condition, right? So we say that if the first input has a update NFT, right? So update NFT is another unique NFT that identifies an update box, which I'll discuss next. So assume if the first update box has the update NFT, then we will follow the update path, right? Which means that there is no restrictions. Let the update box encode the spending rules, right? So everything is allowed if the first input has the update NFT. Otherwise, you follow the exchange path, yeah, which is the exchange rules as before. Nothing changed here. And the bank script is slightly modified, right? So now let's look at the update box, right? Where the update NFT is stored. So the update box is as follows, right? It encodes the update transaction, right? So let's first look at the update transaction, then we'll understand the script, right? So update transaction looks as follows. It has inputs the existing update box and the existing bank box. So it takes 2 inputs, plus assume that it needs any additional funding boxes, yeah, for funding the fee. Similarly, outputs contain existing update box. So update box is preserved. Everything is preserved in the update box except the creation info. And the bank box is updated, right? So creation info plus the script is updated in the bank box. And we assume that there's going to be a fee box not shown here. So the first input, the update box has the following rules, right? The first input must be update box. This is the first input. The first output must be the exact copy of this box, except the box ID, right? So when the creation info changes, then the box ID changes. Second input must be the old bank box, right? This is the existing bank box, so also called the old bank box. How do we know it's the bank box? It has the bank NFT, right? The second output must be the new bank box. So what does the new bank box mean? It is a bank box which preserves everything except the script and the box ID. Yeah. And what is the new script? So it can't be any other script. It has to be a particular script. So this script is determined as follows, right? So if the script of the box is some script, then we take its hash. And this value, the output of this hash should be the value in my R4, right? Whatever this value is. That is what this bank script should be like. And secondly, we want that the new bank script should not be the same as the old bank script, right? These two boxes must be different, right? So we cannot update the bank box if it is the same script. That is the additional condition, right? So now we are able to update the bank box, right? In update transaction, the update box is preserved while the bank box is changed. So now this shows us how to do one update, but what about the next update, right? We should be able to update this value, right? In the new script, bank script hash, the R4 that points to the new bank script hash for the next update, right? Otherwise we are only able to update it once, right? So to be able to update it multiple times, we should be having a second path in the update box. So this is the first path, which is the update transaction, right? This shows the first path, and the second path should be the way to update R4. So this shows how the second path is implemented. So the first path is as before, and the second path is given here. Yeah. So the first path is when the the R4 is preserved, and the update part is when the R4 is not preserved, right? So update part, the transaction is as follows. So it has only one input, the existing update box, and it has only one output, the new update box. Plus it will have some funding boxes that I don't show here, one or more funding boxes and fee box. And it additionally has some data inputs, right? Here I've shown 3, but there can be one or more, right? There should be some data inputs with a certain condition. Yeah. So the number of data inputs should be such that the vote is passed, right? I'll tell you what that means in a second. So let me first go through the update conditions. Yeah. So the update conditions is that the first input must be the update box. This is the first input. This first output must be also the new update box. So this is the new update box. What does the new update box mean? New update box means that everything except R4 is preserved, right? Everything except R4 and box ID. So R4 contains the new bank script hash, and that is what we want to change. And the other condition is that the first outputs R4 should not be equal to my R4, right? So this should be changed. R4 should not be preserved. Yeah. We also want this update self path to actually make an update. It should not preserve everything, right? So this requires that the R4 should actually change. And the next condition says that the R4 of all data input. So this data inputs, right? These contain R4, register R4. The value of that R4 should be the this R4 of the new R4, right? The new bank boxes R4, right? So these ballot boxes should encode a value that the new bank box should keep in its R4, right? Finally, the other condition says that R5 of these data inputs should be the box ID of this box. Yeah, this box is box ID. So we know that for which box the ballots were cast, right? So these ballots are kind of tied to this box only. You cannot use these ballots for some other box. That's the condition. That's what this condition implies, right? The other condition says that these boxes should contain one or more voting tokens, right? So each box should have at least one voting token, but it can have more voting tokens as well, right? And these voting tokens are the ones that give the power to update the bank hash, yeah? Bank script. And these should be held by somebody who is able to control these stablecoins. Yeah? So this should be held by trustworthy people, these voting tokens. These are very powerful tokens. And the other condition is the sum of the voting tokens must be greater than 5. Yeah, here I've given 5. It can be any value that we want. Yeah, so it could be 10, for example, if you want 10, at least 10 votes. So here I'm just saying that we want 5 votes for the update to be successful. So this is the vote collection process. I also call it the vote collection. It can also be called as update R4, update self, where R4 is updated, and it's also the process of collecting votes. Yeah. So the idea of calling this collecting votes is because these ballots are tied to this update box. So the moment the update box changes, these ballots are no longer valid, right? So these can be only collected once. Let's look at the ballot box, right? So ballot box contains one or more ballot tokens. Here I've shown that it contains 2 ballot tokens. The script can be anything actually. We don't really care what the script is because these are data inputs. The script is not executed. R4 is the hash of the new bank script. So R4 contains the new value that we want to put into the bank box. The update box is R4. Yeah, this is what the value we want to change. The changed value. R5 contains the update box, the existing update box ID. Yeah, so this is the existing update box ID, which uniquely ties this box to one update box, right? A single instance of the update box. So how do we cast a ballot? So suppose we want to have some script X in the bank box. Yeah, we don't care what the script is, right? It can be anything, literally. So let the script be X. Then we create a ballot box with one or more ballot tokens, right? So whatever, how many ballot tokens you have, yeah, you try to create as the box with as many ballot tokens that you have, and keep the R4 of that as the hash of X, and R5 of that as the box ID with the current update box. Yeah, that's how you cast a ballot. And once enough votes are cast, yeah, once enough ballot boxes are there such that the count of voting tokens is more than 5, then we can collect the votes and update the update box, right? And once the update box is updated, then we can update the bank box, right, as I discussed earlier, right? So this kind of concludes the update protocol. And let me summarize how we handle update in the stablecoin. So the first spending path is the exchange RC or SC path, yeah, which has 4 transactions, right, as I discussed earlier. So these are the same as before. Then we have a new path which says update bank box, which allows us to update the script of the bank box, keeping everything else the same. The other action we have is cast ballot, where multiple people holding the wallet, the ballot tokens, cast vote for the new bank box. And then we have the collect votes action, where once enough ballots are cast, then we can update the update box for updating for the new bank box, right, with the new bank box hash. So that kind of summarizes how the update protocol works. And let me know if you have any questions, right, offline.
Ergonauts, and welcome back to the next segment of the Ergo Summit, the marathon where we cover everything regarding Ergo. For this section, we will take an exploration in the form of a fireside chat with a very special guest whose voice you haven't heard directly before, but in a sense you have listened to through reading the Ergo blog. We have the company of Guy Brandon. Just before we begin, thanks for making yourself available today. I know the community is especially hungry to hear more about you. So to get things started, maybe if you give us some of your background and what brought yourself to Ergo today.
Sure. So I've worked in crypto for just about 7 years now. I got into it very end of 2013, beginning of 2014, first few days of the year. I still know when my first Bitcoin purchase was, which is when when you kind of go down the rabbit hole, I guess that's when you really start. So 3rd of January, which I didn't realize at the time was, of course, the anniversary of the launch of the Bitcoin protocol. So 14 was exactly the 5th anniversary of that. So that's kind of cool. Anyway, so I realized there was a niche for a communicator. I was really interested in the tech. Sort of understood that this was an area I wanted to know more about and was gonna be huge. And so I started looking around for different ways I could sort of put my skill set to good use. I'd been a freelance writer for years and started carving out a bit of a niche. I worked with a few different projects. I started writing articles about Bitcoin for an initiative called BitScan, which was a directory of online merchants. And that was the idea was that, through this listing, they would kind of help Bitcoin adoption by giving people places to spend their Bitcoins. And of course, over the following years, that whole narrative evolved massively. And now, of course, Bitcoin is pretty well carved out this role as digital gold rather than that transactional currency. But that was where we were. That sort of conversation was very live 7 years ago. So I got into a few different things. NXT was my first sort of altcoin project, and I spent a good while kind of looking around that tech and doing various articles, film scripts, and so on. That's actually where I first met Kushti and some of the other guys from Ergo. So it was really interesting to kind of get back into that group from way back in the day when life was very, very different in crypto. It was really cool. It was very, very informal, kind of really startup feel. Obviously, the whole regulation, the market culture was totally different. Loads of fun. And so it was kind of really fun to get back into that sort of mindset and that place with Ergo, which is very, very much a similar kind of vibe at the moment. But along the way, I worked with various different projects, and the way that one thing leads to another. So I did some work with the SuperNet guys, Waves, for a good few years. Most recently, Maker Foundation, and of course, I don't know, I guess getting on for 18 months ago, year to 18 months. I got back in touch with these guys from the NXT days and started doing some work with Ergo, which is obviously what we're here to chat about today, amongst various other bits and pieces around the crypto blockchain DeFi world.
And are you still in touch with this long line of people you've networked with throughout the years? Maker and
lot of them, yeah, lots of them. So I try not to dip in and out of things too much. There's a lot of value in going with something and sticking with it, as much as is possible under the circumstances. So my very first project was Bitscan, which evolved into Instant Loyalty, which is just a fantastic. It's really growing kind of virally. It's this amazing rewards platform for gamers and streamers. Sort of loyalty engagement platform. And again, it's evolved quite a lot, but the idea is fantastic. It's really kind of gaining traction sort of exponentially among gamer streamers outside of the crypto world. So this is one of these really cool crossover initiatives. It's one of just a handful that is hitting real world adoption. And Brazil, guys in Brazil, streamers in Brazil absolutely love it. It's massive there. Because the value of those rewards is significantly greater than anywhere else. And this is one of the wonderful things about crypto, is that it's sort of absolutely borderless and global. And so the value can go where it wants to. So anyway, that's an initiative that I'm still involved with. It's still live. It's been going 7 years, I guess, in one form or another. And it's just kind of hitting that cusp of mainstream traction now and sort of really crossing over into this kind of massive global initiative, which is pretty cool.
Yeah, it sounds great, especially when we considering how far the gaming industry is coming along with Bitcoin and blockchain itself. The history seems to be more focused around adoption and communicating the ideas. Being part of this section of the movement, how have you seen things change throughout the years?
It's been a lot of, really kind of fast paced, big changes. Obviously, the regulatory piece has come on massively over the last 7 years, and just in the last year, few months even, that's come on an awful lot, and that has really pushed adoption in a big way. So that's one of the reasons, or it's the reason really, that institutional investors are now starting to come into crypto in the way that they are. That just wasn't possible even a few months back, I suppose, and certainly not when we started. And it was always kind of the dream, I guess, or the narrative. People have been talking about this for years, and to me, the weird thing about it is things never happen the way you expect they're going to. you have this narrative, this dream, and you know that it's not going to happen quite like you talk about it. But it did. I mean, it happened exactly like we've talked about for 7 years more for some of these guys. The whole thing where people realize that actually money isn't working for them. The dollar is devaluing, and suddenly what's happened since, obviously since the financial crisis of 2008, and then again now with COVID and the economic impacts of that, and just the huge amount of money printing, it's kind of clicked for people. And people have realized, right the way from Joe Bag of Donuts, as Max Kaiser would call him, right the way through to the likes of, Michael Saylor of MicroStrategy, right the way through to central banks. They've got this idea of digital gold. They're recognizing that there is a lot to this technology. I mean, yeah, value storage, sure, but more than that. And it's just kind of hitting the mainstream now. So I would say, actually, 2020 has probably been, to me, it's been the biggest year for crypto since crypto has existed. This has been the Rubicon year. There's no going back at this point. It hit escape velocity this year in the aftermath of that kind of market crash, COVID prompted market crash, and I think that's it now. There's no putting that toothpaste back in the tube now.
I mean, just thinking back to 2017, for example, I would have never expected myself to see things take off this fast. Even back then, it seemed pretty unrealistic in a lot of senses. This year itself, we've seen the rise of DEXs, automatic market making, oracles bring out. Where do you think things are starting to go, considering what's happened in 2020?
For DeFi or for the crypto industry as a whole?
For the crypto industry as a whole. Maybe we could move on to DeFi.
Let me start with the crypto industry. So I think what's going on is, sort of thin end of the wedge stuff. So obviously you've now got quite significant mainstream institutional adoption of crypto. But I still think that is, that's only a starting point. That's the thin end of the wedge. And you've got, almost every day, you've got a new corporation coming along and saying, yeah, we think we're going to put 1% of our assets in Bitcoin. Or if it's, Michael Saylor has just announced, this is just this second week of December we're doing this. So he's just announced I think $500 million equity raise with the intention of putting that into Bitcoin, which is pretty incredible. So, that company will hold a total of, well over $1 billion worth of Bitcoin. It's just one company. Jack Dorsey, Square, 1%. You've got kind of currency analysts. JP Morgan is now making recommendations, whereas back in 2017, I think even, certainly a year or two before that, he was very much, he was sort of the Warren Buffett school of thought, rat poison squared kind of stuff. And these guys have come around. And not only have they started to concede a little bit of ground, but they're actually actively advising people now that this is something you need in your portfolio, high net worth investors, corporations. And so we're really accelerating pretty fast in that direction. So crypto, we always kind of knew it was here to stay because you can't really kill a decentralized system. But just the level of adoption now is really, it's quite remarkable just what's happened this year. We came into 2020 in a pretty good position for crypto. I think it wasn't, we got over the worst of that sort of bubble aftermath. 2018 was pretty brutal. 2019, things picked up a fair amount, but we were kind of trundling along. And then, COVID came along, really took, I think, almost everyone by surprise. And then we had this huge crash. And then there was this sort of recognition as this is an asset class that can not only handle that, but it comes back stronger than ever. And with a regulatory piece in place, people just run at it. I mean, big companies, and that the technology obviously comes with that as well. So development of the technology. So I think crypto has established itself now. That's not going away. And I think the next stage is all these developments in the DeFi world. Now they're going to start coming on the back of that, because you have this, this established use case, and that's really that the hard work has been done. The sort of winning hearts and minds has been done, and now it's just about unpacking that, and that's that could be the fun bit, right?
Definitely. And on the notion of companies allocating 1% of their portfolio to a cryptocurrency, do you think this is going to become a standard? Do you think 2021 could be the year of adoption?
Yeah, I mean, I think we've already seen the start of that. And for some companies, it's been 1%. There's a company in UK, Neo, I think, was one of the first to do this. Square has obviously done it. But then you've got others like MicroStrategy, which have, pretty much gone all in, and then some. So I think for some it'll be 1%, but I think that'll be the lower end for a lot of them. I mean, a lot it's going to be 5 to 10. Maybe it'll be a hedge, maybe it'll be a sort of looking for a bit of alpha. In some cases, it's going to be more than that. But I think people increasingly realize that you need a diversified portfolio, right? You don't want to put all your eggs in one basket. Maybe you don't want to put them all in the crypto basket. Sure, it's pretty scary. But you want to diversify, and this is a totally legitimate asset class.
And maybe if we carry on a bit with the DeFi, we saw a considerable amount of hype during Q1, Q2 that has died down quite a considerable amount. Do you think this had any meaning? I mean, is there a future for DeFi at all?
So I would kind of view the early 2020 yield farming hype a little like the 2017 bubble. So this is the kind of lots of heat, not so much light kind of phase. And then what happens is the bubble bursts. In 2017, you get some criticism, but actually guys are building this stuff all the way through. This is now when it goes quiet, when it's not in the news so much anymore. Once you've had a few scams and scandals, that's when the work really gets underway. And when it's quiet, you can get on and build stuff. And that's exactly what happened in 2017, 2018. That bear market was brutal for hodlers, but actually the tech was coming on, the regulation was coming on, all that work was going on in the background. And I think that's exactly what's going to happen with DeFi this time. It hasn't really burst in the same way. It's actually still a huge market. I think TVL, total value locked, in DeFi projects hasn't actually dropped so much. It's quietened down a bit, but all that innovation, all that work is still very much going on behind the scenes.
All the noise that comes out of the industry, it definitely makes it hard to focus on what's going on. And with the total value locked, do you think that is a relevant metric? Could it just be some people climbing onto the hype wagon and looking to make some use of that asset that's laying around?
Yes, so absolutely. It's one of those things. It's probably about the best metric we've got, right? I mean, it's like market cap for crypto. In one sense, it's pretty meaningless. On the other, it's it makes as much sense as it does. It's a good enough metric, and it's growing. And you can sort of see where the money's going. You can see where it's been allocated, and so on. It's pretty good. I mean, I'm sure people will come up with much better adoption metrics, but as a fairly blunt tool, it does the job, right?
Yeah, I guess it holds some value. The
point is, you can sort of see the direction of travel, just like Bitcoin market cap or whatever.
And with the technology or features that has been coming out of DeFi, a lot of it has been drained out from yield farming. Do you think there's anything that's actually relevant so far?
In DeFi, in terms of features, there's two or three kind of big themes. So the first one is obviously decentralization, and I think that has to be the main metric. And again, this is one of the places where Ergo comes in, because they've really prioritized this. But it's decentralized finance. Obviously, decentralization is the big It's the big use case, it's the big benefit. And what we've seen is an awful lot of DeFi initiatives that are actually not so decentralized in one way or another, whether it is the the underlying network, the infrastructure, the blockchain infrastructure, whether it's smart contract risk. There's a bug somewhere in a smart contract, that infinite mint bug that we've heard a lot about. It's a whitelist somewhere. It's somebody holding a private key that maybe they shouldn't. It's a kill switch. There's just all kinds of single points of failure. And so a lot of DeFi is kind of CeFi, really. It is centralized in one or other aspect. There are single points of failure. And it's really, obviously, it's the decentralization that matters. And so we got to nail that. Because it's only when it's really decentralized. I mean, that underpins everything, right? It underpins the accessibility and the openness. It underpins the composability. If you think about something like a USD coin, it's not entirely composable, because you've got this problem of what happens if they whitelist or blacklist. Saying, I think the same with Tether. What happens if they blacklist an address? Suddenly there are coins, how does that interact with other dApps and smart contracts? What happens when you are threading transactions through a whole series of different dApps and you've got a blacklisted address somewhere? Just this, this sense that there are possible sort of unintended consequences. There are maybe complexities we haven't quite figured out here. I don't know whether that sort of comes under the category of systemic risk, but I can see a situation where things might sort of fall apart because one element is centralized and doesn't allow for functionality that it should in the decentralized finance world, right? And so being truly decentralized, being truly open, sort of enables all these other characteristics that are the true benefits of DeFi. So one of those is composability, this sort of Lego money thing where you can build dApps, you can plug them into each other. You can kind of tap into those networks, that network effect, those user bases. And if it's really decentralized and open, the world is just your oyster. You can plug whatever you want together and just gain all of those benefits. All of that transparency, that security, that openness, that global user base, it's all there, but it's got to be truly decentralized for that to be guaranteed. And so that kind of comes into one of the other big themes, I think, of DeFi, which is composability, and just that ability to plug those dApps together and sort of copy code, fork it if you want, modify it, change it, build something new, plug it into existing dApps. I mean, that has been really why I think DeFi has grown so fast, is because you can take a currency, a coin, a token, whatever, plug it into your dApp. You can plug that dApp into another one. You can plug it into an AMM or a DEX. You can borrow against it. You can plug it into another lending protocol, whatever it is. All of this stuff, it's just a virtuous circle. And it just snowballs, and that's really what's powered DeFi.
And the application of a big red button, also the availability to be able to blacklist and whitelist, is a large contribution to what is making me anti-Ethereum in some sense. What would you say is your most important feature out of DeFi? Would you claim it's the decentralization?
I think decentralization, proper decentralization underpins everything. You've got to decentralize across every different aspect of your platform. So you've got to run on a properly decentralized network. It's got to be open. You can't have a single point of failure in for example, it's only your token's only traded on one exchange. You can't have a kill switch or a bug in the dApp code. There are lots of different forms of decentralization. You shouldn't really have, obviously, one holder or a minority of holders with a very large supply of the token. all of these sort of they're different forms of centralization or decentralization. And to whatever extent possible, you can't fully decentralize across every different aspect of a platform and initiative, but to whatever extent possible, we should be decentralizing. And I think, the composability is a big deal, because that's what turns the conventional sort of thinking on its head. Conventional economic thinking is you have walled gardens, you have a proprietary code, you keep stuff to yourself, you hold the value, you don't share, you don't let other people have that, because that's the way you make money. DeFi is, it's this open source philosophy. That's how you build value. It's by giving it away. It's kind of crazy for conventional thinking, but that's how it does work. That's why Linux is the massive deal it is. It, basically props up the internet and the world. It's absolutely permeates everything. People don't know it because it does its job so well, but it's open source, and it's just there in the background. It's brilliant. It's secure, absolutely pervasive, and it's the same with it's the same with DeFi. That's the opportunity.
And on the idea of Linux, it's open source, it's free, and sadly, not everyone is aware of it with the occurrence of Windows. Do you think this is something to worry about within crypto as well? The real products at the bottom of the list?
I think the sort of adoption will be actually pretty similar, because Linux only accounts for about 2% of desktop systems, but it runs the world. I mean, you think of it's behind the scenes, and I wouldn't expect regular users to use MetaMask and engage with dApps and go on to whatever dApp portals and interfaces. Ultimately, I mean, that's where we're looking for adoption now. But in the end, it's just going to be behind the scenes. You won't even know it's there. It'll be like I don't know, TCP/IP or something. Back in the 90s, you had to know what you were doing to connect your computer to the internet and send emails and stuff. Nowadays, you just don't need to know that stuff. It's just behind the scenes. It has sorted out the interfaces. The UX is it's just not an issue. It'll be the same one day for DeFi.
And how does Ergo fit into all of this for you?
So Ergo, which we finally get to, has got some great solutions. So it really has prioritized decentralization in a whole bunch of different ways. So partly the nature of the network, the decentralization of the network infrastructure. You've also got the way you can run nodes, so that helps. So we'll talk about these non-interactive proof of works at some point, which allow you to pretty much run a full node without very little overhead at all. So very efficient. In terms of the composability, is another huge deal. So you've got these Sigma protocols, which are it's highly composable cryptography, and you can put together some very powerful sort of it's composable signatures. You can put together some very powerful use cases that you simply can't with a platform like Ethereum. It would just be too complicated. You get some risky kind of edge cases. It's expensive. Pretty much, you just can't do it. So Ethereum is Turing complete, sure, but that doesn't mean that it's efficient and it works well for every use case. It's a little bit, the analogy I like to use is, it's kind of easy to build a jet engine, right? There are simple jet engines you can build with stuff in your garage, yeah, with a can of gas and a piece of pipe. It's totally doable. People do it all the time. Would you want to do it? Would you want to fly a plane with one of those on it? Not so much. And it's that kind of thing. And so it's that kind of granularity of the composability. You can put together really complex, bespoke signatures for really powerful privacy applications. Can't really do that with Ethereum. You can stack together these dApps that are then built with these really secure little components, right the way down to, I don't know, the security of the way the script works. It's kind of Turing complete. You can get Turing completeness, by treating it the right way. But you don't have that kind of ambiguity that you do in Solidity and Ethereum smart contract language that sort of raises these awkward security exploits. So there's a whole bunch of different features about Ergo, which I think are great, really power sort of full decentralization across all these different domains and maintain that security.
And just for the record, anybody that's tuning in, we are not recommending to try and build a jet engine. If we move on to the news, the grapevine for the moment, ETH 2.0, it's meant to answer a few problems regarding scalability. There's mentions of the project Radix and whatnot. Is this really innovative? Do you think there's anything there, or?
Yeah, absolutely. So I think both of those, scalability is obviously a huge concern. And, you know, we always hear about this scalability trilemma. You need to scale a platform, otherwise it's not going to support even a fraction of the transaction volumes that you need in a global financial system. So you need scale. But you need to do that without compromising on security. And you need to do that without compromising on decentralization, which of course will also, you know, introduce a security, you know, loophole, possible vulnerability there. So this so-called trilemma: security, scalability, and decentralization. And so different initiatives are approaching this in different ways. And, you know, for what it's worth, I think ETH2 is pretty incredible. You know, that is a huge engineering task, and you've got to respect that. It's pretty remarkable, the ambition behind that. Now, it's going to take a few years to know how that pans out. You know, Radix the tech is pretty impressive again, and they are working right at the edge of what's possible. So again, huge respect for the work these guys are doing. Of course, these are a few months or potentially years down the line, and we don't know how that's going to work out, and the need is now. So the approach that Ergo has taken is that, you know, there is actually, we can work smarter as well as harder. There is a lot of headroom left in kind of conventional blockchain. If we're smart in the way we use this, we can actually push a lot more transactions through that without kind of resorting to the kind of clumsy fixes of, oh, let's just increase block size, or let's reduce the number of block validators. You know, you look at a lot of platforms, they've got maybe, you know, 20, 30, maybe 100, but not many block validators. And the faster the platform, the fewer the validators typically. Or they've got huge block sizes. You know, you've got, and then of course you centralize the network around miners who can afford those resources, the storage, the bandwidth, and so on. So Ergo has prioritized a set of technologies that enable scaling without kind of taking on the huge engineering challenge and the sort of speculative success of some of these kind of complex sharding you know, initiatives. So down the line, yeah, great. We might be able to build that in. Right now, we're not sure that those are going to work. You know, there's no platform that's really solved that trilemma yet. And so, you know, Radix is working with what we've got and kind of using that extra headroom that we know is there, if we can kind of cut out some of the unnecessary sort of ways that space is used.
And furthermore, with building all of this technology on top of Ethereum, do you think it's necessarily worth their time with the accounts-based model? Do you know much about that, or any information you could offer?
So I think it's, you know, it's horses for courses. There are different advantages and disadvantages to accounts and UTXO models, which is what Ergo uses. Yeah, I'm not going to. I'll let I think Robert Kornacki go into some more detail on that, because that's his thing. Yeah, just said. I mean, the market is currently, it likes Ethereum, and you know there are good reasons to, you know, for developers to look to that model, but we know that there are issues with that, and Ergo offers something quite different, and I think there will be applications where, you know, you want that sort of proven security of the UTXO model, that different way of doing things, some of the sort of unique benefits you get from that, and just some of what it allows you to do. But yeah, this is definitely Robert's domain.
And there is a sea of functionalities built within Ergo. If you had to cherry pick several, what would they be?
So Sigma protocols are a pretty big deal. That composable cryptography, which just lets you kind of plug together whatever signatures you like. So you can have all these complicated, multi-sig or 2 of 3, or, one master key plus 2 of 3, or just, it really allows you to kind of take that to its logical conclusions. And that's pretty cool. And I think, privacy is obviously going to continue to be a big deal, within DeFi as that sector expands. You're going to start getting questions about it. It's not going to be the whole tax avoidance, drug purchases thing. It's going to be actually corporate privacy is a really big deal. You can't let your competition know what you're doing. Industrial espionage, all the rest of it. There are so many reasons to get this right. But I also think in a world where, we recently heard that France is, I think they have just banned or seriously talked about banning purchases of privacy coins. So you're not going to be able to use Monero. You're not going to be able to buy Monero. The US has taken a huge interest in this. And so the sort of possibilities of opt-in, auditable, but also private transactions, this allows you to do some stuff that hides your transactions from the guys you don't want to see them, but also enables you to audit this and stay compliant. So, there is a huge use case here. And I think that's, Sigma protocols are really powering that. And I guess the other one that's really interesting is the non-interactive proof of works, which allows you, these are very sort of lightweight proofs to enable you to pretty much run a full node with the same security as a full blockchain download, but you can do this on almost any device. You can run a full node on a Raspberry Pi. You don't have to worry about downloading the entire blockchain. You don't even have to worry about downloading all the headers, which for something like Ethereum would, that's still several gigabytes of data. And it just allows pretty much anyone to run a full node and allows that network decentralization, allows you to use, any device. And so you're not, as the network scales, you're not compromising on decentralization as more and more data is sort of contained in the blockchain. So that's also a pretty big deal. And I think several other platforms are now, major platforms are looking at incorporating those technologies because they have such security advantages and kind of walk that line between, security and convenience.
The countries that are pushing these technologies aside, such as France, turning their back towards it, will definitely be the ones that suffer the most. How do you vision the future of Ergo, considering these knee pow-pows? Could it be a hub of interoperability between chains? Where do you see us going?
Yeah, I think interoperability is going to be one of the big themes of the coming years, because you're getting a lot of different platforms, but most of them are still siloed. So whatever you think about which platform is going to win, that's not the thinking we need to be adopting in the crypto world. We have seen the benefits of open source, of composability, and that should be true across blockchains as well as within them. So yeah, Ethereum is a huge ecosystem, but actually a lot of these other platforms are going to be growing. They're going to create their own sort of self-contained ecosystems. But the real benefit is when you can seamlessly interact between all the different blockchains. You want a blockchain of blockchains, and we've had our heads in the crypto world for years. We've been immersed in that. You have this sort of this kind of cult mentality almost of this is the blockchain. Actually, most users don't care. Most mainstream users aren't going to care. They're going to want the functionality. They're not going to mind whether it's got the Ethereum label or the Ergo label or what on it. It's just going to be, like the cloud. Do you really care whether it's Apple or Dropbox or Google or whatever it is? You want the ability to store your files somewhere not here. That's the functionality. the branding is kind of, well, it's neither here nor there. As long as that functionality is there, and it's going to be the same with blockchain. So yeah, I think if we can plug different blockchains together, that's going to be a big win. And if you can do it seamlessly as well, that's the real catch. Seamless composability, I think, is the holy grail.
And out of all of this, what do you think the next trend might be within crypto? Something similar to DeFi, or could it be a aspect of interoperability? Yeah,
and I think it's sort of bringing this more towards its logical conclusion. So we've got atomic composability. Composability is the ability to plug different components together and enjoy that network effect. Atomic composability is where you sort of run all this stuff absolutely seamlessly. So it's imagine a flash loan. You can borrow money with essentially zero collateral. You can deploy that. You can maybe arbitrage between different DEXs with DEX and AMM, and you can repay that and take the profit. And all of that happens within one block. That's pretty remarkable, but that requires seamless composability. You can't have a delay of even one block, or those sorts of applications won't work. Or, you think of the sort of classic application, you're going on holiday, you want to book a hotel, you want to book a flight. You don't want to book the hotel without having the flight in place, and you don't want to book the flight without having the hotel in place. You've got to do both or neither. And it's that kind of application, that's that atomic all or nothing approach. And so if we can nail that, that will be huge. And I'm not sure whether that's going to work across blockchains. Maybe we can figure that out. But certainly within blockchains, that's hugely important. And that's one of the problems that a lot of scaling solutions doesn't allow for. So figuring out atomic composability at scale is huge.
The functionality for all of this is definitely there and growing. Is there anything else that you would add on to or elaborate on to for today then?
No, I think that's most of, in my mind, those are the big sort of themes. Decentralization has got to underpin everything. That's where all the benefits come from. Composability is a huge deal. Atomic composability is the holy grail. If you can do that all with privacy and without compromising on any of the single points of failure right across the spectrum, that's a pretty big ask. And I think you're right. I think it is doable, and I think we're getting there. That's the sort of moonshot, right? That's the big challenge. Once you can nail atomic composability at scale with privacy, you're home free, I would say. And that's the point at which you really start to contend with the existing financial infrastructure.
And there we have it for the fireside chat today, guys. Guy has plenty of experience within Ergo, and the insight he has offered today has the opportunity to enrich all of our minds within the crypto space and what Ergo can do itself. I hope you'd enjoyed today's chat and look forward to the rest of this Ergo Summit. Thank you.
welcome to Ergo Summit 21. My name is Savo and I'm the CEO of RPC Fund Management and the youngest hedge fund manager in the history of planet Earth. I'm also a member of the Ergo core team, and it's really a pleasure to be here and to be able to present my vision for Ergo as well as make an important announcement. So let's get started. First of all, I want to look at the historical context. Every single era in human history was characterized by one particular good or commodity which divided society into those who do and those who do not hold institutional power. In medieval times, this commodity was land. It divided people into the aristocracy and the peasants. After the Industrial Revolution, this commodity were machines. They divided people into those who are the capitalists and those who are the proletariat. But today, this commodity is data, and specifically, your personal information. It divides our society into those who control and those who are controlled. Freedom is impossible without financial freedom, and financial freedom is impossible without privacy, because if you know how someone spends their money, you know everything about them. Our job is not to be the moral arbiters of the world. Our job is not to tell people what they should do with their own money. Our job is to make it possible for people to do with their own money whatever they please. And this is why we have built Ergo, the most fundamentally sound, the most advanced, and the most complete cryptocurrency in existence. Ergo is deflationary but scalable. Ergo is designed to be held but also to be used. Ergo is decentralized but also has a very robust ecosystem which we work very hard to add to every single day. Ergo can be perfectly compliant for the use by the biggest banks, and it can be perfectly private for the use, in theory, for example, by the counter economy. So no matter if you want to use Ergo to modernize a part of the settlement process in your investment bank, or you want to use Ergo so that you never have to rely on the legacy financial system again, and you want to, for example, make a living by selling NFT artworks in the Ergo auction house. It's our job to make that possible for you. Ergo is visionary but focused on the real world, because all the grand visions, all the philosophical promises in some of the greatest white papers are worthless if they can't be used by real people in real life. And this is why I'm very proud to announce that Ergo will be listed in the software of General Bytes, the world's largest manufacturer of crypto ATMs, which will allow ATM operators throughout the world to list Ergo, or in layman's terms, this will allow you, our great Ergo community, to literally walk up to your local street corner, walk up to a Bitcoin ATM or crypto ATM, insert literal physical cash into the machine and receive Ergo, or the other way around, to sell Ergo for real cold hard cash. As I said, it's our job to give people a choice. Now listen, my vision for Ergo is not to be the next digital gold. It's not even to be the next digital cash. My vision for Ergo is to be digital apples. Because although our brain was programmed to perceive gold and US dollars as symbols and measures of wealth, you'd be surprised how expensive a single apple can get in terms of golden coins and US dollars in the event of a global famine. In order to do the most, you should do no more than what is necessary. And we believe all of the things that our projects are exploring as something visionary or futuristic, such as oracles, true decentralization, true privacy, and a scalable solution for algorithmic stablecoins are necessary. We believe all of this is necessary, and not only that, we are already developing and have already developed much of that, or the means to produce much of that in terms of stablecoins, for example. Now, you see, 4 years ago, I tweeted that the impossible trilemma of crypto is privacy, price stability, and decentralization. Although it's fairly easy to have 2 of those in your cryptocurrency, it's almost impossible to build a cryptocurrency that has all 3. I'm very proud to say that we have made that cryptocurrency. Ergo beat the impossible trilemma of crypto. Ergo is the project that probably excites me the most, and the project that, made me the most happy to work on. All the people on our team, there's no part-time approach. There's no full-time approach. There's only all-the-time approach. All the people on the team are workaholics, fueled by enthusiasm and support for Ergo. Before Ergo, as you know, I work in legacy finance. I own a hedge fund, but I've also worked on some of the top stablecoins and on some of the top privacy coins. We are trying to build a team with a huge range of backgrounds because we want to be that bridge between the current financial system and the financial system of the new age, the financial system of the future. And to do that, you have to have people who are well versed in both of those systems. All of this would be impossible without you, our great Ergo community. Your support, your enthusiasm, and the feedback that you provide us with fuels all of us to keep working very hard. In terms of that feedback, we have received it, and we have made it our priority. Although there have been some mishaps in how the project was run so far, we're proud to have addressed that with a team structure that helps us move forward, with a new focus on marketing and coordination of both guerrilla, community-based marketing, and also old school, centralized, top-to-down, traditional marketing techniques. All of you have asked for more than that. You've asked for exchanges, you've asked for major media support. I don't think we're not listening. In fact, I'm very proud to say that in the coming days and weeks, we will announce new exchanges, and that we will also, you will actually be able to see some of the most mainstream media platforms in the world writing about Ergo. We are spearheading the new age of cryptocurrency. We are the trailblazers, and Ergo will unleash the new wave, and as I said, the new age of blockchain. This is why the protocol that allows anyone to launch a stablecoin on top of the Ergo network, AgeUSD, has a very special meaning to me. And once again, I want to say I'm very thankful for all the motivation and all the support you, our great community, have given us to accomplish all of these great things. That's it from me for now, and enjoy the rest of the summit.
Hello Ergonauts, I hope the summit's going great. And here we now have another demonstration from a non-real, this time for the Zero Knowledge Treasury. A ZK Treasure is a joint spending dApp which preserves on-chain privacy. A group of people can jointly spend their funds, Erg, wrap tokens, and so forth, securely without anyone knowing which one of them participated in the protocol. So let's have a distributed signature between Alice, Bob, Carol, and John. As we can see, at least 2 of Alice, Bob, and Carol has to sign. Also, John's signature is always necessary for the transaction to be a valid one. Let's use the ZK Treasury dApp to manage sample USD assets. First, we create a team in the ZK Treasury server representing Alice, Bob, Carol, and John, representing Alice, Bob, Carol's, and John's distributed signature that we just saw. Now we can create proposals for the team we just created. Team members can see proposals and decide to approve or reject them securely using the ZK Treasury client. Normally they will do this process locally and separately. However, for the sake of this test, we have run 4 different clients on the same PC, each representing one of the members. We create a proposal to ask for 100 sample USD tokens. Let's say Alice rejects the proposal and all others approve it. When enough signatures are collected, the transaction will be signed and the proposed sample USD amount will be sent to the proposal's address. We just need to wait a bit for the transaction to be generated and mined. Anyone seeing the transaction on chain cannot know who has actually participated in the signing process, but can verify that the signature is valid. I hope you've enjoyed this quick rundown of what the ZK Treasury is, and we can let it serve as an introduction to its more prominent usage in time to come. For now, that's all from a non-real, and enjoy the rest of Ergo Summit.
Hi, in this talk, I'll be talking about something called JSON dApp environment, also known as TX Builder. So this is a tool for interacting with Ergo dApps. And I assume that you have seen my earlier talk on Kiosk because it is necessary to understand Kiosk before we dive into JDE. So moving on. I'll go through a quick recap of what I discussed in my earlier talk on Kiosk because this more or less builds on top of it. So here we see the Ergo stack on the right side. This is the Scala stack and Kiosk is built on top of this. So on the left side, I discussed some features of Ergo which we can refer to in my last talk. Here I've just shown what a Ergo box looks like. So Ergo box, a box in Ergo is another name for UTXO. So UTXO is a general term, and in Ergo, UTXOs are called boxes, right? So whenever I refer to box, I'm referring to a UTXO of Ergo. So in Ergo, a box has 10 registers numbered R0 to R9. First of 4 of these are mandatory and the remaining are optional. And Kiosk allows us to create a transaction with boxes having certain values populated in the registers. So JDE will also allow us to do that. Here I am showing what a Ergo transaction looks like. So as we can see, a transaction consists of 3 sets of boxes. The first is the set of inputs. These are the boxes that must exist on the blockchain, already exist on the blockchain, that is. And these boxes will be destroyed. Or we also say that these boxes will be spent. And when a box is spent, the script inside the box is executed. So whatever the script contains, that will be executed, and that must evaluate to true for the transaction to be valid. So in this example, there are 2 boxes. So both the scripts should evaluate to true for the transaction to be valid. Next, we have the data inputs, which are also a sequence of boxes, but these are not spent. So these boxes must exist in the blockchain at the time of creating the transaction, or rather at the time of mining the transaction. But these boxes will not be spent. So they will just be read and they will be put back into the pool, into the UTXO pool. So the script inside these boxes need not be executed because they are kind of used in a read-only mode. And they are not really, the script is not executed, but any data inside these boxes can be used in our smart contracts, including the script, because which is also part of one of the registers, and it's considered as a data. Finally, we have the output arrays, which are another set of boxes. These are the boxes that are created, so they don't exist yet before the transaction. They will exist only after the transaction is mined, and they will be added to the UTXO set. So what we want is a tool that allows us to extract from the blockchain a set of boxes that we can use as inputs, another set of boxes that we can use as data inputs, and perhaps some other set of boxes that we don't need to use in the transaction, but we may need to compute intermediately. For example, we may need to take another box and use that value as the value of the output. Yeah. So these would be called auxiliary boxes in our discussion. So to summarize, Ergo transaction has 3 sets of boxes: inputs, data inputs, and outputs, out of which the inputs will be spent, the data inputs will not be spent, and the outputs will be created. Here I'm giving a quick recap of what is Kiosk. So as we can see, Kiosk is a library on top of Ergo AppKit, which is again a library on the Scala stack of Ergo. And last time I showed how to use Kiosk Web to manually sign a transaction for a timestamping service, right? And that Kiosk Web component used something called Kiosk Lib, which is a headless library running on Scala. And JDE is a small component inside the Kiosk Lib, right? So this is what I'm going to be talking about today. Last time I talked about Kiosk Web without JDE. So here I'm going to show what the timestamping service is. This is the dApp example I'm going to be using for demonstrating JDE. So for details, please refer to my earlier talk. On the left side, we see the script of the timestamping box. So to summarize, this dApp consists of 3 types of boxes, right? One is the box B that we want to timestamp. So here we are showing that box B. So this is the Alice's box. The second is a timestamp emission box called E, which emits the timestamps. So here, this is the timestamp emission box, and this is the emitted timestamp, this one, right? And finally, the box T, which contains the actual timestamp, right? So this is the emitted timestamp box T. So here we see a transaction which has one input, which is the timestamp emission box, one data input, which is the box that we want to timestamp, the box B here, and the output contains 2 boxes, right? The first box is a copy of the timestamp emission box, because like I said, the timestamp emission box in the input will be destroyed. and the output contains a copy of that exact timestamp emission box with some minor differences which I'll get into in a second. And the second box is a timestamp box, which contains the actual timestamp that we will use in some other dApp that wants to use some timestamp for some purpose, right? So what this is doing is that if you look at this input, it has some timestamp tokens, right? Which I am just going to refer by token ID. It has 499 of those timestamp tokens. And what we see here is that this transaction takes out one token and it puts it into the timestamp box. Here we see that in R3 there is one token of the same token ID. And the balance tokens are put in the copy of the timestamp emission box. So here we see that it has 498 tokens left that are now ready for use in another timestamp by somebody else. So this is the app that I used in my example last time. And here are the steps to do that manually via Kiosk, which I did last time. Yeah? So I'm going to summarize the steps that I showed you last time in manually creating the timestamp via Kiosk. So first step is that we collect the following details from a block explorer or somewhere. So this is not related to Kiosk, basically. This is more or less something external to Kiosk. So we get the box ID that we want to timestamp. This is the only information we actually should need, right? The rest of the thing should be automated. So anyway, let me just summarize this. We need the box ID of the box that we want to timestamp. Then we need the box ID of the timestamp emission box, right? So using this, we can fetch the, we can use it as a input, and this we will use it as a data input. Then we need the token ID of the timestamp itself, right? So because we'll need that to create the copy of the timestamp emission box plus the timestamp box. Then we will need the current height as well, right? So why do we need the current height? We need to store that in R5 of the timestamp, which is the entire purpose of the service, right? To capture the height at which the box was created or the height at which the box existed. Finally, we need the funding box ID and the corresponding private key. Then the next step is that we create a variable for R4 containing the box ID. So it contains the box ID of the box we wanted to timestamp. Then we need to create a variable for R5 of the timestamp box. And this variable is the current height. So this is the height that we just got here. Sorry, this one. And then using these two information, we can create the timestamp box. And finally, we send the transaction. So at the right side, I show the manual steps that we involved, right? That were involved. So the first set of steps were using the Explorer, getting the box ID, getting the height, and getting the token ID. The second set of manual steps were on the Kiosk front end, which was create an environment variable called R4. By the way, in my earlier talk, I used the variable R4 because it was used in register R4, but there is nothing special about the name. I could have used any other names, for example, my column byte, my collection byte, or hello, yeah, anything. I could have used any variable here. And similarly, the second step is to create a variable called R5 that stores the height. Then we create the timestamp box, and then we create the transaction and then broadcast it, right? And the other thing is that all these steps must be done very quickly, yeah. So R5 is the height, and if we waste too much time in broadcasting the transaction, then R5 will expire and the transaction will no longer be valid. So we'll have to create the transaction once again if we delay in broadcasting it. So let me see, we want to see if this can be automated, right? So let me try to demonstrate this, use this example as a demonstration of the automated TX builder or JDE. So what is JDE? Basically, it's a tool to automate dApp interaction via Kiosk. So it's kind of loosely coupled with Kiosk, or it is, if needed, people can use this in their own wallet as long as they build on top of Kiosk. That is also explained in the documentation. Coming back, so JDE is a JSON-based script for automating Kiosk. So what does it automate? It automates all these 4 tasks that I mentioned earlier: reading from the blockchain, local computation, creation of the transaction, and broadcast. Yeah. So what does reading means? Reading means fetching certain boxes for inputs, data inputs, and auxiliary inputs. So like I said, auxiliary inputs are inputs which you don't want to use in the transaction, but you may want to use them during computation, yeah, while you create the transaction. And this should be possible via filter. So we should be able to filter boxes based on various criteria, which I'll explain in the next few slides. Then the second task for reading from the blockchain would be extracting registers and tokens of the fetch boxes, right? So tokens means the IDs and the amounts. and then store these in variables and then use those variables in further computation, right? So next step is the local computation, right? So this is, for example, defining certain constants and then performing operation on those constants and variables, right? And then defining certain registers and tokens and then finally use them to create outputs. So as an example, in the previous slides, I was showing the timestamping service, right? So we needed to get the current number of tokens held in the timestamp box, which was 499. And then we needed to subtract 1 from that and create the new timestamp box with those tokens, which is 498. So the script should not really care about how many tokens are there. It should not worry whether there are 499 or 500. It should just say that whatever the number of tokens, let that be X. Take out 1 from that and create an output with that balance value. All right. So this is what it should allow us to do. And then finally, it should allow us to create a transaction with those inputs and data inputs and outputs. So let me now give you an example of how it happens. So reading the blockchain, right? So reading blockchain is the most intensive, or not rather intensive, but the most complex task. So I'll spend a little bit more time on this, and defining outputs is more or less a subset of defining inputs. And defining inputs is the task of blockchain reading, right? So when I say blockchain reading, I mean I'm defining inputs. And inputs come in 3 types. First is the actual inputs of the transaction which are being spent. The second is the data inputs of the transaction which are not being spent. And the third are auxiliary inputs, which are neither spent nor used as data input. They are used only during computation and then discarded. So how do we find inputs, right? So, or how do we find boxes? So we can find boxes by addresses or by box IDs, right? So let's assume that we want to find boxes by address. Say we want to find the timestamp emission box by its address. So the first step is to define those addresses via constants. So there is something called a constant declaration, which roughly looks like this. So there is a keyword constant, and then, the keyword is not there. It is just a set of text in the parentheses. So the first is the name, which in this case is called pool addresses. The second key is values, which in this case now is an array of 2 values, right? And the third is a key called type. Yeah. So third field or a key is the type. A second example of address is here, where I have not used values, but instead used a value, right? So constants can have 2 fields, one of 2 fields. Either it can have values or it can have value, but not both. So values can have multiple strings, while value has only 1 string. So in this example, I am using the Oracle pool example, right? So if you are not familiar with Oracle pool, refer to my earlier talks where I discussed about Oracle pool in Ergo. So Oracle pool is consisting of 2 types of boxes. One is the epoch preparation box, and the second is the life epoch box. So here I am defining a pool with these 2 addresses, right? So the pool oscillates between these 2 boxes. There is only 1 box at a time, but either it is this or this. So we don't know which is it at any time, right? It could be either this or this. So here we are giving 2 values. The idea is to match any one of them. Well, in the second example, I am matching only 1 value, right? So moving on. Now, how do we match with addresses? So here we can find either by addresses or by box IDs. Yeah, or we can do by both as well. So here the idea is that we have a value and we say pool addresses. So this is the pool addresses we defined, and the value is here, this. So that means it is going to match if the pool addresses are any one of them, right? And the second example says it is going to match if the pool addresses are any one of them. And finally, the matched address is going to be stored in a variable called found address, which is available for use in further computation, right? So here I'm not storing it, here I'm storing it. And in the third example, I'm finding boxes by ID. Yeah. So like I've defined addresses, assuming that I've defined a constant that has a box ID. The type of this will be a collection of byte or call byte in short. And here I'm saying that the value should be that ID. Yeah. So here, like I said earlier, yeah. So pool addresses, if you go back, it actually has multiple addresses, so it will match one of them. Yeah. And the actual matched address will be stored in this variable. We can also filter by registers. So filter by registers is basically a keyword registers followed by a sequence of register declarations. And what is a register declaration? So these are the examples of register declarations. Yeah. So for example, here we can see that a lot of things are optional. Here type is optional, for example, right? Example, what this is that the only register R4 is defined. That's all. Yeah. So it will match only when the register R4 of the box is defined. In the second case, it will match if the register of the register R4 is defined and the type is a collection of byte. In that case only it will match. The third example says that the box will match if register R4 is of this type and some value. Yeah, it should. So some call byte is another constant that I have defined some other place, right? Or it is some other variable basically. And the fourth example says that it will match if it is any of these, and the final name will be stored in the register. Yeah. So what will it store? It will store this the value of the register in that found register. Yeah, and that will be of type collection of byte. This kind of seems redundant because we are actually matching to some fixed value and then we are storing that same value. So obviously this is going to be exactly the value that was found, right? But as we shall see, once you look at the documentation, I'll not cover that here. We have multiple values as well, right? So we could have actually given a set of values here matching, and some call byte, for example, could have contained multiple values, and then this will be containing the name. The name will be having the actual found value, right? Like we did here, right? So that's the reason why we have both name and value in this example. Finally, I also will quickly describe how we match tokens. So it is similar to how we match registers. Basically, we have the tokens keyword and then followed by a sequence of token declarations. And a token declaration is any of these types below, right? So here, for example, I have just the first declaration just matches if the token at index 0 is there, yeah? So as long as there is a token at the first index, the box will match. The second declaration will match if the token at index, there is a token at index 1. So that means there should be always a token at index 0 and also at 1, yeah, because you can't have 0 empty and 1 filled. So this implicitly implies that index 0 and 1 are both populated. And whatever the value of at index 1, you just store it in found token ID, which I'll use later. Third example shows something similar where it says that index 1 must be populated. So this implicitly implies that 0 is also populated. And then it says that the amount of that token ID, I don't care what the ID is, as long as the amount of that token is less than 20, less than equal to 20. Yeah. So basically here I'm giving a value. 20 is actually need not be the value 20. It is just a variable, a constant with the name 20. Yeah. And it could be, ideally it should be the value 20. Right. And in this fourth example, as before, we are matching with the value and then the final amount which is matched. So as long as it is less than 20, yeah, so it could be 10. And this actual value is going to be stored in the variable called actual amount, right? The fifth example shows that ID index is optional. So index is not given. It just says that as long as this box has some, at some index, a token called token ID, yeah, and the amount, actual amount, then match this box, yeah. And the final example says that as long as there is a token in this box with ID, token ID, match it, and whatever the value of that amount is, store in the value actual amount, right? So quickly summarizing what I just discussed, constants. So here this is constants. Constants can have 3 fields. It can have name. It should have name. It must have 3 fields basically. So it will have name, which is the constant, that is name of the constant being defined, the type of the constant. And it should have exactly one of value or values. It should not have both, but it should have exactly one of value or values. Yeah. So here is an example of that. In the other declaration, names and values are both optional. Yeah. So other declaration have 2 fields, at least 2 fields. It can have more. For example, if you look at the declaration of amount, it has 3 fields. It is value and the third field is op as well, right? So anyway, quickly summarizing, other declaration can have name, which is optional, and a value, which is optional. Yeah, it is not having values. It is only having value, which is singular. Okay, and in the constants, right, what are the types possible? So the types are as follows, right? It can be int, long, collection of byte, group element, and address. So these are the current types supported in JDE. Coming back, so what does a name mean? So whenever I use a name keyword, yeah, for example, here I'm using name and here I'm using name. Name means that I'm going to define a new variable. Yeah, it's going to be something that is containing the value from a box extracted from the blockchain. Yeah, so it's an on-chain value. So for example, here this will be the value of the register, actual register from the blockchain. Yeah, and whenever I use the keyword value, it points to something that I've already defined earlier. Yeah, I'm not defining something new I've defined earlier. It could be an on-chain or off-chain, I don't care. So constants are, for example, off-chain variables. Yeah, and on-chain variables will be the ones that are fetched from the blockchain. Yeah, so whenever I use a keyword value, I'm pointing to something that is defined earlier, which can be on-chain or non-on-chain. Yeah, it doesn't matter, but it should have. It is not defining a new one. It is pointing to an already defined variable. Yeah. So to make things simpler, I'm going to call anything that defines something as a target. Yeah, it's creating a new target for other pointers. And whenever it points to something or whenever it uses the value keyword, I call it a pointer. Yeah, it is a pointer because it points to something, points to some other target. And a target is creating something for others to point to, while a pointer is pointing to some other target. Yeah, that's the way to look at it. Okay. So anyway. Yeah. So whenever we want to read on-chain data, we will define a target. Right? So whenever we want to read something from on-chain, we will create a target. That is, we will use the name keyword. And when we want to match something or we want to fill data, we will define a pointer. Yeah, that is, we will use the value keyword. So matching I have already shown you. What I mean by fill data? Well, fill is simply matching is used for inputs and filling is used for outputs, right? To be more precise. When I use the pointer definition in the input definition, so whenever I use a value keyword in inputs, it is going to be used for matching, right? So here, for example, when I used value, it is going to match when the R4 has the value of defined by the target some collection of byte, some call byte. And whenever I use the pointer in output, it is actually going to fill the data. So for example, if I had this in output, then it's going to create a register R4 and fill the value of this target here, there. Yeah. To be precise, this is how it's going to look. So both contain the keyword value, but when I use it in input, it's going to be matching. And when I use it in output, it's going to be filling. Matches and create. So filling is creating basically. Filling means creating something new. And another thing is that output cannot contain targets. Yeah, output can only contain pointers. So obviously you can't match in output. You can only create. And matching is, and you cannot define also something in output. You can only reference, right? There is no point in, there is no purpose of defining a new variable in the output. And Kiosk doesn't support that yet. Okay. So now the second intermediate manual work was doing some computation, right? So JD allows us to do basically 4 types of computation. One is the unary operation, which is of this kind of syntax. So it has name, the output of the operation basically. So here in this case, it's called my ergo tree. And from is the input to the operation, right? This is basically any existing target. Yeah, and op is the operation in the unary. So here, these are a list of operations, and you can refer to the online documentation for these, what these means. So proof delog is basically instruction that converts a group element to an ergo tree. Yeah? So here it's taking a group element and constructing a proof delog statement from it. To call byte is basically another operation that outputs collection of byte from ergo tree. Yeah, to long basically converts int to long, to int converts long to int, etc. To address converts ergo tree to address, and to ergo tree converts address to ergo tree. Now we have binary ops, which takes 2 inputs and an operation. So here I'm giving a variable, I'm creating a variable called a plus b. It can be anything, but I'm just using a plus b here. The first is a, the second is b, and the operation is add. These are the possible operations here in binary. Then we have something called post condition. So these are the conditions that must be true for the operation to be valid, right? So if any of them fail, then the operation will fail. The entire transaction creation operation will fail. Then we have branches, yeah, which allows us to perform, create boxes with based on certain conditions. So this syntax is as follows, and I'll not go into details here. You can refer to the documentation. So I'm going to show how to use JDE for timestamping a box. Like I showed earlier, how to use Kiosk for timestamping a box. So here in JDE, remember in Kiosk, there are so many manual steps. Here in JDE, there's only one manual step, which is to find the box ID that you want to timestamp. because obviously that the framework cannot know. That will be user-defined input. So this is the only step that the user has to do, which is the box ID to timestamp. Then he just create the script or just replace the box ID with your box ID into the script and paste it in the kiosk section of TX Builder and then click submit. So let me quickly go through the example I have shown here. So here, like I said earlier, I showed you the kiosk web frontend. Here I'm showing the kiosk web frontend from the web. Yeah. So here, this is the URL of that. And here I've created a session already, which has some ergs. This is the address that we'll be using to timestamp, or rather, this is the address that we'll be using to fund the timestamp. And this is the box that we will be timestamping. So here we can say this is the box ID of some arbitrary box. Yeah, this I've just taken from the Block Explorer, some random box. This is the only thing that we need here, because this will be data input. And as we can see, this is not spent, right? Because the spent transaction ID is null. So the box must exist, right? To exist for it to be used as data input. So I've done my homework already. So I've created such boxes. And let me quickly show you if there is any ergs in this. Yeah, so there is some ergs here. This is the address of the funding box. And let me also quickly go to the script. So here I'm going to show you the script, the JDE script that I'm going to use for creating this. So box ID is the only thing that I need to change here, and I've already substituted my box ID. So if you want to use your own box ID for timestamping, you have to take this script. By the way, this script is available on the Kiosk website, which I'll show once I have done with the demo. Right. So this is the box ID. If you look at it, I have pasted it here. The rest is some script, which I'll discuss quickly. So this is the emission address, the address of the box that emits the timestamp. This is the box that contains the timestamp. So this is simply the false script. Yeah, this is a non-executable script. It will never evaluate to true. This is the token ID of the box that contains the timestamp. This is the min token amount. So we want at least two tokens to be there in the timestamp emission box. Then there are some other variables I've defined, which you can look at it in the web page, in the source code. Here I've defined address. So now I'm matching boxes by, inputs. Yeah, let's look at the inputs. So here I'm going to match boxes. So the first input is going to be matched by address, and the value is the emission address. The emission address is this value. Then I'm going to check whether tokens. So the tokens at index 0, and I'm going to say whatever the the ID should be this token ID, my token ID. And whatever the amount is, yeah, you store it in that variable called input token amount, and make sure that it is greater than this min value. Yeah, this value. This is what this is doing. And whatever the number of nanoergs are there, you store it in this value called input nanoergs. And option strict, I'll skip here. I'll not discuss here. You can look at the documentation to understand what this does. But it is there to, it is always good to have it there. Here there is outputs. So here I'm defining the output. So the first output is the emission address, which is the same address that I had here. The index, the same token at index. And here instead of here I used the name, here I'm going to use value, which is the balance token amount. Now what is this balance token amount? Balance token amount is the output of this binary op, which is the input token amount minus 1. Right. And the nanoergs is the same as this nanoergs, yeah, which is the input. So I'm just copying the same value here. The second input is the timestamp box, which is the timestamp address. This address. The register as follows. The first register is my box ID, which I discussed earlier, and the type is collection of byte. The second register is the height, which is simply the value height. So height is the reserved keyword in JDE. Whenever you use the height, it always points to the constant, which was the height at the time the TX builder was invoked. And then I'm saying that it should have one token at index 0, yeah. And the min storage rent is some value that I want to keep in this token, so it stays for a certain time. And yeah, so here I'm going to copy this code, and I'm going to paste it in the TX builder. So here, basically, how do you get to this? So you go to this URL, and this wallet section has a method called TX builder. So here I'm going to paste this code, And I'll just select no for now, yeah, because I want to inspect the transaction first. So if everything is correct, then it will output a transaction that it wants to broadcast. So let's quickly inspect it, right? So this is the ID of the transaction, this is the input box ID, etc. This is the funding box. This is the data input. So see that this is the data input. And the output, this is the balance, this is the timestamp emission box, which has the containing the balance tokens. So if you look at the box, this will have 996 tokens, yeah, because let me quickly go to this box, yeah. So let me first copy the box ID script, then copy this box ID and then paste it here. Sorry, I used the wrong thing. It is this. So if you look at it, yeah, so this box is not spent. It has 996 tokens. So the balance is 995 and the token ID is the same token ID here. So this is the timestamp emission box. This is the box that is going to be spent. Yeah. And this is the data input. Yeah. And this is the address of the funding box. So this is what I will use to show that the new transaction has been emitted. So right now there are two transactions at this address. And okay, coming back here. So this is the fee. This is the box is paying the fee. So this is the fee box, which is paying a fee of this much amount. And this is the balance token amount, right? So if you look at it, there were 0.006. Sorry, this is the balance ergs amount. My mistake. So if you look at it, this has 0.006 ergs. And this you can ignore because this is just a copy of the input, the token emission box ergs. So here we are spending 200,000 or sorry, 2 million ergs in this token timestamp box, this many in the fee, and the balance is coming back to the as change. So let me increase the fee a little bit, right? I would like to pay a bit higher fee. So there is a option for fee, I believe, somewhere here. Let's hope that I didn't make any mistake here. I'll know in a second once I type this. Oh, sorry. So it should be a number instead of a string. So let's see now. Basically, I'm spending everything. I don't want any change. So this the fee box now contains this much amount, right? So everything is fine. I inspected the transaction. It is as before, except that there is no more change. All the change is going as fee. So this time I'm going to hit yes, click yes, and hit submit. So it should broadcast the transaction. So after a few seconds, we should be seeing this on the blockchain, right? So let me now refresh this. Yeah, so we see a new unconfirmed transaction, and we see that the transaction ID is the same as this transaction ID. And this is exactly the same thing I described earlier manually using Kiosk, but now we have done this using TX Builder. So I'll end my talk here, and please forward any of your questions.
Hey there, this is Robert Kornacki, Head of Research at Emurgo and board member of the Ergo Foundation. Today, I'm really excited to be here at the Ergo Summit and specifically talking to you on this topic of our grant program going into 2021 for the Ergo Foundation. I am joined today with Mark, who you may know from a previous talk in the Ergo Summit where he talked about Ergo-Bootstrap. How's it going, Mark?
Thank you, I'm good. Thank you for having me.
Always a pleasure. So, in this presentation, what we really want to hone in on is the fact that Ergo is really a grassroots blockchain. We didn't have $1 billion ICO, we didn't get 27 different companies, dev teams all joined together. We instead went the Bitcoin route. We started from zero, got a lot of great miners, we expanded the ecosystem, built tool after tool after tool, and now we're getting to a point where we have this solid foundation, right? Where we're not just, you can build on top of Ergo, but learn 26 different parts and figure out the code based off of, very lukewarm or crappy documentation. We're actually getting to the point where, I've built a Ergo Headless dApp framework. That's an entire framework that allows you to go from zero to, let's say, accessing Oracle pool data within 3 to 4 lines of Rust code. Before that would have taken you, let's say 100 to 150 lines. And so we're getting to the point where this key essential tooling is getting user-friendly, right? And so if you want to create a dApp today, or you just want to create a normal app that say uses Oracle pools, you can, write 10, 20 lines of code and you already have access to Oracle pool data. Soon we'll have other headless dApps released, and so you'll be able to do a lot of these things where rather than, a year and a half ago when we launched mainnet, none of this stuff was possible, and if a contract got posted on chain, if you want to read state of that, it was really challenging. And other cases, so that's really on the developer end of tooling, for smart contracts. What you did, Mark, with Ergo-Bootstrap is really another part of that, right? Where I guess it's one step removed, where if someone is a user or also a dev and they want to run their own Ergo full node because they want great security, or they want their own front end or back end for the Ergo Explorer, or maybe the Yoroi backend, that was really enabled thanks to your project. Do you have any extra words just to kind of summarize what that project was if someone missed your other presentation?
Oh yeah, so basically Ergo Bootstrap is just like a toolkit that allows you to set up Ergo Blockchain cluster, what we called. So basically it will allow you to set up those different components. So you don't really need to be a full stack developer anymore. For example, if you want to focus on the front end, you can just bootstrap the node and maybe the API and just focus on the front end itself, which is something that is also really encouraged with the headless apps that you mentioned as well. Or maybe you just want to set up the Explorer and want to focus on the backend. So I think this really allows you to be flexible, and you don't really need to be that full stack sysadmin. Like, you don't need to know everything like with other blockchain projects, right?
Right. Yeah, so that's really the angle we've been looking at for grants, where we want to, from the grassroots up, not just bring in some really big company to, patch in all the holes, but we want to give grants to people who are part of the community, who actually see value in Ergo, see a future for Ergo, and so, it's beneficial for us. We're improving the ecosystem by giving out these grants, but then the ergs are actually going to people who care, right? And this is kind of something that I won't be accusatory, but this is something that a lot of blockchain projects, they seem to not really care about, right? Because it's all very money, profit oriented. No one really cares whether their grants or how their incentive schemes are set up actually go to users who want to use it, or if the tokens end up at some speculator's hands who will dump it the second they get a 33% return or something. We really don't want to encourage giving out big grants to people who just don't care, because we think this is a great project. And so what we want to do is really start bottom up, give grants to small people, individual people rather, small groups, and whether it's a blog post that's really well detailed and it covers a topic that we at the Ergo Foundation haven't explained enough about, and it really brings out a whole new understanding for your everyday user, how something maybe like Sigma protocols works. Those kinds of things we're really excited about. And also, for example, with translations. If someone's a really great translator and they want to translate some of the content, we're very happy to give out grants for that. We're also very excited to bring in developers who may not either understand blockchain entirely or may not be experts in Scala or Rust. But if look at the issues in some of our repos, you may notice that some of them have a bounty, right? This is kind of a mini form of a grant, you may say, right? So if you fix some sort of formatting error that we have, or if there's a small function or a method that needs to be implemented, or there's some code that needs to be fixed, you can go check out the issues, write some code within 20-30 minutes sometimes, and maybe you can make 50 to 100 ergs, or 200 or 300, depending on the bounty. And we're really right now looking at this multi-pronged approach of how do we both disseminate a lot of ergs to a lot of people so that we can get this excitement and really base level movement of people who know what Ergo is, actually care about Ergo, have a lot of ergs, so we have really great dissemination, so we don't have this centralized holding of all the coins. And how do we transfer this into momentum? Because going into 2021, I think it's obvious to a lot of us, there's a lot of excitement with Ergo. Just looking at the community, say 6, 7, 8 months ago, I think we've at least tripled, quadrupled, five-tupled maybe even. And that's pretty exciting, right? And with this Ergo Summit, where we're announcing a lot of things, showing off a lot of new pieces of tech, there's just a lot of momentum, as I said, that we want to try and channel. And the grants program is really a part of that. And so, from your perspective, I was wondering, Marek, can you kind of give a summary of your experience? So you told us about Ergo-Bootstrap, what it does, but that's not the whole story, right? And so I was wondering if you could tell people, what was it like writing your grant application? How did, was it challenging? Did you have to write 27 pages, create an essay to explain to us? Was it, short? And also, what was the process like of going through the grant? Like, was it easy for us to pay, actually give you the ergs after you succeeded? Because I know in some places in the blockchain world, people, do projects and then getting paid out. It's not always the easiest thing on earth. And so what was your experience like?
Yeah, I think it was really pretty straightforward. It all started with a discussion, I think, on the Discord server. And we really came up that quickly that it would be a really nice solution to have for the ecosystem itself. And someone on the forums, I think, suggested like, hey, you should probably apply for the grant. So I reached out to the foundation, and it was actually really pretty straightforward. The summary was probably just one short page with the step and deliverables. And after probably a week, I got back with some basic questions about how the final product would look like. And from them, it was really straightforward. We agreed on actually some payment terms, so there was part of it upfront, and then after the delivery of the project, which is, I think, pretty standard in most of the grant schemes or how to call it this process, right? So I really would encourage. I know that it may sound intimidating to apply for a grant, but it was really easy, and I would encourage everyone to do it. Maybe even if you just have an idea, just maybe go to the forums and to the Discord server and ask people. Maybe there is someone else that could implement your idea, right?
Right. Yeah, one of the great things about the Ergo ecosystem right now, and also to some degree you could argue for the entirety of the extended UTXO world of blockchains, currently being, Cardano and Ergo, is that really right now we're starting to get to the point where we have all of the tech starting to be in place. And so now there's a lot of benefit and a lot of, apples to be picked, a lot of fruits. Because with the base developed, it's not as challenging to, take 3 steps forward, come up with a whole new smart contract protocol, a dApp, some sort of new piece of tech on top of the software. All of this is really within our reach. And we, as, the Ergo Foundation and the core devs behind Ergo, we see there's so many different things to do. And also, there's a lack of ability to pursue everything because, we're a finite set of people. We're really trying to do our best to make Ergo as attractive as possible. But there's still like 18 different projects we have in mind that we could go into. And so also in the opposite direction from what you were saying, Mark, if someone doesn't have the ability to pursue building something, but they have an idea, that'd be great for them to submit a grant. But also, if someone is, say, really technical, a great developer, but for whatever reason they don't have an idea, we'd also be very happy to talk with you. So feel free to come into the Discord and, maybe we can be the middleman who takes someone else's idea and, offers it to you or gives you a list, or, we have some other ideas in the back of our heads too. And so we're really more than happy from both sides of that angle to help out people who come up with ideas, who need ideas to, develop on. And so we really think that there's so much potential for all of this. And so no matter if you're super technical, not technical, you want to just create a small blog post, or you want to create, the best DEX or new dApp that uses Sigma protocols, Oracle pools, that builds it out as a headless dApp and, goes crazy, full stack, every technology known to man that we have on top of Ergo-Bootstrap and so on forth. No matter which side of the spectrum or anywhere in between you are, we'd be very happy to have more people contribute, and we are willing to give out grants to help support everyone and anyone who can really produce a value within the ecosystem. We do think that grants are a great opportunity, not just in giving people the option of building on top of Ergo, but also to make it feel more like they're part of the project, right? And this is something we really want to cultivate, where a lot of projects, you have a big divide, say, between the core devs, and, they guide everything, and they're this bubble that acts as, whatever, semi-dictator of where the project is going. We understand at the Ergo Foundation, we're trying to help this project grow, but as I mentioned, we want to kind of disseminate not just the ergs, not just the development, but also have people feel like they're part of the project. And we're really taking decentralization seriously. We don't want to be the dictators, forever and ever, and we're not really dictators right now. We want more people to submit their opinions, take part, join in building this project. And so we're also trying to facilitate this, where if more and more people understand the tech as a whole, understand where everything is going, then their opinions will be able to also be, taken into account. And the more and more technical people we have, the more people who are building on top of Ergo, then with the more voices we have, and that actually allows us to be more robust, right? Because we're not just listening to, me, Alex Chapernoy, Amitabh Saxena, and a few others who are guiding development. But then, we can have more and more people creating Ergo improvement proposals and building out a true robustness, not just on the dApp level, but also on the protocol level. And so, suffice to say with all that, we really do think with the grant program, and potentially with some other ideas that we have coming Q1, Q2 of 2021, so stay tuned. More is to come out in the near future from the Yoroi Foundation. But with all that said, Our push for the grant program this year is really focused on helping everyone get into building Ergo grassroots up. And so if that interests you, I really, really highly recommend, just like what Marek was saying, that you come on Discord, you can pitch some ideas. I believe we have a grants program Discord channel, so that's the best place to talk about it. We'll, within a few hours or up to a day, we'll get back to you, and we can really just start a conversation. And maybe if you have a project idea, let's say it's slightly out of scope for you, maybe someone else will be interested. And so you'll be able to, join together, start to build teams, get to know other people, and really build this grassroots movement to try and take Ergo to the next level. And so, Mark, if you have any last words about any of this, feel free.
Yeah, I would probably just to highlight what you already said, most about documentation. It may appear that actually the technical stuff is the most important, but good documentation and resources can have as much as impact as any technical change for the community itself, right?
Right. And so, related to that, that's a great points that I passed over, Mark. Do you see personally any piece of or any area where documentation is the most lacking, where someone's interested to jump into this? Where would you recommend would be the first place to go to or the first thing to target?
Yeah, I think like any documentation can be improved. There is what is really nice is like in Ergo you have so many different projects, like from Explorer to the node itself, or even like Ergo-Bootstrap.
Right.
So I would say like pick whatever feels like the most fun for you and go from there.
Totally. That's a really great point. Without documentation, it's hard to onboard more developers, and so, it's a chicken and the egg problem. But it's something we're addressing, and if anyone wants to help us address this faster, we're more than happy to give out grants for this as well. And so with all of that said and done, thank you very much everyone for watching. Thank you, Mark, for taking part in this presentation. And like I said, please submit your grant applications, and hopefully in 2021, we'll really start to see an awesome move forward for everyone in the ecosystem, from small users who can build small projects all the way to really large and awesome dApps. Thanks, everyone.
Thank you.
Hello guys, Kurstis here, and this talk is going to be very excited, at least for me, because I'm going to reveal the roadmap for the Ergo ecosystem 2021. And let's start with a disclaimer. So, as a reminder, Ergo is about community-driven approach. Right, what does it mean in regards with development? That developers are coming and living. Many developers are working part-time, some developers are anonymous, so it's hard to say. Well, sometimes they're coming, sometimes leaving, but maybe it's the same developer after all, so who knows about those anonymous developers. Alright, so all those things do mean that there is some instability in regards with development. Right, so you need to consider this. Well, actually, big corporations as well as small startups are also unstable in regards with deliveries, right? But here, as decentralized community, we also have specific instability because of the nature of the community. Alright, also please note that there are new partnerships which are coming, will be announced in 2021. There is always new research appeared around or done by us. There are also some new trends which will appear in 2021. Some of them are predictable, some not. And all these things may change development landscape also. Hopefully with a positive impact. Alright, and in regards with development, so let's break it into different layers, right? Then it would be simpler to reason about development efforts and the roadmap. So let's have the following layers. So the core protocol with research and development around it. The reference client, which is implementing the protocol and often consider it as a protocol. Then there is some basic infrastructure for developers and the users like wallets, libraries, monitoring tools, and so on. Then there are applications. So currently the most of efforts in regards with applications. Finally, I'm very happy about that. So finally we are mostly talking about applications, which means that previous layers are more or less stable. And so as applications are reworking well and solving some real world problems, right, and reworking the real economies after all, hopefully. Then we can talk about social impact, right? But I'm going to exclude any thoughts about that from my presentation. So let's discuss this in community chats. This would be an interesting talk, I believe. Alright, so let's start with the core protocol. The core protocol is more or less stable, right? So no any revolutionary changes are expected, only evolutionary ones in 2021. So the main directions for 2021 are improvements in networking layer for improved efficiency of the nodes. Then higher throughput of transactions by first doing research and then implementing some sub-block confirmation protocols. Also, we will research and maybe develop, if needed, some side chains, so first side chains for scalability and new features to be tested in side chains first. or maybe some features will be just incompatible with the main chain, then it's better to launch a side chain for that. Alright, and in regards with contractual level, so there is an update coming, so update for the Ergo tree interpreter, and more specifically costing of the scripts. So simplified costing with high performance, and also a few new instructions are coming. And for all these things to get done in the core protocol, hard forks are not needed. Hopefully, so there is one soft fork expected in 2021 for the contractual level upgrade. So fourth point in the list, simplified costing and new instructions. And other changes will be done via just Velvet forks, hopefully. So in regards with terminology, for soft fork, majority of mining power, 90% of mining power support is needed to activate changes. And for Velvet forks, this is not required, so any support from miners will activate changes. Right, and for networking layer, so we just need to update the nodes, and all nodes will work in the same way. Okay, so what are the goals for the changes planned? So the goals are following, higher throughput and improved scalability of the protocol. Alright, and also interoperability, when we are talking about sidechains. Alright, so then talking about reference clients, so the Ergo node. There is some ongoing work we can do for many years ahead, right? So especially about profiling and efficiency improvements, right? So a lot of work already done, and a lot to be done. But there are also two major changes planned. So in the first place, NIPOPO-based bootstrapping, which means you don't need to download all the headers in order to bootstrap a node. In some cases, right? So if you are going for fast bootstrapping. And also possibility to bootstrap with UTXO snapshot, which is corresponding to fast modes in Geth client for Ethereum, or warp modes in Parity client for Ethereum, now abandoned. Alright, so what are about goals here? So the main goal is possibility of bootstrapping within a few minutes. If you are going with a clean wallet. Alright, and yeah, so still such bootstrapping should provide the same security guarantees as full node, with very negligible probability of difference in results. Alright, and then yeah, also improved scalability, right, is also the goal, definitely. So we need for improved scalability and for higher throughput of the nodes. In regards with infrastructural part, so let's start with new wallets which are expected. So, as you may know, there is a partnership announced in 2020 with Cypra Wallet, and Cypra Wallet is privacy-oriented mobile wallet with atomic swaps. So recently they launched the first release with Bitcoin support, and Ergo is going to be cryptocurrency number 2 they are going to support. So it's already in progress, and hopefully in 2021 we will see Ergo in these mobile wallets hopefully also with support for mixing and atomic swaps with Bitcoin. Also, we need for Ledger or Trezor finally, right? So there are a lot of talks in the community about need for that. So there is a grant from Ergo Foundation assigned many months ago for Ledger support development, and yeah, still it's not there, and hopefully somehow in 2021 hardware wallets support issue will be resolved. Alright, so there is another wallet coming, ergowallet.io, which is desktop wallet with support for custom tokens and improved privacy. So it's already supporting custom wallets, and it's already about improved privacy, so it's using new change and addresses all the time. And in comparison with Ergo Mixer, it provides you very improved privacy. Right, so you are using new addresses all the time, and if you are using Mixer on the way also, so that's pretty good story. Well, unfortunately, this wallet is still pretty raw, so you can install it and play a little bit, but please do not store any significant amounts there. So hopefully in 2021 it will become mature enough for holding ERGs. Alright, so as you may know, there is old wallet Coin Barn, which was withdrawn from Chrome store during some updates and not republished, and actually developer abandoned development of the Coin Barn wallet. But now, well, there are some guys in community willing and able to maintain it, and also there is agreement with previous developer that the Coin Barn will be republished in Chrome store. So then it will be available for general users again. And Coin Bar is simple and actually pretty good wallet for Ergo with custom wallets support also. Alright, so talking about tokens and interaction between wallets and applications. So currently the most urgent thing which is needed is token support in Yoroi, and hopefully it's coming, so maybe by Ergo Summit you will see some news about that. And also there is a standard for interaction between applications and wallets, EIP 12 standard, and it's going to be implemented first between Yoroi and decentralized applications, right, interacting with Yoroi. And yeah, also stay tuned, so by Ergo Summit maybe there will be some news already. Alright, so in regards with libraries application developers are using, so the main topic for 2021 still is about finishing Sigmaverse, which is alternative implementation of contractual level in Rust language, so it provides possibility to build applications on top of Ergo contracts in different platforms, including mobiles. So there are many other libraries in JavaScript, TypeScript, Java, and so on. Alright, so for 2021 we need to improve them and do more documentation and yeah, attract developers. So this is the very critical need to attract more developers into the community. Alright, so then in regards with infrastructure support, there is Ergo Bootstrap tool you can use to bootstrap your nodes and also explore instance in minutes. So hopefully in 2021 it will also support Ergo Mixer out of box and so on. Right, and also building process and maybe binaries will be published for the nodes, and also reproducible builds are needed. So yeah, these things will be done in 2021. Alright, so then applications. So main focus on applications these days. Right, and this is the most visible part, and this is the part most of the users are interested. Right, so most of the users do not run full nodes, unfortunately. Maybe. Right, so then about applications, so the most critical need is to launch what I'm calling a liquidity machine. Right, so some applications stack which is needed to get liquidity on top of the Ergo blockchain, and then do trading, right, and also use the liquidity coming from other blockchains issued on top of Ergo blockchain in applications. Alright, so the minimum set of applications in the liquidity machine is about stablecoin. Right, so AgeUSD is coming, and a lot of talks during the Ergo Summit about this protocol. Then Ergo DEXs are coming, decentralized exchanges, so there will be many of them. And yeah, first one maybe will be announced by the summit. Right, Ergo Swap, which is kind of Uniswap on top of Ergo. And there is work with Gravity guys on gateways to provide different tokens on top of Ergo from other blockchains, and also to provide Ergo token on other blockchains. So it's kind of interoperability solutions. Right, so yeah, in regards with DEXs, so in the first place Ergo Swap will be done because, well, it's simpler, right? It's simpler to develop it in terms of UI. It's also simpler for users. And yeah, such Uniswap-like exchanges are now popular on top of different blockchains. Right, then some classic DEXs with order books will come also. So contracts are done, and also matching service is done. Some testing is needed for the matching service. Right, and then UI is needed, and yeah, so for order book DEX UI is a pretty complicated thing actually, so that's why Ergo Swap will be launched first. Alright, and then we can think about DEXs with smart orders. So usually it's about some specific applications like token sales. So there are some examples of smart orders already available, like token sale orders with buyback guarantee and so on, right? So hard to say how UI will look like for such dexes even, right? So it's very a new beast in the zoo, so let's see how it goes. Hopefully in 2021. Right, and what's good about Ergo is that all these kinds of dexes can be composable for free or almost for free. So I'm going to make a standard on DEX contracts. So we will have different contracts, right, for DEX orders, and then standards will compile them and provide some notes on compatibility of these contracts, right? But it's already tested that Ergo Swap is compatible with order book dexes, which is really awesome, right? So then you have shared liquidity between different types of dexes. Okay, and so dexes are about getting trading on top of the Ergo blockchain without reliance on third parties. Right, and gateways are for delivering liquidity from other blockchains and also providing Ergo and then custom tokens like stablecoins and so on from Ergo to other blockchains. Right, and for that we have partnership with Gravity. So with this partnership and with gateways which are already in progress, we will get USDT, USDN, USDC and so on, Bitcoin on top of Ergo. Right, and we will get also eventually Ergo on top of Ethereum, Binance Chain, Waves, Tron and so on. Right, and then we will have different kinds of USD on top of Ergo, so AgeUSD and USDT, USDN and so on, right? So with USD liquidity pools on Ergo, we already can start playing with liquidity pools, liquidity mining and so on, right? So those liquidity games will be started. So more about tokenomics. So what's expected for 2021 is that tokenization will come for income flows for Ergo Mixer. It's already announced, by the way, by anonymous developers of Ergo Mixer. So maybe Ergo auctions will be tokenized also, as well as other applications, right? So tokenomics is coming for Ergo applications which are doing some profits. Right, so then hopefully we will see some improved token sales mechanisms associated with tokenization of those applications and more. Right, so a lot of experimentation is going on these days in regards with improved token sale models. So I can mention things like augmented bonding curves and continuous token offerings and so on, right? So a lot of experimentation in this field, and hopefully Ergo tokenomics will also play with improved token sales mechanisms. Alright, so hopefully we'll see more NFTs on Ergo auctions and not only. And well, I'm pretty sure that with tokenomics appeared, so community will invent more and more schemes involving tokens. Alright, then in regards with privacy, what can be expected is that we will see some applications on top of Ergo Mixer. Well, it got API very recently, like 2 weeks ago, so 2 or 3 weeks ago. So yeah, so now it's possible to build applications on top of the Ergo Mixer, and I guess we will see some applications this year, and this is pretty much excited, right? So you have the whole stacks on top of Ergo. So there is Ergo, right, with core support for cryptographic protocols. Then there is Ergo Mixer on the application level, which is implementing some cryptographic protocol on top of the Ergo blockchain. And then there are applications which are using Ergo Mixer, so the third layer here, which is pretty much exciting. Alright, and we will see stable coins mixing as stable coins are coming on Ergo. Right, we will see stealth addresses being used, hopefully. Right, maybe in combination with mixing pools even. Right, and with Schnorr signature coming to Bitcoin, we can have private swaps with Bitcoin and other cryptocurrencies which do support Schnorr signatures, and the elliptic curve used in Bitcoin and Ergo. So there were some examples of private swaps already done on top of Ergo. Well, with Bitcoin Cash, I guess. Right, and yeah, so after soft fork coming to Bitcoin with Schnorr signature support, so it will be possible to do private swaps with Bitcoin. So maybe this year we will see them in action, but it depends on Bitcoin developers also. Alright, so another thing, and now it's getting closer to social transformation. So this topic is about crowdfunding and alternative financial systems. So hopefully this year first local exchange trading systems will appear on top of Ergo. So some community members are huge fans of such systems, and well, if we imagine constellations of local exchange trading systems, then it's providing kind of good implementation of original Ripple idea, basically, but also on top of the Ergo blockchain. Okay, and there is well one service for crowdfunding, ergofund.io, which is unfortunately delayed, and yeah, hopefully will be launched in 2021. Alright, and well, what I described to the moment is pretty modest plan, right? So it's not optimistic, well, also not pessimistic, but not optimistic as well. And yeah, with growing community, much more can be done. So what community can done, right, and it can be profitable in many cases, is standard DeFi stack in the first place. So lending, options, bonds, contracts for difference, prediction markets, and so on. Right, so as Ergo is proof of work blockchain, so we can expect some contracts on mining hash rate, maybe. So tokenization, as I said before, we can expect a lot of tokenization schemes to be invented and tried by community members. So yeah, there are already some folks in the community willing to use Ergo for transformations of some communities, the economic life, right? So hopefully we will have more with a growing community. Right, so contributors very much needed, and yeah, we are slowly growing. I mean, Ergo developers community is slowly growing, and currently we have everything to get new developers into developing on top of Ergo pretty quickly. So we have libraries, tutorials, Ergo scripts by the example. We have Headless dApps framework, and more and more. And yeah, there is also templates for an application which will be published soon, but there are already some applications which can be used as examples, like Ergo auctions and so on. So all the applications which are already running are open source. That's it. Thanks a lot for your attention, and stay tuned for updates.